Okay, good morning. Find your seat. We're nearly ready to start. So, good morning. I'm Wolfgang and I'm chairing this session together with Doris. Please keep in mind the session is recorded and the code of conduct applies. As first speakers, we have from Nokia, Carl Montanari, and from OVH Cloud, we have Simon Pecor, and they are talking about simulating network at scale with Kubernetes and OVH Cloud. Stage is yours.
So hello, I'm Simon from OVH Network Engineering. And today I'm very happy to talk to you about how we've been simulating networks in the few months with Kubernetes. But first, I'll let the stage to Carl.
All right. Yep, so I'm Carl Montanari. I created Kubernetes. And so really quickly, I'll go over our simple, very straightforward agenda here. I'm going to talk for a couple minutes about kind of Kubernetes, where it came from, why it came to be, what it is, a little bit about how it works. And then I'll turn it back to Simon to actually talk about using this thing in kind of the real world and using it in anger. And hopefully we'll save some time for Q&A. Alrighty. So to start the kind of Kubernetes story, we have to start at the beginning with Container Lab. I know it's early, but maybe I could get like a show of hands who's familiar with Container Lab, maybe used it a bit. Okay. That's great. Yeah. Sure, Roman's heart is filled with joy seeing that, so that's really good. So Container Lab, for anybody who isn't familiar, is a great tool. I'm going to gloss right over the top of this really quick, high level. Definitely recommend you check Container Lab out after the talk. But Container Lab, in a really simplified nutshell, is about building declarative, shareable, repeatable network topologies. And as you probably can guess from the name, or obviously a lot of you already are familiar, this relies pretty heavily on containerized network operating systems, so something like Nokia SR Linux, Arista CEOS, something like that. But we can also support virtual machines like your Nexus 9K, XRV, VMX, all of that kind of thing using Roman's fork, VRNet Lab. And so Container Lab in a nutshell is free open source software. It's got a very batteries included, user-friendly kind of mentality to it. And in general, it's very awesome. So once you have Container Lab and you have your containerized network operating systems, either just natively containered or packaged up, you're now able to kind of build network topologies using Container Lab. So you define these topologies in a very straightforward YAML file, nothing too crazy here. It defines the nodes, the links, some other kind of goodies like that. And then you use Container Lab to spin this up in Docker on your local machine or on a virtual machine, somewhere, obviously with Docker running. And this is really great, and this is kind of what makes Container Lab repeatable and shareable, is that we have this declarative config file, we build the topologies in Docker, Container Lab handles all of that orchestration. And so if I have a topology, I can share it with Simon, and we can have the same experience at the end of the day. Obviously, this is really useful. But there can be some problems with this. So what happens if you want to emulate a very large topology? Or you have like some very resource-hungry network operating system like XRV 9K or something like that takes a bunch of memory to boot. This is obviously problematic, right? Because if you're on your laptop, you're stuck with your laptop. If you're on a cloud VM, you can keep paying more, but obviously at some point that becomes cost prohibitive and you kind of don't want to do that. So what do we do? Well, Container Lab has kind of hooks or ability to do multi-node topologies, which is a really useful feature. And basically what you have to do is you separate your Container Lab topology and you use VXLAN to kind of plumb tunnels between these kind of sub-topologies that you split up and spread out across multiple compute nodes. This works, absolutely works. It's a little bit error prone, it can be a little tedious. You should definitely automate it, but obviously that's its own kind of challenge. And this kind of leads us to the question of, what if there was some kind of magical compute system that could scale out and, yada, 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 right? It's a very useful thing. And so Kubernetes enters the chat, or Kubernoodles if you want to be a child like me. Last audience participation in the morning here. I know it's early, but maybe another show of hands for who's familiar with Kubernetes. Okay, probably lots of hands. That's good. That's great. Yeah, Kubernetes is obviously a very popular, very big project. In a nutshell, again, this is a container orchestration platform, so we're obviously talking about containers with Container Lab, so Kubernetes is kind of an obvious segue here. Its main purpose in life is intelligently scheduling these workloads that you have across some amount of compute, which is really handy. And it's very extensible in kind of a lot of ways. But the two that we care about in particular are custom resource definitions and controllers. These are kind of silly words or fancy words, but the custom resource definition thing means we can have some open API spec. We can load that up essentially to Kubernetes. And now the Kubernetes API server supports CRUD operations on that resource that we defined in this open API spec. And a controller, or you may also hear operator, kind of an overloaded term as well, is basically just some code that's running and that is usually interacting with these resources that you create. So why Kubernetes, like generally, and also for Container Lab? Well, generally, I mean, obviously it's very popular. Everybody pretty much raised their hand, say, yep, we're familiar at least with Kubernetes, at least a little bit. It's prevalent, it's everywhere. You can run it on your laptop in Minikube, Docker Desktop, Kind, whatever. Even if you're not running it in your organization, you're probably like a click away from running it because you're in some cloud like OVH that has a managed Kubernetes offering. So you're very close to it, even if you're not already doing it. And like on this previous slide, we talked about we have these containers. Maybe we have too many containers. Where do we put them? We need to spread them out. Well, that's literally Kubernetes' job. That's it. That's its whole purpose in life. Obviously oversimplifying, but in general, that's what it's all about, right? Of course, we want some cool points. I don't know if the Kubernetes like hype train is still rolling, but if we can get some cool points from it, we'll take it. We didn't go full cool points. Kubernetes is written in Go. If we wanted full cool points, obviously it'd have to be in Rust, but we didn't do that, so we'll just have to take the Kubernetes one. And then the last thing about Kubernetes kind of specifically is once you have this Kubernetes API, you can deploy to that API kind of wherever that API lives, right? If it's on-prem, if it's hosted, if it's self-managed, if it's whatever. This is the same experience that we have with Container Lab and Docker, where if I give Simon the topology file, he can run the same topology, same experience that I have in my Docker on my machine. So Kubernetes is basically extending that. So obviously this is kind of relevant to Container Lab in this story. So if you hadn't already kind of put this together, we had Container Lab or Collab and Kubernetes, and now we have Clabernetes because I'm terrible at naming things and I'm sorry for that. I also named a thing Scrapply for Scrape CLI, so clearly this is a trend that's bad and I should like fix it, but here we are. So Clabernetes is basically exactly what you kind of would expect listening to me so far. About a year ago, I was talking to Roman, and I've been a long time Container Lab user. I've been doing a lot of Kubernetes stuff, and I said, why don't we just run this in Kubernetes? Like, seems like a good kind of marriage. And he said, yeah, you crazy person, go ahead and build the thing. Sounds good. So I started doing exactly that, and kind of here we are. So the main goal of Clabernetes is Container Lab that we know and love. Big thanks to Roman and Kareem and Wim and Marcus and all of the contributors to Container Lab that have made it an awesome tool. We just want to scale it out. So that's the main primary goal of Clabernetes. We also want to be able to install it in any Kubernetes cluster. There's a big asterisk here because of course, access control, security, blah, 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 can make this a challenge. But in general, if you have a vanilla Kubernetes cluster, you should be able to install and run Clabernetes. Keeping with the kind of batteries included, friendly user experience of Container Lab, we want to bring that to Clabernetes. So we try to make it so that, the happy path for network folk like ourselves, you don't have to be a Kubernetes expert. You get into troubleshooting, you might have to open Pandora's box a little bit and things get a little hairy. But in general, you should be able to get a basic understanding of Kubernetes and get your network topologies modeled in Kubernetes and running and connected to and all that good stuff. And last point really is hammering home the first, which is this should just work with Container Lab. We're talking about Container Lab because I love Container Lab. Hopefully all of you do as well. And we just want to run it in Kubernetes. That's the whole point. So we want to take your existing Container Lab topologies and have no mess, no fuss, put that into Kubernetes. And then how do we go about doing this? Okay, so like the design, the idea is be dumb smartly or be smart dumbly or some combination thereof. Keep it simple, stupid if you want, whatever you want to say. But just try not to be clever, right? We love Container Lab. This is about making Container Lab scale out. Let's use Container Lab wherever we can. Let's be simple. Let's not try to overthink this. Just keep it simple. And then, of course, we want to do standard Kubernetes things, right? A lot of this we don't necessarily want to expose to like the networking kind of folk that don't need to care. But for maybe you have a Kubernetes admin team, we want this to look and feel like a normal thing that they would install in a Kubernetes cluster. What that really means in real life is it's a simple controller, very standard stuff. It's written in Go. It's deployed with a Helm chart, nothing crazy. You can love or hate Helm, but as a user, it's a pretty common experience in Kubernetes land. We have few, and I think simple CRDs or custom resource definitions. This is part of that extensibility thing we were talking about. And there's only 2 of them, and you only have to care about one. So I think that's pretty simple. And then we have no additional CNI or cluster requirements. It should be able to install in any cluster. I'll try to hurry up a little bit to give Simon time. So here on the screen, we have a topology definition. So this is that custom resource that I was talking about. Inside of it, well, there's some Kubernetes junk, API, metadata, yada, yada. Normal stuff if you're familiar with Kubernetes. Inside of that, you'll see the spec definition container lab. This is a totally bog standard container lab YAML definition, nothing crazy. If you can't be bothered to do the Kubernetes part, there's another badly named tool, Klabverter, that can convert your container lab topology into this Kubernetes-ified Kubernetes topology CR. Once you have this, you can apply it to your cluster. The controller, just some Go code, basically then reconciles against this, another silly Kubernetes word to just say we run some function when things happen to this resource. That controller basically takes this topology definition, chunks it up into subtopologies, which is a node from your container lab definition per subtopology, divides them up, makes Kubernetes deployments, connects them with VXLAN, and now you have a running container lab topology. If you have a load balancer in your service or in your cluster, which is really common, we'll also expose that each of those nodes with the load balancer service, so you can SSH, Telnet, if you have Telnet, GNMI, whatever, to your devices, just like normal. And then last point here, the main point is we try to be sane about updates to these definitions, because obviously these containers can take a long time to boot. They can have a lot of resource, which can have a lot of churn. So we try to intelligently manage what things we update and when. So we won't, every time you make a single update to the topology, we don't just like nuke it and redeploy the whole thing. So we try to be good stewards of kind of our resources. That's all I have time to talk about. I probably went a little over, sorry, Simon. So Simon's now going to tell you all about using this in the real world.
Yeah, thank you, Carl. So let me tell you some backstory about how we use Kubernetes at OVH in the first place. So on a cloudy day in September of last year, I set up a meeting with my team to talk about all the struggle we had with regards to virtual labbing. So we were having scale issues and also a lack of programmability of our labs. Basically everything Carl just described. And so after hanging up with a call, and we did not have a really elegant solution to this, I read on Twitter that Roman just announced 2 hours later, actually, the release of Kubernetes Alpha. So it was a bit of a no-brainer for us that we had to reach out to them and to start working together on this. So first, this little disclaimer before I start. I will be using some cloud products in this presentation, and of course, I will be using OVH products. But you will be fine running any cloud provider of your liking as long as they offer the same services. So to create a Kubernetes service in a cloud provider, it's pretty simple, at least at OVH. You select the location of your cluster in terms of data center and region. You select the beefiness of your node in terms of CPU and RAM and storage. The node pool size, which you can also tune up later if you need more resources or less resources. And a few minutes later, your cluster will be up and running. And so it's ready to install. You're ready to install Kubernetes. Either though, you don't need to know Kubernetes in much detail, but you will need some tools on your local machine, starting with Helm. So Helm is a templating engine for Kube, and kubectl, which will be your local API endpoints to communicate with your cluster. So you give kubectl a file called kubeconfig, which contains all the credentials and location of your cluster, so you can communicate with it easily. Then Kubernetes is available on GitHub, and Helm is able to fetch directly all the last version of the deployment on it. So here is a CLI. So you just call Helm with the GitHub URL. In my case, I also pass on some custom values in the YAML file, which is used to specify resources for each network OS vendor. So for example, Cisco IOS XRD is going to require that much of RAM and CPU and so on. So that when Kubernetes will do its scheduling across the nodes, it will do it in an effective manner and you don't run out of resources. Then a few minutes later, you have your Kubernetes manager running on your cluster, ready to host topology from Kubernetes and Container Lab. Another very important component that I installed is a registry. So it is used to store all your images from network vendors in any version of flavor that you want. It's especially very handy if you have a large number of topology across your team. You can just reference them in a topology from a central place. Very easy to spin up. You basically just set up the name and the storage requirements, and you can get going pushing your images on it. At OVH, we use infrastructure as code to generate the configuration of the routers, which is based on Jinja. I don't know if any in the room are familiar with Jinja. So Jinja is basically your configuration with placeholders all over the place that you can replace with data from JSON and YAML and so on. This is all stored in Git, so we can have peer reviewing and release management, which is very handy day to day. We have a component called CI/CD component called CDS, which is open source by OVH, which will watch this Git repository for any changes and will compute the configuration automatically. So that's fine, but there is two main challenges that are not resolved by the solution. The first one is I don't know if my syntax is actually valid. Is it going to commit on the router? And also, I don't know if I'm breaking anything on the control plane or data plane or whatever. So at that time, we had to go take the configuration, push it on the router, go check manually if everything is okay, and then merge it into the production branch. So the first topology I wanted to simulate with Kubernetes and Container Lab was the Paris area. So it's composed of all the layers that we want to simulate at OVH, starting with an AZ and the region, then the network of the region connecting to the backbone. And finally, at the top, we simulate some edge networks and peers. So this is mostly based on Cisco IOS XRD, which is IOS XR, but in a container that is supplied by Cisco. And we also have some Nexus VM. It's not available as a container. Also FreeRTR, which is open source and allows us to inject all the routes from road dumps that we want from the peers. And finally, at the end of every endpoint, I implemented some Ubuntu probes with custom tooling that I will show you later. So here is an extract from the configuration. So as I said, I'm now able to reference my registry directly on the image field of each node, as well as the startup configuration, and finally the links. So I had to do some tuning on my templating because, for instance, the naming scheme of virtual nodes are not the ones that you'll find on the real routers. So I had to fine-tune this, as well as some features that may not be available, such as MACsec on IOS XRD. I had to disable it. But otherwise, all the control plane, at least, is fine. And it's not time to deploy. So we also put topologies in Git so we can share it across the team easily. And you will need one last binary that Carl talked about, which is KlabWärter. So it will take the YAML topology, Container Lab topology, and then you can pass it on, pass the output to your kubectl, and it will deploy it on the cluster. Here is the CLI. So very simple. You call KlabWärter. It will actually automatically find the YAML topology in the current directory. And in a few minutes later, you can see your node spinning up. So for reference, IOS XRD is about 3 to 4 minutes to be effective and fully booted with SSH and control plane. Ubuntu is 1 minute, and Nexus is more 10 to 15 minutes because it's a VM. It takes up much more resources. And it's much more longer to boot. okay, it's really great, but I don't yet know if my design is working. Is the configuration committed? I am breaking anything. So the first thing you want to do is SSH into every router, like a real one. And the good news is ContainerLab makes this especially easy because it will provision automatically the management interfaces with also DNS entries and stuff like that. And Kubernetes embeds a binary called SSHin that will automatically find the first container in your pod, and only container, for instance, and will SSH to it with a default credential. And then once you log in, it's like a real router mostly, so you can pass it any command that you wish is legitimate. That's fine, but to be able to know at a glance if the whole design is working and the whole topology has correct reachability, I needed something more concise and better. So I installed a log collector called FluentBit, which is deployed on the cluster. And the nice thing with FluentBit is that it will automatically parse JSON output on the node. So if I put an fping loop on the probe that is pinging all the destinations that it's supposed to be reachable, then I can output the formatting. I can format the output to JSON, and FluentBit will take it and send all the nice field informated data to my log collector. And then in this log collector, I can create dynamic tables showing every probe and the reachability info in the table. Okay, some feedback. So we have achieved a game changer for us in our day-to-day workflow because we can now run as much labs as we want, as much topologies, even if they are very large. We don't have any technical issues with in regard to resources. Kubernetes associated with Cloud Managed Kubernetes cluster makes it virtually painless. It's very easy to get started with this. And we'd like more container native network OS. So Nexus from Cisco is the last one we'd like to have. There's been a push from the vendors in the last couple of years to have more container native OS. So where are we going to now? We'd like to simulate basically the whole backbone and regions. Now that we can simulate every layer in Paris, we can do it for every region that we want and any part of the network before we do any changes. Also, what we're going to is to do CI/CD lab validation. So this will make CDS spin up dynamic labs on our cluster with Cloudberter and kubectl to be able to show to install all the configuration changes that we are planning automatically without us doing anything, and give us the result of end-to-end testing and syntax validation. And if the result is okay, then we can merge it into production. So if you want to get started with ContainerLab and Kubernetes, you can head to containerlab.dev or scan the QR code. Very nice documentation, very clear. And there's also a Discord channel if you have any more questions or technical difficulties. You can head there to ask questions. That's it. That's the end of the presentation. We also have shiny stickers, so if you want some, you can head to Roman, which is here. And time for question. Thanks.
Okay. Thank you very much. I see people running to the microphone. State your name and affiliation, please.
Peter Hessler from Zayo. This looks very cool. It's very nice to see this. I was wondering if in your testing and development, if you're able to see when a change would trigger a link flap, like changing an MTU on an interface, and if you can see that in your testing or not.
Yeah, so MTU change will affect things like BGP, obviously, especially when you push up a lot of routes. So yeah, this will be visible.
Okay, thanks.
Hi, my name is Rinse Kloek, speaking for myself. Very good presentation, very enthusiast. Do you also plan to simulate, for example, not only your own network, for example, your external peers, like you will have BGP peers, eBGP. Do you also plan to simulate that in your lab, or is it just only configuration changes you are simulating?
So yeah, so in the Paris area topologies that I showed at the top, very top, was it was Cogent, but it could be any tier one network that you wish. So with FreeRTR, you can just inject the DFZ. So you can simulate any external peers that you want and have the probe behind it. Yeah.
Yeah, but that is just manually created. So you just manually create those extra VMs like FRR to simulate your neighbors.
Yes.
Okay. Thank you.
Maria Bird Cizinek, I'd like to ask what are the system requirements for, let's say, divided by the number of nodes? Because what we have run into is when we started simulating more than 1,000 nodes, we ran out of disk space and we ran out of memory. So my question is basically how is it scaling this way?
I could try to answer that. Yeah, I think it would probably depend on your node pool in whatever Kubernetes cluster you're running. So you could have node pools with nodes of a different profile to match, whatever your estimated workload is. I don't know if that's a direct answer because obviously it would be hard to answer, but I think the short is we could probably scale it really, really big with sufficient amount of nodes in the node pool, and then with a sanely sized nodes to make sure that you have like a sane amount of containers per node. I don't know if that's probably not the answer you're looking for, but hopefully at least useful.
Okay, so I'm not gonna run this on my laptop. Yeah.
Okay.
Okay, thank you.
David Tedlizo, Ionos SE. So we've been running Container Lab for a while as well, and we've experienced some interesting problems with the big A and big J vendors, where features would work on hardware but not in the lab, or would work in the lab but not on hardware. Do you have any plans on actually getting rid of a hardware lab and going Container Lab 100%, or will you still use a dual topology?
Well, I don't have a lab at the moment, so I run Kubernetes at my house, so I have no problem with this. I think in general, there's always going to be things you're going to have to test in hardware. MaxSec, I think Simon said during the presentation, like obviously not going to run in software. So I think it's just going to be tailored to your individual use case. So it really matters that I test MaxSec. Well, then you probably need hardware. Like I can't help you there. But as vendors get better software implementations, then hopefully we can pave over at least some of those problems.
I also have a small comment since I'm almost last in the queue. Juniper has discontinued the VMX, but they've recently released 3 new products to kind of step in the place of VMX. So,
yeah. Okay, last question.
Hello, this is Kostas Surbadelos from NTT. Excellent work. I just got the pass from the previous speaker. Is there any way to connect this virtual topology to a physical one, just to be able to emulate the missing stuff on the data plane that you cannot actually simulate in a virtual world?
Yeah. So I think the answer for the moment in the case of Kubernetes is probably not easily, but with Container Lab, you can, and Roman can probably check me here. But yeah, I think you could do like some MacVRF or something to like bridge out to physical interfaces. There's nods, yes, no. Roman's nodding his head, so I feel like that's good. But Kubernetes, no, at the moment, but it's something that's probably possible.
A good point to consider.
Yeah,
okay,
absolutely.
Thank you.
Okay, thank you very much, Carl and Simon.
Great.
The next talk is Maria Isabel Gandia Carriedo, and she talks about Signoc tools, the survey results. Maria, stage is yours.
Thank you. Can you hear me? Yes. Okay. Well, thank you. Thank you, Wolfgang. As I said, well, this presentation is about the Signoc tools survey results. I am Maria Isabel Gandia. I work for a consortium of universities in Catalonia, and I'm also working at the GEAN project on behalf of Rediris, the National Research and Education Network in Spain. So today I'm talking about GEAN. I am going to talk about the results of a tool survey run in GEAN. Before we start, disclaimer, I'm not in favor or against any of the tools shown here. It is just the results of a survey, not necessarily my personal opinions. And it's just to have fun with the results and see your own, take your own conclusions. You may know GEAN because GEAN is the network, the pan-European network that links all the national research and education networks in Europe. But GEAN is more than that. GEAN is also the organization that runs the network. It is an association, it is a project, and it is a community. So about the GEAN project is a big one. The community is more than 50 million users because they are users that belong to the research and education institutions. It's also 500 people working there, so it's quite a lot of people. I am one of these 500. And this is the 9th phase of the project so far. We have been running GEAN projects for years. This is GEAN 5.1. The previous project was GEAN 4.3. The GEAN project is offering services to all this community, to these 50 million users, around security, around operations, trust and identity, and also network development. And I'm currently working on the network development team in the GEAN project, mainly in the Networky Academy, offering resources for orchestration, automation, virtualization, like the training program which is open for you if you want with social networks and EduGain. This GEAN project is also an umbrella where the SIGs happen. SIGs are special interest groups. These special interest groups are just birds of a feather. It's like places or groups of people that meet, share ideas, interchange experiences, best practices around a topic. And we have SIGs on many topics. We have SIGs on clouds, we have SIGs on trust and identity, and also on the network, of course. And on the network, we have SIG NGN, Next Generation Networks, and also SIGNOC. SIGNOC is Network Operation Centers. So what is SIGNOC? Or what do we do in SIGNOC? We share experiences about network operation centers, of course. This is in a graphical image what we do. We have a mailing list. We exchange information through the mailing list, but we are a community. So it's mainly about a community. SIGNOC is quite like a NOC, like SNOC or IT NOC, but for research and education institutions, mainly NRENs, but also other institutions. And I have highlighted here in red squares what we are talking about today, the survey, because the SIGNOC community meets twice a year. We have fun talking about taxonomy of the NOCs, about security, about network operations, but we also create the survey. So we decide what questions go in the survey, what tools we put in the survey, then we run the survey, we ask about the tools, we ask about standards, and then we have the reports. And the reports contain a PDF with all the graphs, the Excel file with the graphs too, so if you want to see them in details, you have the numbers there, and also a matrix. We have run the survey 4 times. This is the 4th time we have run the survey. In the first survey that was run in 2011, 2012, we asked about many things because we wanted to know more details about the NOCs. We wanted to know everything. It was the first time, it was TFDoc by that time. And we asked about taxonomy, we asked about tools, we asked about structure, about everything that has to do with the NOC. We had many open boxes there because we thought it was great to have open boxes to let people just explain what they did. The problem was that open boxes for a survey make it very hard for us, for respondents to answer. It's much easier to just click on the answers. And on the other hand, it's difficult for the people who analyze the results of the survey to take these free text boxes and have a structure on them. So for the second survey, we decided to reduce the number of questions, focus on tools and standards, and just have a list of tools. In the first survey, we asked about 14 functionalities. You will see them later. In the second survey, we added a functionality to this list of functionalities, DDoS mitigation, that was not in the previous survey. And then we asked also about subjective things, the rating. How important is this tool for your NOC? How good is this tool for your NOC? So for the importance, it could be from 1 to 4, from low to high. For the rating, for the quality, it could be from poor to excellent, from 1 to 5. We did the same in the third survey, but this time we added a new functionality, orchestration, automation, and virtualization, because Knox detected that some networks were automating many things, and we wanted to see which tools they were using for that. Again, importance and rating. And for the fourth survey that was run last year, we added a new function, again, training, because NOCs are the trainers of new engineers that come to the NOC. It's not a special department that is just teaching the newcomers, the engineers. It's a NOC that teaches NOC engineers how to work at the NOC. And we had 68 responses. In fact, we had 82 responses in the survey, but only 68 of them were kept because we tried to clean them up a little bit. First, because we want to know who is answering the survey. We want to have one response for each organization, because if 10 people from one organization respond to the survey and one person from another organization do the same, it would look like the tool is used 10 more times than another one. So we want to know which organization are you working on and what tools you are using. If you don't write the organization, you put XXX in the name of the organization, then this response is discarded. And we only kept a duplicated organization for one organization that contacted us and told us that they were using different departments and different tools for different functions, and they were not repeating functions or tools, so that was fine. After cleaning 68 responses, and the structure of the survey and the structure of the report after that, it's always the same. For each one of the functions, short definition of the function, then we ask if the NOC is responsible for that function. If it is, then we ask about the tools. If it's not, then we jump to the next function. And then for the tools, we ask about the importance and rating. All the predefined responses were answered by 2 or more NOCs in the previous survey, in the 29 survey. And open boxes are also included. So if you have other tools, that's fine. You can put them in the results. This is the structure of the diagrams in the report. And this is complicated because we are trying to monitor or to show 3 dimensions into a 2-dimensional diagram. So we have small bubbles and big bubbles. And the bigger the bubble, the more organization use the tool. The smaller the bubble, the less popular the tool is. So for instance, here, you would have something that goes to the right, up, and with a big bubble, this means it's popular because the bubble is big. It's very important because it goes to the right, and it's very good rating because it's up. On the other hand, this tool here would be not very popular, and it's just important for a few members of NOCs, but very poor rating. Usually when you have tools that are quite popular, they are around here, and if they are not popular, they are around here. You will see that in the next slides. Then we also have a matrix, and the matrix also shows 3 dimensions in a 2-dimensional diagram or file. Here you have, in the rows are functionalities, 17 functionalities, and the columns are tools, more than 150 tools here. So for each one of these cells, you have the number of institutions that use the tool, and if you click on the cell in the Excel file, you have the list of organizations that use it. And why do we have the list of organizations that use it? Well, because we are a community and we know each other. And if we are using a tool and we know that another organization is using the same tool and we have problems with that tool, or we want to use the functionality of this tool, it's easier to poke them directly. We can do it through the mailing list, but we can also meet them at one of the meetings or poke them via email or one of the other tools. The types of organization that answer the survey are national research and education and campus university networks mostly. You saw we had 68 answers. Why do we have so many? This is more than 68, because some NOCs manage 2 types of network or 3 types of network at the same time. Many NRENs also manage campus university networks or internet exchanges or also specific research networks. So we have organizations that manage more than one network. And about the functions, this is the list of functions. And in this report, in this presentation, you will see that we also have the columns for 2016, 2019, 2023. Here for 2023, it's always rating 1, 2, 3, 4, 5, 6, 7. But for the other ones, you see the position in the ranking where they were in the corresponding report. So if they are in the same position, it's a 0. If they are going up, green arrow, a number of positions they went up. If it's going down, red arrow, a number of positions going down. What does this show us? Well, that monitoring is always the function that NOCs are performing. NOCs are monitoring the network. They are there for that. Problem management is the second one, which is quite similar. You monitor, you find a problem or an incident, then you act on it. And ticketing, we create tickets. These are the three kings of the NOC functions. We also see that knowledge management and documentation is slowly going up from the 8th to the 6th to the 4th position. This means that even if NOC engineers don't like documenting very much, they understand the importance of documentation. So that's good, it's going up. We also see that communication, coordination, and chat is going up. So it is important to communicate what's happening on the network. And on the other hand, we see that security management is going down 6 positions. Why? Well, we think that's why, because security operation centers are starting to be deployed in the different organizations. So security is taking over from the NOC to the SOC, and the NOC doesn't feel responsible for this security anymore. Also, we see that training, even if it was in the last position when we asked, it's in the 13th position. So it means that it's quite relevant. And orchestration, automation, and virtualization are the last function or the last one in the ranking. Regarding the number of tools that we use, it is huge. There is no single tool for all the functions, that's clear, but there is no single tool for one function. Look at monitoring. More than 11 tools on average for monitoring in each organization. This means that each one of you, if you belong to a NOC, or if you are a research and education institution, but I think it's quite similar in other environments and in this community in particular, you have more than 11 tools that you use more or less daily or weekly to monitor your network. SNMP tools, flow monitoring tools, syslog analyzing tools, ICMP monitoring tools, RIPE Atlas, NLNOC Ring. You have many, many tools to monitor your network. On the other side, you have ticketing. Most of us use just one tool for ticketing. It can be two, because depending on the NOC, maybe you use an external ticketing tool, or maybe you use a different tool for security and for monitoring. But you can see that you use, or we use, many tools. The second one in the ranking will be communication, coordination, and chat, and you name it. How many chatting tools do you have in your mobile phone? You have like Rocket Chat and Slack and WhatsApp and Twitter and everything. So NOCs also feel the pain. The first question we asked about tools in the survey was not about the rating, as I mentioned before, but frequency. We asked, are you using the cool streaming telemetry very frequently, or are you still using SNMP-based tools? You see, we're using SNMP-based tools a lot. And it is very important. It's just on top of the table, used by almost all the NOCs. That's normal. We have all these tools based on SNMP. After SNMP, we have flow monitoring-based tools and syslog handling tools with a little bit more of frequency for syslog. And then streaming telemetry has room for improvement, let's say. It's a little bit better than in the last survey, but still quite in the left and bottom position in the table. Then we asked about the tools in particular, the list of tools. And then I animated this graph so you can see something here, because if not, it's so crowded with 36 tools that it's impossible to see something. This way you can spot your tool, but you can also go to the Excel file and take a look at it if you want. You can see that we have all sorts of tools with all sorts of importances and rating. Grafana is the most popular one, followed by Nagios, but we have many others. And as I said, if each NOC is using 11 tools, some of them are just everywhere. I try to zoom in this graph. The next slide is about this zoom, but I let it stop. Okay, we have all the tools here. You can see them also in the Excel file. I zoom in this. These are the top 5. So the first one is Grafana. Grafana was the most popular for most of the networks. Then Nagios, and interestingly, MRTG. Take a look. This is a zoom, so this belongs. This starts at 3, but MRTG is quite popular still, and it's a long time ago known tool. Then we have RIPE-Atlas. This is one of the most popular tools we use. And PerfSonar. PerfSonar is developed by the research and education community for the performance management, to see the performance of especially multi-domain circuits. If we zoom in a little bit more, well, not zoom in, zooming out, top 10. If we look at the top 10, we also see that other tools appear like NFSen, the ELK-Stack, InfluxDB, weather maps, and so on. And if we look at the top 16, and see that I put top 16 here and not top 15 because RIPE-RIS was the 16th one, and this is the RIPE meeting. So I wanted to show you how the RIPE-RIS is used. RIPE-RIS, taking into account that we have 36 tools, it's in the 16th position, so it's at the top of the table. We're using it, and even more for problem management. This is just monitoring. Maybe it's not daily, but we use it. We have other tools like Izinga or Zabbix appearing in this top 16. And if we take a different look to the same data and we see what's the percentage of the respondents to this question that use each one of the tools, we see that Grafana is used by more than 70% of the organizations that answer this survey. So it's a very popular tool right now. And Nagios is the second one, more than 50%. And MRTG is also there. So you can see that Nagios and Cacti are still popular, but MRTG is going up. Grafana is the first comer, the first time on the table in 2023 because it was mentioned by 5 organizations in the previous survey. And SmokePing and NFDump disappear from the top 10. You see NFSen is the 10th one. You can imagine what NFDump is. SmokePing is quite close to. For each one of the functions, you will see the average of tools that are used, but I already mentioned them in the first graph. If we go to problem management, Confluence, ELK-Stack, but Nagios is the most important one, and Request Tracker. RIPE-Atlas is quite important. RIPE-RIS, as I mentioned, for problem management is also quite popular. For monitoring, is in the 16th position here. We don't use so many tools. RIPE-RIS is one of the popular ones. It's in the top 10. For problem management, we have a mix of open source, we have a mix of vendor-based and distributed tools, a little bit of everything. And this is something that it's a pattern that is repeated in other functions too. There is an increasing usage of RIPE-Atlas and RIPE-Stats. Jira goes down from the first to the fourth position, maybe because they change a little bit the way they offer the product, and some organizations are moving from Atlassian to other tools. For ticketing, we don't have so many tools. We have RT, Jira, OTRS, ServiceNow, and Zendesk. And then Proactive.net and UTrack are mentioned once. The answers are quite scattered. There is no single tool that is used by more than 50% of the respondents of this question. And Request Tracker was in the first position in 2016. It went back to the first position in 2023. Then, if we see knowledge management and documentation tools, you can see here that we have many tools. Most of them are on the top of the table. And regarding the number of users, Confluence remains 50% of the users, and GitLab is quite the same. GitLab, Netbox, and Nextcloud appear for the first time because they were mentioned in the previous survey. And then several tools are going down, like Google Drive, Wiki, and OwnCloud. There are other tools that disappear from the top 10. You can see them here too. And then for reporting and statistics, Grafana is again the king, followed by RT and Splunk. I'm going to go quickly through this because you have the report to see it. I wanted to show you also the communication tools because this time the Signal community decided to separate bidirectional communication from unidirectional communication. And then in previous surveys, it was all together. So for bidirectional communications, you see, we use email-based tools like email or mailing list. But if you look at the percentage of people who use them, around 60% of the organization use email and mailing lists. This means that nearly 40% of the organization are not using this for bidirectional communication anymore. It's quite different for unidirectional communication. You use unidirectional communication with mailing lists, but not for bidirectional. For bidirectional, and remember the 2019 survey was pre-pandemic, now it's after the pandemic, we are using more asynchronous tools, more video conferencing tools too. And what we are not doing is calling by a phone. We don't use the telephone anymore. We don't like it, or it looks like we don't like it. Maybe we use the mobile phone, but the landline disappears from the top 10. In previous surveys, we had landlines there. People were calling the NOC. Now people only call the NOC if really needed. If not, they prefer just to drop a message. For unidirectional communications, as I mentioned, 90% of the organizations use email and mailing lists. So yes, we use email and mailing lists. And when we want to broadcast something, we use Twitter too. But we don't use Zoom or other things. We still use traditional email-based tools for that. For configuration management and backup, here's a clear line. Git and Rancid on top of it, Oxidized, and IMS and CVS have the same ratings and Subversion. And then Git is used by more than 70% of the users. And Rancid is quite popular too. Subversion is going down compared to the previous survey. The last graph I wanted to show you is about resource management. And why? Because I found it quite interesting that this big bubble here is Excel files. So we have lots of tools to manage resources, but we're still using Excel files. Most of the organizations use Excel files. And you see the importance is not that high. All the tools are in the middle of the table, medium importance. Ratings are quite scattered too. Excel is not the best rated one, but it is the most popular one, the biggest bubble. Here, more than 60%, and nearly 70% of the organizations use Excel file for resource management. Netbox was mentioned, but it was in other, so it will appear in the next survey in the list of organizations. And Confluence is the best rated, but it's only used by 24% of the organizations. There are other functionalities in this survey, in the reports, but I cannot go through all of them because I don't have time to go through all of them. Some facts, interesting facts. Resources management was about IP addresses, VLANs, and so on. Inventory management was about routers and switches, and so on. And guess what? Excel files are also the kings. So we're using Excel files. It's a popular tool. As more institutions have SOCs, the percentage of NOCs who feel responsible for security management decreased from 63% to 45%. Automation is still the function less NOCs feel responsible for. And you can see all the results in this link here. All the results from previous survey, the Excel files, the matrices, everything is there. Some conclusions. Well, you see, the ecosystem is huge. It is biodiverse. NOCs work with dozens of tools. More than 150 are used by more than 2 organizations. So there are others that are used by just 1 organization, and also ad hoc tools. There is no tool that has all we need, even for just 1 function. Look at monitoring. There is no tool that works for all the functions, not even Excel files. And there is biodiversity, this mix of open source, vendor-based, and distribute tools. So if you are starting a NOC, I don't know how many newcomers are here, but if you are starting a NOC, I would say that if you take a look at the survey, it can give you some ideas. If you take the 5 or 10 most popular or 20% most popular tools, you should probably be fine making your decisions. And the survey helps you understand the trends and which tools are more popular. This means that have more community behind it if you have any questions, and for which functions, and also past trends. But if you have a wonderful tool that works for you, I'm not going to tell you to change it. It's up to you. That's just the results of the survey. And that is the end of my presentation. Thank you.
Thank you, Maria Isabel. And I see people rushing to the microphones.
Peter Hessler from Zayo. I noticed in some of the responses that you had a specific tool and then a generic term that can also be applied to that tool. Like, for example, IM could match Slack, it could match Teams, it could match Mattermost, etc. And I was wondering if you got any explanation or understanding of why respondents chose the generic term versus the more specific term.
Well, in fact, this was the list of terms we put there was a decision by the Signal community. So we said, well, do we want to put a looking glass, a specific looking glass, or a specific IM?
Mm-hmm.
And they said, well, keep this. So we kept it like this. It's just a community that is small, so maybe we can just do that. But why people decided to put to choose the IM instead of other tools, this is not something I know, because I don't know who responded, why they did that like this.
Okay, thank you.
Thank you. Hi.
Hello, Stavros from Ham6Nog, who is not using Excel to document inventory. Super interesting presentation. Thank you very much. I saw in your results, however, a little bit of mixed results, which are contradicting with my impression, because I speak a lot with colleagues from other NOCs, and we share experiences on tools and stuff like that. So I was wondering what type of NOCs did you talk about and you did your research, because maybe I said and I missed it. Because as I understand, if you are a small NOC team like Ham6Nog with 8 guys, 9 guys, it's like jack of all trades. We do everything, so we use a lot of tools and so on. But in larger organizations, the NOC has a little bit more specific role, more on the ticketing side, more on the customer facing, and the real stuff with Netbox, fancy and simple, and so are happening with other parts of the organization.
Yeah.
And in your results, I could see both. So I was wondering what kind of NOCs.
Yes, well, these NOCs belong to research and education organizations, mostly national research and education networks and campus networks. So this means that NOCs are usually not so big as in big organizations. NOCs do almost everything in some cases, but there is a biodiversity in the size of the networks too, and the size of the managing organizations. For instance, we have organizations that only have 4 people there, and they do everything. And there are organizations that have 800 people there, and they both belong to the National Research and Education Networks community. So it's quite diverse. There is a gap between some of these organizations.
Okay, so the people who actually did reply to the question, most of them are do most of the functions, if I understand correctly.
Yes,
Yeah.
well, monitoring, problem management, that's for
Everything.
sure. Then automation is sometimes done by a NetDev team, and other tools are in the SOC. So it depends on the size
Great,
of the
thanks a lot. Yeah, very nice.
Hi, my name is Andri from Indonesia. My question is, how did you do the survey? Are you going to use did you use the open-ended questions or closed questions? Because it's a bit weird for me. I mean, my impressions this is 2023 already, the
Yes.
survey, and AI is already there. And I haven't seen any of your presentations that some NOCs using AI. I mean, like my organizations, we use a lot of data from the API, from the Grafana and everything else, and then we just consume it using the AI, using the LLM. So now we can actually ask AI rather than looking into some graph of, say, for example, if some problem happens with our network.
Yeah,
Yeah.
well, there is work to do. And okay, the first part of your question was about,
Yeah, open-ended questions or closed questions.
no, okay, this was a list of tools.
Okay.
Okay, we use SurveyMonkey for the questions. There was a list of tools, and at the end of each one of the questions, we had an open box, so you could add your own ad hoc or other tools that were not on the list. And in the last surveys, if there was a tool that was mentioned by 2 or more organizations, then we added it in this survey.
All right.
If the tool was only mentioned once, then we removed it from the survey. And about artificial intelligence, it's not that we don't use artificial intelligence. We, in fact, are working on artificial intelligence in the GEAM project too.
Okay.
But this was quite oriented to quite focus on the tools per
Okay.
se. So we were asking about independent tools, let's say. And you see there were many tools used by organizations. Some organizations have APIs and use these APIs to
Yep.
organize their own dashboard and have their own things there.
Yeah.
But we wanted to know what was behind them, what kind of tools they were using behind them. So, for instance, maybe you're using InfluxDB and you are drawing with Grafana,
Yep.
and that's fine. But we wanted to know: are you using Grafana? Are you using InfluxDB? If you have your ad hoc tool, cool. Yep. But maybe it's yours, so it's not so relevant for the community to know what you have done, because the community wants to know about particular tools that they are also using.
All right, thank you.
Thank you.
Okay, thank you very much.
Thank you.
So the next presentation is a remote presentation, and it was pre-recorded, but the author is available online for questions later, and the topic is exploring the benefits of carbon-aware routing by Zafzan El-Zar from the University of Oxford. Please run the recording.
And today we'll talk about my work exploring the benefits of carbon-aware routing. This is a joint work with Paul Gunning from British Telecom, BT, and my supervisor, Noah Zilberman. So to achieve net zero carbon by 2050, we have many initiatives. It's true that computing, mainly done in data centers, is one main driver of carbon in ICT, with data centers reporting an annual energy consumption in the order of 10 to 20 terawatt-hour per year. On the other hand, networks report less than 10 terawatt-hour per year, which may seem not very significant. However, with a huge number of ISPs, these small contributions will sum up, and then carbon related to networks cannot be neglected. This work is in the context of routing, so at the network layer, and it specifically addresses Scope 2 emissions associated with routers. So if we look at this small network, if we want to send a packet from router A to router E, there will be multiple paths. Previous works focused on increasing the power efficiency of these networks by, for example, choosing the shorter path. But routers placed at different locations will be fed from different energy sources and will have a different carbon intensity. The carbon intensity is a weighted measure of the amount of CO2 released to produce 1 kilowatt-hour of energy. So for example, here, it would be better to route through the upper path now instead of the lower one, although the lower one is the shorter path. So this adds the geographical dimension to the routing problem. Now, with the ability to predict this carbon intensity per region from the power grid ahead of time, we can take benefit of this information, integrate it into the routing process, and explore how much carbon emissions can be reduced based on carbon-aware routing. So the first step is to clarify the building components of the carbon footprint for networks. It depends first on the amount of energy consumed, and then on the source of this energy. Is it coal, gas, renewable energy? And finally, on the weighted carbon emissions associated with the source. So the last two terms can be covered by the term carbon intensity. And we'll go over both components, the energy and carbon components, and then move on to define the metrics that relate to this. So first of all, the energy consumption of a router has a dynamic part that is proportional with the utilization, almost proportional, and an idle part that is built from the static power or zero port power plus the power for enabling every port. On the other hand, the carbon intensity is the measure of grams of CO2 emitted per energy consumed, so per kilowatt hour. So a higher carbon intensity means that the source of energy is emitting more carbon and is less green. So renewable energy sources will have an associated lower carbon intensity. So for example, for solar and wind, it can tend to zero, the carbon intensity. So in the figure, we can see the variation of the carbon intensity per day in the UK, and this is for different seasons. So this metric varies a lot per day, per season, and also per region, and we can see a noticeable change only within a few hours. Now, recent machine learning algorithms allow to forecast this carbon intensity up to 24 or even 48 hours ahead of time. And this is actually the main motivation of this work, to plan ahead, to adapt the routing of traffic to greener paths. So now, knowing that the carbon footprint relates to energy and carbon, we define a set of metrics to be considered by the routing problem, and in subsequent sections, we evaluate the impact of these metrics on reducing the overall carbon emissions. So starting with the energy-related metrics, the typical power is the first metric and is defined by the power consumption at 50% load and can be mostly extracted from datasheets. The second metric is the energy rating or labeling of the router. This metric indicates the energy efficiency of a router. It is still not standardized, but we define it as the ratio of the typical power and the maximum packet rate. It can be defined differently, but we start with this definition. And after examining a range of routers available in the market, we derived a closed range and divided it into a 7-star scale, so from A to G. Next, we look only at the dynamic power and divided it by the maximum capacity. So the unit here is watts per megabits per second. For the energy rating, we consider the typical power, but here we look only at the effect of the dynamic power per unit of traffic. So this metric is the incremental dynamic power per unit of traffic. That's it for the energy-related metrics. We'll move on to the carbon-related metrics. The first metric is obviously the carbon intensity, and we talked about it before. And finally, the carbon emissions metric is different from the carbon intensity because it considers the actual energy consumption per router over a previous interval of time. So it's the product of the energy consumption and the carbon intensity. So that's it for the metrics, but we can also have combinations of these metrics. For example, we can combine carbon intensity with the typical power, or carbon intensity combined with energy rating, and so on. So how to evaluate these metrics? We have two approaches. The first approach is to change the link costs based on these metrics and then apply the Dijkstra algorithm. So this is a basic approach. And for example, if we look at this example network and we consider the carbon intensity to be the metric for the links, so in this case, we can have with equal cost multipath, ECMP, we can have two paths with the same cost that is like considered greener than the one in the middle. But then if we add the energy labeling to these metrics, the routing tables will be also, again, different. So that's like a different optimization target. So that is the first approach. And this one will mainly improve only on the dynamic part because all equipment are still on. The second approach aims at further reducing the idle power by shutting down unnecessary ports. So the second approach is a carbon-aware traffic engineering-based heuristic that we denote by CATE. And what it does is, after changing the link costs, it will pick the links with the least utilization and highest carbon emissions, shut them down for the specified interval of time. It then checks if the graph is still connected, check if the carbon savings are still positive, and it repeats this process over and over until no further links can be disabled. So this is a simulation-based study using the NS3 simulator, and it is applied on real network topologies like British Telecom, BT in the UK. This is the topology of BT in the figure, and BT is a main ISP with more than 1,000 nodes. And we also looked at Giant topology, which is an educational network based in Europe. So now, before proceeding to the results, it is worth highlighting on the traffic patterns considered that turned out to be a game changer. We considered two traffic patterns, the daytime traffic and the evening traffic. So the daytime traffic is dominated by business customers and is mostly somehow symmetric, whereas the evening traffic is dominated by residential customer traffic that is mostly downstreaming of content from caches co-located at metro nodes. So here you see the hierarchy of the BT topology. These are like some core nodes, some metro nodes, and some tier 1 nodes. And according to BT, caches are located at metro nodes. So this downstreaming traffic peaks at around 8 p.m. So now we present some results. We see the carbon and energy percentage improvement with respect to OSPF for day traffic on the left and evening traffic on the right. We have different combinations of the metrics introduced, and then we have Kate that is based on disabling ports. So the first 3 metrics are energy metrics, and we see that the incremental dynamic power per unit of traffic leads to higher improvement in terms of energy and carbon. And this is in the context of power efficiency, because carbon is not considered for these energy metrics. Then combinations that include the carbon intensity save more on carbon, but this is at the expense of a path stretching of about 5%. The path stretching is the increase in the average number of hops traveled by a packet. We can see that also the combination of carbon intensity now with the incremental dynamic power per unit of traffic is the best combination of metrics. And then Kate introduces additional carbon savings by disabling unnecessary ports. And then all of these improvements vanish for evening traffic because the flows for downstreaming are all short and there is no room for changing the paths a lot. Like even disabling ports is minimal and can be impossible at peak times. Moving on to the Jayon topology, we can see similar patterns in the results. So again, Kate has the highest savings. Now for the Jayon topology, all the nodes are considered to be the same because we don't have the same hierarchy in BT like core, metro, and tier 1. We assume all the nodes to be the same, so that's why they all have the same energy parameters. So we only compare between OSPF, Kate, carbon intensity, and carbon emissions. So again, Kate has the highest savings with around 8% of the links disabled. But interestingly, here you can see that the delay is really similar for all 4 scenarios. And this is also for BT. Now, back to BT. If we want to see the variation of flow paths, on the left, we have the carbon intensity heat map. And on the right, we see the flow intensity in gigabits per second per region in the UK. So this is for OSPF, and this is for the carbon-aware routing. So according to the carbon intensity API, where we extracted the carbon intensity information from, the UK is divided into 14 regions. And they did an analysis for the energy flow between regions to derive the carbon intensity for the energy consumed per region. So we see that in OSPF, London has the highest cross-section throughput. Then with carbon-aware routing, flows are higher for Northwest England and East England that have a lower carbon intensity. And this is like relatively to their surrounding in the map. And then on the other hand, we can see that East Midlands and South England have less flows in carbon-aware routing because of their relatively higher carbon intensity. Finally, London, on the other hand, did not change really. And this is because of the high density of nodes in London. And this leads to somehow have a bottleneck in the topology. Now, looking at the flow intensity for Jayon topology, we have similar patterns, but it's worth highlighting here also on the change in a few regions. In carbon-aware routing, we see that France, Italy, and Germany have the highest intensity of flows. So most of the flows flow through these countries. But when we compare these values to the flow intensity in OSPF, we see that the flows increased in France increased in Italy, but decreased in Germany. But yet, Germany is still with the regions with the highest flow intensity. And this highlights, again, on the issue of having bottlenecks in the topology, where some high carbon intensity regions cannot be avoided. Finally, another aspect of the simulation was to see the effect of changing the static dynamic power ratio for routers, because different routers will have a different value of this ratio. For example, chassis-based routers have a very high static power for the chassis. So we vary this ratio, and we see that carbon savings diminish as this ratio increases. So it's always better to invest in equipment with lower static power, but also the ones that are more power proportional. So in summary, some takeaways of this work are, first, in terms of metrics, the carbon intensity combined with the incremental dynamic power per unit of traffic are the best combination of metrics. The energy labels are a good metric for purchasing, but in the current form have limited routing benefits. It can be better, for example, to divide it into two separate metrics, one for static and one for the dynamic power. Third, the limitations include the high idle power that limits the carbon savings. Fourth, the routing bottlenecks also limit carbon savings, and it's always better to place additional renewable energy sources at these bottlenecks because it's hard to be avoided by the flows. And finally, the carbon optimization is application specific because, as we've seen, the downstreaming traffic is hard to be rerouted. But one possible future direction is to look at time shifting of the flows instead of just space shifting them. So the next steps, what do we have as next steps? First of all, we need to identify and agree on a set of metrics for sustainability, like energy and carbon metrics for routers and also for all the equipment along the way. Second, we need to establish veracity of the reported metrics, like can we really trust this carbon intensity data from the power grid? Third, we need to define standard reporting formats. And finally, we need to tie the electricity consumption and the carbon intensity to applications. And this is the concept of carbon tracing. So a final note is that the code is available on GitHub for the GATE algorithm, and I'm happy to take any questions. Thank you.
Okay, Savzan, if you're online. Yeah, yeah, hello.
Hi.
Perhaps I should look at the camera so you can see me. Okay, there is someone at the microphone.
Hi there, Tom Hill from BT. Quite interesting to see this. I didn't actually know that this work was going on, so that's good fun. I've been advised as well that all the information here was gleaned from the public domain. So it's important to note that this isn't internal information. There are a few problems with it, but I think very interesting work on the whole, and something we perhaps don't necessarily consider. I wondered whether or not you'd considered the combination of metrics and working on a sort of a threshold-based constrained mechanism for working out, if we use the least carbon emitting path, does it go over a certain threshold of latency, for example, or does it go over is it a path that's not necessarily as capacious as some of the others? Has that been factored into some of the research that you've been considering?
Yeah, so when we consider the carbon intensity into the paths, there was like a small additional delay. So it was 5% fast touching, but it wasn't that But again, this is just to explore how much can we gain from the carbon-aware routing. It wasn't it cannot be tackled now by the ISP. There are like a lot of challenges yet to be resolved.
Yes, I mean, not the least of which it's very difficult to actually attribute where the power was generated as to where the power is then consumed. But I do feel that as network operators, And this sounds terrible of us, really, but as we have other requirements for making sure that we hit a certain level of network performance before we worry about how much carbon we're burning in providing those links. So, I mean, the constraints there, the traditional constraints that we have, those don't go away.
Yes, so quality of service, some of the quality service requirements can be embedded in the Kate algorithm, but we didn't embed them here because we want to see, like, at most how much can we improve on the carbon, like even with the less QoS constraints.
Well, it's interesting work, so thank you very much.
Thank you.
Next question.
Peter Hessler from Zayo. Very cool presentation. I like that we seem to be more aware of how our carbon use and our energy use is being affected by our industry. One thing that I noted in my day job was that there's a number of energy saving settings that we can enable on, for example, Juniper PTX routers that can save hundreds of watts per device, but they're not enabled by default. So I would encourage all the operators who are paying attention to look at the documentation for your devices and see what you can enable. And this will simply turn off ports that don't have any optics plugged into them. If there's no optics in a line card, it can turn off the entire line card. And it won't affect any other ports that are actually in use, and you still get full performance out of them.
Yeah, so I want to add to that is because the carbon intensity can be forecasted up to 24 or 48 hours ahead of time, so we can plan for this.
Yes, exactly.
Thank you.
Okay, I see no more questions. So thank you, Savzan. Thank you for your presentation, and perhaps see you at one of the next RIPE meetings in person.
Yeah, hopefully. Thank you.
Thank you. Okay. I have a couple of announcements. First, please rate the talks. Rate the talks. The program committee really relies on your rating, and it helps us a lot on planning. Also, there has been an agenda change. So we moved one of the Friday talks to this afternoon. So please check the online agenda for an update. And also in the afternoon, we're going to have lightning talks. And with that, I send you to the early coffee break. Thank you very much.
Hello, everyone. Welcome, good morning, and welcome to the second part of the morning plenary today. I am Franziska, and this is my co-host Antonio from the program committee, and we will chair this session for you. General remarks, please do us a favor, rate the talks, give us a comment. That way we know what you liked, what you disliked, and you can still put yourself up for the program committee. We have 2 seats open for election. You can put yourself up until today at 3:30. Just shoot us a mail at pc@ripe.net. And without further ado, I would like to remind you that if you go to the microphone, please state your name and affiliation. If you're unsure how to behave on a microphone, we have a code of conduct that will explain it to you. And with that, we will start with our first speaker. Our first speaker is Joshua from the University of York, and he will show us a new tool to create metadata-rich internet topology graphs to understand the internet in a geopolitical world.
Hello, I'm Josh, and I'm here to speak a little bit about architecture and routing in a geopolitical world. And my supervisor is also here if you want to ask questions at the end as well. So without any further ado, we've got a few different ways of looking at what the internet looks like. And I'm sure some of you have seen at least one of these different versions of it. So one of them is looking at the AS core and how autonomous systems interact on the internet. One of them is looking at kind of what part of the internet is hosting how much content. And there's sort of other connectivity maps through time as well. Some of these have some advantages, others have others. But importantly, why should we care? And here's an example. For instance, we all have our own priorities of what we want an internet to look like. From a user perspective, that might be really low latency. From an operator perspective, that might be sort of network routing transparency, so you know where content is going, how you can steer it. And also settlement-free peering is a sort of economic incentive so that everyone is able to provide transit. So arguably, this might be to some people a kind of border-free, settlement-free, transparent, and uncensored internet, which, of course, we all know is not the reality. And so this is kind of touching on that, looking at the kind of geopolitical element. So kind of within the context of internet sovereignty, where nations are trying to exercise what they would call a right to govern their networks to serve their national interests. In the UK, we call that making the UK a safe place to live and work online. In other countries, there are kind of other implementations. And then there are kind of governance ideas being shared. So I know Netman Dial was only a week or so ago now, and they had their own outcomes and their own vision for how the internet should be governed. So alongside that sort of angle of it, there's also increased regulatory intervention. So at each one of these kind of content, platform, and network levels, different countries are introducing different types of legislation. Across the EU, they've got some examples. Here in Poland, there's some legislation to go almost to counteract some of the EU examples. In the UK, we've got the new Online Safety Act. So everywhere is kind of starting to build even more of a kind of regulatory base for the internet. And of course, that can't be implemented in a kind of borderless internet world. So there are kind of 3 questions I want to look at a little bit here. So first of all, there's like, does the topology differ between countries? Do different countries' internets look slightly different? How does it differ? And then why might it differ? So looking at whether that legislation might actually be kind of the impactful element. So our work is kind of building a tool to collate internet topology data from a number of different sources and compile it into a kind of internet topology graph that we can now analyze and then possibly do other things with. I've got a link on here that take you to our sort of lab website, and hopefully next week I'll release the source code for this as well. I just need to clean it up because I've been running it on a specific machine, so I need to make it a bit more platform agnostic. So first of all, kind of looking at the approach that we take, I want to talk you through a little bit about what this tool does. And first of all, it's taking sort of internet routing data from a variety of different sources. So RouteViews from the University of Oregon, the RIPE NTC's RIS service, along with RIPEstat and a couple of other tools like Atlas. And then the Packet Clearinghouse, which provides sort of dump data from a number of routers, various internet exchanges around the world. So another quite a rich source to try and expand what we can see. And this is kind of how the system works. So we take in kind of internet routing data from these root collectors. We take in metadata, so things like the registered country, the registered location, who owns the resource and whether they own any other resources, and we process that in. We also look at kind of geolocation data, so can we see where a given router is in the world, and that way we can kind of start to detect ASs that span multiple places. And then we process the data, we label our internet topology graph, and then we use this to output. So when it comes to capturing location, there are a few different challenges. One of them is that different registries capture that data under a slightly different field. And also when it comes to network spanning multiple locations, the different AS tags that come associated with that are also quite interesting. And then another part of this is kind of looking at prefix geolocation. And in our case, we're using MaxMind because it's a free source for our research. But it also comes with some of the like cyclical dependencies that if they don't know where something is, they just use the registry information anyway, which doesn't necessarily give us any additional richness. Adding additional metadata to this, so we take in the registered owner, but then we have to try and work out if that owner exists in another autonomous system record. So for instance, if a company is merged with another one, often there's an inconsistency in the data despite the company ultimately being the same. So we have to try and look at that. So we're using things like peering DB, opaque IDs, and that kind of thing to see if we can correlate between the same owner across multiple registries. Also looking at the registered location. This is using ISO standard country codes, and so I'm going to keep that consistent throughout this. So whenever you see a country code, that's the ISO standard one. I haven't made up a new additional one. And then looking at state ownership data to see if the state owns a percentage or more than 50% of some of these companies that we detect within the data. And then ultimately we get this as an output. So we get a node being an autonomous system, so with an autonomous system number and associated metadata. And then an edge is just an adjacency between it that we're detecting with things like AS path and also some traceroute data from Ripe Atlas probes. And here we go. Here's a basic example, just a general node to node peering, so an AS to AS. So if we look at 2024, this is coming from the 1st of May, and my timestamp start point was at midnight, so the start of the 1st of May. We see 84,266 autonomous systems. And to give you a bit of a comparison with alternative data sources for the same time period, I've put ours. We've got how many AS is reserved within RIPE-RIS, and we're a little bit higher than that because we've combined a number of different sources. And then to try and give you a comparison of what kind of adjacencies we're inferring from that data, I put our data for 2024, which is a little bit higher on the right-hand side here with a blue-like graph line. And then ours versus Kaida's in 2020, because Kaida probably has the richest set of data for kind of inferring interconnections. So you can see we've got a little bit of progress on where we were before. So our topology is seeing a little bit more, and part of that is to do with the richness of the data sources we're combining to build a better data set. In particular, we know that our data isn't quite as accurate for Africa because there's very little in the way of root collecting probes in Africa. So if anyone can advocate for that, that'd be really helpful. Within the same time, we're seeing 84,266 ASs. We're also seeing 116,977 NRO assignments. So that's the maximum, I guess, number of potential ones if you're excluding bogons that could be in the data set. This is only the ones we're seeing as active. So in reality, that number would be slightly smaller, but clearly we're not seeing everything. And that's kind of an overview of how rich our data is. And this is what we see for it. So in this case, we've got a CCDF plot of the maximum degree, and that's running along the bottom. And then vertically, we've got the kind of probability on a log-log scale of seeing that. And so this is showing it across 4 different periods of 2010, 2015, 2020, and 2024. What's particularly interesting, though, if I look on this next slide, is the kind of decrease in the medium degree nodes between 2023 and 2024. And then seeing a higher number of high degree nodes. So this is talking at nodes with a degree of like more than 10 to the 3. And that's an interesting trend that we're kind of starting to see this like medium number decreasing and the highest degree nodes increasing. So an interesting discovery there. Also, if we look at like RPKI deployment on the same scale, we're taking RPKI deployment as where we can see one ROA object for the AS, which I appreciate is not possibly the best measure of it, but it's one way of looking at it. And so on here, we've got all ASNs, so we can see that sort of purple line going through, and then we can see the number of medium degree nodes where they've deployed a RPKI is much higher, but at high degree nodes, there's possibly a little bit less on that front. And then when we've seen no RPKI, we're seeing that mostly existing still within that medium degree node space. So the probability of encountering a non-RPKI deployed node, you're going to get a degree between 10 to the 1 and 10 to the 3, so 10 and 1,000. And then if we look at the average neighbor degree, so this is taking the average degree of all of an AS's locally collected peers that we can see. This is another interesting plot, which kind of shows that at the higher end, where the average neighbor degree is right above 10 to the 3, the number there has been increasing over the past kind of 4 time periods, so 4 lots of 5 years. So another interesting kind of key trend. And then this is a kind of crude way of looking at it, but most influential, where we talk about eigencentrality, which is how kind of central to a network graph a node is when it comes to an autonomous system. This is the kind of top collection of autonomous system providers that we can see based on our company data. We know our data is slightly biased because a lot of the root views and RIBRIZ data is collected from root collectors paired with Hurricane Electric in particular. So where we see them being like at the most central in this graph, that's possibly not true. But what we can see is that the kind of major providers that we would expect to see are appearing in that data in the most central. Then we talk about kind of autonomous systems and peerings. The number of autonomous systems registered or observed has increased significantly since the start of our data collection period in 2005. The number of public interconnections has also increased. But what is really quite interesting here is the average path length has increased as well. So where in like a lot of particularly academic literature, we talk about an average path length being about 3.7, in this latest collection of data from 2024, and also similarly in 2023, we're seeing that path length being 12. I think there are a couple of possible explanations for that. One of them is there's a problem with our data. I don't think that's true because we're capturing the previous measurements up until about 2015 using our data as well. So there's something going on there. And I think it'd be interesting to find out quite what it was, whether it is kind of this, what I'm going to suggest is possibly kind of censorship approaches, or whether it's just an increase in private peering and we're not detecting this, but we are trying to mitigate for that with trace route entries as well. So hopefully we would be picking up much of that. So the kind of does element here, does topology differ between countries? I've got here a force-directed plot of the internet looking at May 2024. And so I've put a number of countries allocated colors in this graph on here. And you can see kind of at the top here where that green patch is emerging, that's the United States. They've got quite a strong domestic interconnected base. On the right-hand side coming out in this kind of large blue patch, that would be the connectivity of Russia. Russia's approach to censorship is quite interesting because they have quite a distributed approach. So what we see is a high degree of interconnectivity with the rest of the world from quite a lot of nodes, but we still see a kind of separation coming out where they've got kind of a domestic network that can exist almost on its own. And then coming off on the left-hand side, you get this kind of weird like spring side here, that's Iran. And we can pick that up quite clearly on the graph. And China's actually so far off this graph, we can't see it, and it goes out the bottom edge. So it's an interesting kind of way of seeing that the interconnectivity of some countries, and particularly the United Kingdom, where I come from, is right in the middle of this graph, so you can't even distinguish it. And then some of these other countries are quite prominent. And then the how. To look at this, we want to look at kind of what a foreign neighbor is. So this is kind of how we're calculating it here. So we have the registered location of these autonomous systems. And so on here, we have like Not Company LLC is in the UK. It relies on its upstream provider, Internet Provider Limited, which is in the UK. And then following that is connected to what we're going to call a foreign neighbor. In this case, it's going to be Hurricane Electric, which is in the US. So that's how we're defining a foreign neighbor, would be the foreign neighbor of Internet Provider Limited. So we look at unique upstream neighbors, which is going to be the number of neighbors we haven't yet seen that are not from a domestic country and are not yet seen as we move at each step. So we're going to move from that kind of first base where we're in the UK it's got a foreign neighbor, that's going to be the first unique upstream neighbor collection. And then beyond that will be the ones that set of neighbors are connected to that we haven't already seen. And this is kind of where we get this graph from here. So I've got a number of different countries running along the bottom. It's Norway, China, Russia, Great Britain, India, and the United States. And you can see there's a kind of a trend here with some of the countries where you'd expect higher censorship. In the first few steps, we're going to get a kind of decrease in the number of unique neighbors we discover. Interestingly, also, we get the same thing when we look at the United States, although it's not quite as pronounced. So it's a kind of interesting topological trend, is the number of unique neighbors is decreasing after a first one of these steps. And then visualizing connectivity, I'm using a graph format here where effectively in the center of it is going to be the most important nodes. And as we move further out, they're becoming lesser important. So they're not as critical to the kind of domestic connectivity. When we're closer to the center, we're expecting that now to be kind of tier 1, tier 2. And so if we look at this for a collection of countries, so here we've got Iran. What's quite interesting here is we're looking at the topology of Iran and its first degree foreign neighbors, and we can see where those neighbors are connected as being almost on the edge, sort of lesser importance to kind of the domestic connectivity of the country. Now I want to keep that picture in mind, and if I show you a slightly different one, this is Norway, for instance, and we see that in Norway, a lot of their domestic connectivity is delivered on the outer tiers, the lesser of importance nodes, and a lot of the connectivity they have to the rest of the internet is delivered almost centrally to this graph through some tier 1, tier 2 providers. An interesting trend. And we can see this kind of reflected through a number of countries. I'm going to show you the United Kingdom here because it's a much bigger network. We're seeing again that kind of dense mass of a lot of different colors being a lot of different countries being the most central part of the network. And on the outside, we're looking at the domestic connectivity of the country that's kind of dependent on these international providers. So an interesting kind of topological phenomenon. So looking at the why is this a thing, I'm going to suggest that potentially censorship is one of the arguments there, so kind of domestic regulation in each of these countries, and a way of implementing that is to have control of the connectivity going externally. So in this case, we're using the UNI data, so the Open Observatory for Network Interference data, and there are two different ways this to kind of detect censorship. One of them is the explicit censorship, so people are seeing block pages, or we can see that the DNS resolution is just not correct. And then we've got kind of non-explicit ways where we're looking at anomalies in the data that we're collecting. But of course, we need to mitigate a little bit for that. So we look at kind of the ratio of anomalies to normal traffic or good traffic. And then I'm going to talk here about relative upstream change. And that is, again, that same phenomenon where we look at the number of neighbors going outwards. In this case, we're not looking at unique neighbors. We're just looking at the number, so the volume of ASs at each one of these steps. And we're going to look at the change. And we're looking at that from the border. So where we're talking about that, we're talking from the domestic nodes layer, followed by the first degree of foreign nodes, and then the second degree. And if we do that, we have kind of relative upstream change going up on the left-hand side here, and then the ratio of censored and anomalous to normal or okay traffic along the bottom. And we can sort of start to see a relationship as we move at each one of these steps, so degree 1 being that first step of foreign connectivity, degree 2 being the next step. And we can see that kind of trend increases. I don't want to put too many dots on the same graph, but you can start to see the trend emerging. When we kind of accentuate that, we look at what we're going to call cumulative downstream burden, which is going to be the number of ASs that are external, that are like dependent, or the country is dependent on for its connectivity domestically. So dependent on being like connectivity to the outside world. So if you're a first degree node, for instance, you're going to have a greater dependency if there are fewer also at that tier. And here we're starting to see a correlation between the two. So as the amount of interference or censorship and anomalous traffic to OK traffic increases, this kind of connectivity burden is also increasing. So there's a kind of a funneling effect here happening where nodes are being like dependent on that are further away from the country's core. And then this is kind of doing the same metric, but in this case, it's kind of removing the duplication. So if one company is owning 5 of these nodes, then we're going to collapse that to being one company because it's got sort of one rule set potentially behind it. And we see a much clearer distinction. So what we're seeing here is the higher level of censorship is equating to a higher level of what we're going to call the funneling effect, where this is kind of bottlenecking traffic going outwards from a country. And so we're seeing that high censorship. But what's also interesting is where we're seeing high levels of funneling, you can also see there are geographical restrictions as well. So for instance, South Korea, where they've got a higher level of funneling, has neighbors that potentially aren't going to be an open internet to connect to, like North Korea or China. And so their level of funneling is much higher because they are dependent on a small amount of connectivity to the outside world. So another kind of interesting trend, also geopolitical. So one of them is the political angle, and then this would be the geographic part. So in summary, what I've shown you here is kind of the basics of this kind of internet topology fusion tool that we're going to make open source in the next week. The degree of the highest, the volume of the highest degree AES is increasing over time, but also the volume of the lowest degree is also growing. But in that mid-range, we saw that between 2023 and 2024, the volume of AES has actually decreased. And also that geopolitics is having a statistically significant impact on the shape of internet topology. And this is a trend I would expect to continue growing as censorship in different countries is increasing. So we can see that kind of relationship is existent. And if you have any questions, I'd welcome those. And if you want to get in touch, then you've got my contact details and my supervisor's contact details as well. Thank you very much.
Thank you, Josh. Do we have any questions in the room? I don't see anything. Do we have something in the chat? Oh, Tobias then.
Tobias Wiewig, Max Planck Institute for Informatics, speaking for myself. So you had these interconnected graphs, which showed Iran to be less connected. And like stupidly thinking about that, I would assume a similar picture if, for example, there was no LGI in Iran, there was no Deutsche Telekom Iran, and no Telefonica, no Orange, which in Europe usually have pretty state boundary crossing presences. So you can get, like, from a subsidiary of LGI, you can get Ziggo in the Netherlands, you have Kabel Deutschland in Germany, similar things with Vodafone. Did you account for that?
Yes, quite a bit so. So a lot of the data here is a little bit biased by all the kind of major peering connections that are with the root collectors. But if I expanded the graph slightly, you would start to see these ones appearing. So Telefonica in particular, I've seen quite a lot appearing in the data as being a kind of major interconnection provider. There's more work to be done, but hopefully if you can use this tool afterwards, then you'll also be able to detect exactly the same phenomenon you described, particularly the networks that cross state boundaries. So at the moment, this is looking at registered ASs, but the data set itself does contain the countries that we see networks appearing in.
Okay, thank you. We have a comment from the chat.
Not from the chat, myself. Question for you. Antonio Prado. I would like to know about censorship. If you counted HTTPS common name errors in your statistic when you redirect a page to a landing page from the authority, for example.
Yes, that would be like explicit censorship, where like the traffic is redirected. So it wouldn't be the page that would be used in the controlled test. So we have kind of a data set in the uni approach is that they have a data set of normal, like expected pages. And then if it differs, then we can see that that's either going to be anomalous or an explicit block. And in this case, it would be explicit.
Okay.
Hi, and this is Irene Milosevic with the Cooperation Working Group. We usually discuss geopolitics there, but thank you for presenting that tool here with us. A point of clarification, in your presentation, you talked about the length of a digital path going from 3.7 to 12. Could you just a little bit explore why do you see that and what path length is actually going, in which parts of the world is getting more lengthier?
I think in particular, the parts of the world is growing lengthy. So this is taking just a general average, is not kind of counting for bias in certain areas, in particular places like China, where they have a really strong domestic connectivity that is not dependent on the outside world at all, is skewing the data slightly. And the same with Iran, where we saw that kind of jetting off the side. So countries like that, where they have a really high degree of censorship, their topology is fundamentally quite different to those of where the kind of topology is amalgamated with the rest of the world. So that is skewing the data slightly as well. So that's the kind of main problem. But
so it's within the national boundaries, as you say.
Yeah.
Thank you.
Vladislav Odopian from GLAV. I have a question. If you accounted sudden change of upstreams, like we observed in Ukraine in regions that were occupied by Russia, the local providers were forced to change to Russian upstreams so that all the traffic could go via Russian upstreams and get censored.
This does pick that up. I haven't looked at that here, but that is definitely something that we have seen. And I know there's an interesting paper by Louis Petinaut that looks at that in much more detail, particularly in the context of Russia and Ukraine.
Okay.
Peter Hessler
Here,
from Zayo.
and then you, and then I'm closing the queue.
Peter Hessler from Zayo. I have a partial or a potential answer for why the AS path could have extended. It has to do with the BGP selection algorithm. And the first, so you check if it's valid, then you check the local preference, and that's a operator specific value, and then you check the AS path length. And it's very common for a lot of medium and small networks, and even for large networks, to have a better local preference for peers versus for transit. And so that's a very easy way to see massive explosions of the AS path length. So one potential explanation for that.
Yeah, I think I've seen a little bit in the data because it's very difficult to work out explicitly from like a no knowledge perspective of what's happening within certain networks. I think it is notable though that we have seen it only in very recent years, and I don't think that's necessarily the most recent trend. So I think there's possibly other factors as well, but that might be a contributing one too.
Okay.
Yeah, so Sebastian from GVDG. So I'm asking about, did you consider to look at the EU as maybe one country, also to look how it changes, because it's like a huge economically interconnected block, and like comparing it to the US would probably be fairer if you didn't consider all inter-EU peerings foreign.
Yeah, if you remember the kind of massive splat graph quite early on, if we remove the EU from that as a whole, the splat graph doesn't really change much. So yes, we have looked at it. Kind of the EU as an interconnected region is arguably closer to that kind of utopian idea where we see a really high degree of international connectivity, but fundamentally the rest of the world's internet isn't kind of dependent on, or the shape of the rest of the world's internet isn't dependent on that.
Thank you very much.
Thank you.
Our next speaker is Tobias from Max Planck Institute for Informatics. And here we will take a step back, and he will talk to us about the state of general internet measurement projects in academia and what can potentially be done to help them.
So welcome everyone to my reflections on active network measurements in academia, and a couple of the other ones too. So this is a bit in the context of a project called Measurement.Network, which also is supported by the RIPE Community Fund and a couple of other members of the community, for which I'm really, really grateful. And I think we should first quickly talk about what network measurements are. It's basically the thing we do, well, as academics. It's also kind of what you do as an operator. It's called historic monitoring, and you do it to figure out what your network actually does. And we as academics, we don't have our network on our own. We just do that for the whole internet. So it's kind of important for us because we get papers out of that. And for, well, practitioners, if you run your own network, well, you want to know what it does. And if you're, like, for example, doing protocol development, you want to improve protocols. You can do them active or passive. Passive is the easy part. You just listen into things. The active part is the one where you take a stick and poke at things. And well, sometimes things are not that happy to have been poked with a stick. That makes active ones a little bit more difficult. Academia, another term to introduce, that is basically the place where we all go to study, learn, and do research. And academics like me, I might not be the best example of one, but people like me are the ones that are there to do the studying, teaching, and learning. You have different levels of education. In the European region, it's usually bachelor, master, PhD. Bachelor is quite simply put, you show that you can do stuff when you're told to do it. A master is that you can do stuff without being told what exactly to do. And then the PhD is a pinnacle, because there you demonstrate that you can actually come up with stuff yourself and then actually also do it. Those people usually do that after they graduated their master. the purpose of academia is that we want to find new knowledge, new technology, make the world a better place, educate people to go out into the world and make the world a better place. And one other thing, we do have our own currency, which is research output, papers, renown, and fame. So why can I talk about academia? Well, I have actually spent quite a lot of time there. So I got a Bachelor of Science degree, a Master of Science degree in System Network Engineering, and then I actually did a PhD. Used to be like a teacher at TU Delft, and then switched over to the MPI for informatics. And I also know a little bit about ops. So a lot of people here know me for probably, well, somewhat longer than I have been known in academia. I basically always have been pushing packets around, setting up systems, running infrastructure. My little hobby AS is, well, equipped with a larger AS cone than some professional ASs, and I think we will hear about personal ASNs later today. And yeah, I kind of do both. Disclaimer before we now go into the contents of this talk, my work is not perfect, and I don't claim it to be. My work actually usually has like a lot of bugs. And in practice, we tend to be all just cooking with water. So like these are mistakes everyone, including me, tends to make. The examples in those slides are from my work, right? Except like one or two, but those I think are fair. Simply because I want to make the point that these things happen. This is like a general systemic thing. So also please don't take it as like, oh, those academics, they don't know what they're doing. Don't hate the people, hate the game. So let me do what I can do best, which is stupid stuff. Stupid stuff in this case looked like this. This is my mail setup being a bit more enthusiastic. You might notice it says like SMTP is kind of not a thing, and my MySQL is also doing like 400 queries per second. And my OpenBSD-based mail server is a little bit busy. What I did is I put like trace, or the OpenBSD equivalent, to the process, and I figured out, well, it's kind of complaining because somebody tries to log into my mail server with, well, characters that are not contained in Latin 1_Swedish_CI. So the query fails, and the server is like, oh, query failed. Maybe I should retry it up to 400 times a second. Now, this was basically, well, this was most likely internet background noise, but in a way it was still kind of somebody doing an active measurement against my system. My system was in a little way special, and then it toppled over. Let's do something else. Let's do email security. And I mean, email is kind of the thing which BGP people look at and say like, well, at least I'm not doing something complex at that. Granted. But it has some interesting things. And one of those interesting things is a sender policy framework where you can say like which IP addresses are allowed to originate emails for your domain. One interesting feature it has is include. And if you can include something, you can often do recursion. And if you can do recursion, that quite quickly smells like denial of service. And the RFC actually says like if you include things in SPF records, you should only do 10 lookups. And I mean, we all know if the RFC says you should only do or you must only do X things, all implementations out there will behave according to that. Yeah. Anyway, you get really excited as a researcher because you smell a paper. That's like the thing that keeps you going. And you want to see like, is this really a problem? Because what sells a paper is like large scale impact. So what you do is you go to Stack Overflow, DNS server, Python, because you know Python, and copy paste together a quick Python DNS server. Try a measurement by just sending people to an eternal SPF tree. And it turns out eternal trees are something some of these mail servers are actually recursing. Sadly, while doing that, they don't really do that mail processing stuff anymore, which might make users a bit unhappy. In addition, you recently moved institutions. You're running your experiments in EC2 because your previous and your current institution, by the way, not my institutions, this is from a collaborator, and I was involved in that work, Both kind of outsource their IT, so everything is in EC2. And the delegations for your DNS kind of fell victim to that, so people don't really know that it's you doing those measurements. So you had a couple of mail servers falling over and people who couldn't reach you and didn't know who was kicking over their their mail servers or how. So after you have gathered your data, you're really happy because you have a nice finding, and you approach an operator mailing list, and they are like not necessarily happy with what you did. And you're a bit confused. You may be also a bit hurt, or actually get one of the more stronger winds of operator opinion after toppling their systems. You can also then think about like running more reliable networks. You try to get a mail server that won't have those bugs. So you opt for like the YOLO Colo mail setup, and you just try to use that instead of your self-written Python server. So you clone the Git repository, you do your Docker Compose up, and you see this, right? And you have a mail server VM running, well, Docker container, you have a recursive resolver that does things, and you have your authoritative DNS. Yeah, thing is, DNS is not really a UDP-only thing. So all of a sudden, your measurements might have like this little bug, especially when packets get too big. Let's say because there's an RRSig attached to an RR set, which is kind of not that good for the quality of your results, but you maybe kind of don't notice. Also, maybe your DNS resolver just stops resolving because you just did Docker Compose up. There's no real-time monitoring. Maybe the DNS didn't get delegated, which is something we actually stumbled over. Or your recursive resolver is just a stub and forwards to one of the quad resolvers like, well, I would now say everyone, but I think the better word would be far too many people are doing in general. So you don't even know when you see something hitting your authoritative, whether it might have been an artifact of your network measurement setup at all. If you want to do security stuff, it gets even more fun. So we wanted to do some SSH-related scanning. And the poor PhD student had a very nasty colleague who happens to have his own personal AS. No clue who that was. And the PhD student was forced to like test the measurement setup. And for some reason, there were some hosts in that AS not being found. All packets are going out, like the SYN packets. SYNAC comes back, leaves the AS that is being scanned, but they never arrive at the scan box. No clue why. The reason was basically that the scan server had ETH0, which had 192.0.2.23/24 for management purposes, and then a bond with 192.0.2.42 in the /24, and the scan traffic should go out there. And to make that happen, there were rules installed that said like from 192.0.2.23/24, look up table 101, and corresponding table, sending it via ETH0 because that's basically the management traffic, and the same thing for 102. Somebody see the issue? Well, in the rule it says /24 as well. And because Linux in this part of setting networking rules does not require networks to be networks, the first one matched the whole /24. And that led to a very weird interaction with the Cisco switch on the other side, which made half of the packets arrive at ETH0, even though they should have come into the LACP. And yeah, then we only saw half of the packets. Anyway, security, I said, and this is what you would see on the other side of our scans. We're not actually attempting authentication. We're doing something that looks like authentication, but I assure you it's not. But it's still a great opportunity to make many non-friends via the partially anonymous chat service under AppUseAd. And we are actually reading that. So That is one that doesn't go to dev null. And it's an even greater way to get the organization's whole IPv4 prefix kind of block listed. And it's an even more amazing way, because you're sending SYNs to all IP addresses within the internet, to find all the hidden middle boxes in your organization's network. So usually large-scale active network measurements are a great way to get into contact with your IT department. They are usually not that happy about that, but it works. In addition to that, the internet just tends to be very, very complex and law-driven. Right? So understanding how the internet works is difficult. Just ask yourself, with whom do you peer, and with whom are you actually peering? And then ask the same question to your contracts department. And I'm pretty sure most of you don't really want to ask that question to the contracts department. Another thing is that, like, as I said, I have my own little AS, and I do have some form of AS cone there under. And if you use analyze data for network measurements, I, for some reason, upstream 2 ISPs, one insurance company or finance company, and one media publishing company. I can assure you it's all personal ASNs we will be hearing about later. At the same time, you also, if you talk to researchers at conferences, you often hear things like, well, peering agreements are generally established between the legal departments of 2 corporations and then communicated to IT for implementation. And I mean, that one wasn't even a joke, right? It's like, it's reasoning about a world you have never experienced. Network protocols, on the other hand, are even more complex. So whoever put the S for simple into SMTP and SNMP also put the L for lightweight into LDAP. And whenever I figure out who that person is, I will have a strong chat with them. I ask a developer for a widely used DNS server, who may or may not be in this room, whether it would be feasible for a person to write DNS software after roughly 1 year of working on or with DNS that can be safely run against the internet without breaking anything. And the reply was, well, I wouldn't even trust myself to write some new DNS software that does not break anything when thrown against the whole internet. Because, I mean, it's DNS. Well, at least it's not mail. So if you want to write reliable measurement software, you have to be aware of the internet being full of corner cases and like all the unwritten, undocumented law-based rules of protocols of your choice. And you have to build something reliable, ideally reusing as much tested and working software as possible. To be able to do that, you have to be an experienced programmer that is able to just write really good software. I mean, many people are looking for that kind of person. You need version control, you need tests, proper development process. If you want to run these measurements, and like writing the software is only one part, you have to operate it, you have to run the measurements. You have to be an experienced system operator that can debug things like this little ACP issue before. You have to know about all the tools involved in doing that. You have to monitor your stack. You need historic monitoring to figure out, well, do I run into an bottleneck? Is it maybe just my disk performance I'm measuring when I do these RPKI measurements? And you also need to know whether it still works, so real-time monitoring. You really need an end-to-end understanding of the stack you're using to measure, as well as of what you are measuring. And that whole thing needs to be self-contained. So no outsourcing, no, yeah, we put that into AWS, because whenever you do that, you introduce random unknown variables that might influence your measurements and might just make for a very, very exciting thing you're analyzing. And all of that needs to be ethical, right? There's one very fun thing about like the internet being made from duct tape and bubblegum, and I think there are many things we know that are issues, so we just don't talk about them. If researchers find them, they're like really, really excited, because that is a paper. That is a paper for sure. You need to get ethics approval from ethics departments that often don't even know what the internet is. I'm exaggerating here a bit. You need to have proper property protection going, so you need to be able to set reverse DNS. Negotiating that with an IT department can be a bit challenging. Ideally, you also want to adjust the whois, you want to run a web server, you want to have 24/7 app use, and you need to maintain a block list. So the PhD we need is all of that combined. It's not a PhD student. It's basically a whole IT department. And that bites into the reality of a PhD. That means 4 to 8 years you're working on a topic during which you should churn out like 4 to 6 top-tier papers. It must be new research advancing the field. It needs to be embedded in related work, meaning you have to read that academic related work. And you, of course, also have to do all these, like it's basically a whole IT department things. And you do that after a bachelor degree in the US or after a master degree here. So in terms of industry experience, that's like juniors, right? People joining your organization, show them the ropes, you mentor them, teach them how the stuff works. At some point, you take them with you to a RIPE meeting, and they learn it. With the difference that there's a clear timer attached here and that there's no seniors there. And ideally, if you look at like 4 divided by 4, the first paper should already be under submission after roughly 1 year. And then the most important rule of all bites. People under pressure will do people things. You just take shortcuts when you're under pressure, when you feel like you're drowning in work, when you feel like you're trying to scale a mountain that is just too big for you. And that ties in with something called the LPU, which is the least publishable unit. It's usually a lot easier to publish what is novel or flashy and has impact. I mean, we all probably had this like, oh God, not again, moment when we saw yet another vulnerability coming along with its own logo. The least publishable unit of we spend 6 months on engineering, often used as a funny term in reviews, which was really, really challenging and we learned a lot, but it did not impact or change our results. Well, apart from making our results more reliable, the LPU of that is 0. You can actually get reviews which are like, well, this was a lot of engineering effort, but where's the science? In addition to that, academia is very, very competitive. You're measured. You're constantly measured, and not in the internet measurement way. You're measured on the number of papers, on the number of supervised students, number of acquired grants, on the committee tasks you're doing, on the courses you're holding, on the quality of student evaluation. There's just endless metrics. And there the truth is, any sufficiently evaluated metric for those being evaluated is indistinguishable from a game. So people will try to game these metrics. And at the same time, there's always somebody who is better at everything at the same time than you. So what you need is more papers, more diversification of your research interests, less going into depth into one thing, just taking the shotgun approach and trying to get those numbers up. And sadly, some things you need to do to, well, get that going are things you kind of only learn by doing them, like running networks. Some experiences you simply cannot tell a person about. They need to have felt that. I mean, just the shock of the CLI freezing after you issued a command and you're like, was that commit or commit confirm? And then you go to your car. I mean, those moments, you can't tell people about them. They have to feel it. And that is basically why measurement.network was born as an idea. The idea would be to change the game a little. Core idea, you have some infrastructure where active measurements can be run from, which is kind of good for general equity because there's a lot of organizations like universities where especially junior people do not have access to that kind of resources because, well, if you're like a senior person and go to the IT department being like, we need this for our research, it's easier than when you just started. Ideally, this should not be tied to any organization with a publishing incentive. This is also why this is not in a main funding stream of the MPI, because it shouldn't be an MPI toy. It should be well known and blockable, so people can just, discard it without being scared that they are currently blocking EC2 prefixes, which then 2 weeks later might host a learning management system. And it should take some basic ops tasks of the place of researchers, like monitoring base infrastructure, DNS, ensuring unfiltered PPS can be reached. It should make more things accessible because it's relatively easy, for example, for researchers to get an ASN and temporary prefixes. What's not easy for them is knowing that this is possible and knowing how to find and contact an LIR. Which sounds like, well, if you want to find an LIR, you just chat to one on a RIPE meeting. Like, no. Like, that world is somewhat removed. It's like looking at this externally, they just don't know. And in addition, it should also support other scientific processes, like, for example, reviews, and it should loop in people who actually did and know about things before there's some unhappy XYZ NOC mailing list threads that have to be started. Currently, the progress is that there is an ASN and also another ASN, which is now also part of this project, which we will be talking about in the V6 working group. Some IP addresses which you can block. Thankfully, some upstream. I'm upstreaming myself, but it's heavily prepended because main upstreams are LWLCOM and OpenFactory and the community IX, which we heard about yesterday. There's a couple of Juniper routers being deployed, a couple of servers. Things are being set up. Some first measurements as test cases were run. And I'm now approaching the point where I do have a review system patched and configured. So most likely some of you will get annoying emails from me trying to recruit you to, well, adopt and mentor a couple of academics. They're really nice. So key takeaways. Academics try their best to do good work. The realities of academia tend to stand in the way. There's still far too little actual interaction between academia and people running systems. And Measurement.Network is a fun project aimed at making research more reliable, accessible, and tight in practice. So consider to review, mentor, and contribute. And with that, one last note. The problem of engineers is that they need to be artisans and scientists at the same time. And universities just make scientists, and the other education paths just make artisans. We need both.
Thank you very much. I will start using my microphone privilege to jump in on one important thing. I've been through all of this and I made my fair share of dodgy measurement campaigns. So one question for you. I mean, I strongly think everyone in this room should support and try to support your project. But do you have any hints for this community how to actually interact, support, and help researchers that come into our community and want to take part and want to improve their work? What should we do?
So the thing is, what I believe would help is if researchers would have the time to, when they start their PhD in network measurement, to spend 1 or 2 years first as an intern, junior in industry, and see it. Because that is the most valuable thing the community could do. The problem is that academia is not leaving the room for that.
Agreed. Brian?
So Brian Nisbet, HEANet. So this is fascinating. I love it. And obviously I can't speak for DFN, but I'm hoping that this is something you can speak to NRENs about and can maybe speak to Géant about as well in relation to getting, the academic, because TNC, which is the NREN conference, is in about 3 weeks' time. And I would have loved to have seen this as at least a lightning talk at that event to bring awareness there. And I'm hoping you might look into that for next year. But have you had any conversations with any NRENs or with Géant about any of this? Because it seems like a really good place to talk to people about it.
So you might have noticed like the before prefix kind of looks like a legacy because it is. So that came from DFN actually. I talked a bit to them, but I think one very important aspect of this project is to keep it a little bit away from the traditional path of academia. And I want to hand it over to some non-publication incentivized or academia related governance function body like the MET working group here, or maybe in the RTF, simply to kind of protect it from this A, it's not my toy, so I don't want to play with it, and B, to ensure that it doesn't then ultimately fall into the same pathways we had for the past 20, 30 years in academia, and it remains something that independently helps instead of just being another one of those we have a lot of already.
Cool, thanks.
Peter Hessler, speaking as a private individual. You hinted at this in your talk, but I was curious if, so as you know, there are many standards to choose from. Some of them are truthful, some of them are blatant lies. Have you like collected any resources to help academics understand which standards they can actually believe and which ones are, take a grain of salt and which ones are just ignore it and here's the real information?
So you're asking for standards.
Like for example, in the IETF, the RFCs for BGP, relatively reliable, relatively well actually followed. The RFCs for HTTP and HTML especially less so, where most of that is done in another body. And then the standards for email, for example, are, YOLO. And kind of helping researchers understand where those boundaries and where those restrictions are.
I do a lot of work on email and would like to disagree but can't. But point being, it depends, right? It's like what binds us to our colleagues in the legal department. Well, you ask a lawyer a simple question, legal one, and they say, well, it depends. And you ask an engineer an even more so simple technical question, and they are like, it depends, and you get a 90-minute lightning talk. So I don't think that you can do this with guideline. You need experience. You need the ability to evaluate these documents, assess how the industrial law has developed, the role of different bodies, the incentives of different players, why certain standardization projects are moving to other standardization bodies, and that's something that's like that freezing shell. You need to acquire that skill.
Okay, thank you.
Thank you. Do we have anything?
Yeah, we have a comment from Sergei Myaserdov from NetArt Group. I think it's related to the first part of your presentation. Running a UDP-only DNS queries, even for the measurements, sounds kind of weird or too far away from the real life.
Oh yeah, it was a bad example, but I can sadly assure you it's on the level of things you sometimes just find.
We've all been there.
Yeah.
Okay. I don't see anyone at the microphone anymore. Okay. Thank you, Tobias.
Thanks. Bye-bye.
Next up is Jan from Akamai, and he will talk to us on who actually owns all of this V4 space we keep talking about.
All right, let me see. Here's the clicker. Wonderful. Jakcimesh, quick show of hands. Who here speaks Polish? All right. You guys can already tell that I don't, right? So on my flight over here, I asked Duolingo what's important to know, and I came up with chłopiec je chleb, which means the boy is eating an apple. And the boy is eating bread, and the man is eating an apple. So you can tell we are already in Monty Python, dirty Hungarian phrasebook territory over here. But okay, so I was going to talk about centralization in the ownership of IP blocks. And I'm fully aware that I'm the last thing standing between you and lunch, but so bear with me. We'll try to go through this. I'm, from the internet, I'm here to help. And my idea of being helpful is generally to complain about things. I mean, to point out interesting findings, such as that RIPE NCC actually is a redundant acronym since Réseau IP Européen translates to European IP networks. So we have the European IP Networks Network Coordination Center. Or that this particular map that you've seen before is a lie, which kind of gets me to the topic that I'm going to talk about. But before I do that, there's one more thing that you really need to know about me, which is that I have no idea what I'm doing. I work at Akamai as an information security architect. As the great George Costanza said, I always wanted to pretend to be an architect, right? But that is information security. That is not networking. So my colleagues from Akamai here probably are like, what is Jan doing up there? He doesn't do networking. And that is oftentimes what I try to do. I try to throw myself into the uncomfortable situation and talk to people I don't normally talk to. So you get a little bit of an outsider's view here at RIPE, where you all have a lot more expertise than me. So keep that in mind when you're asking questions and saying like, why didn't he just? And it turns out the answer is, I don't know what I'm doing. Anyway, so let's get started. The year is 2035, the year of Linux on the desktop. This one's going to be it, right? IPv6 is next. We're going to get there as well, I promise you. And of course, Amazon has just bought the last available /8, 255.0.0/8, and now owns all IPv4 space. How did we get here? Well, I'm going to suggest that 2035 is perhaps even too far. At Amazon, you find that they are already using internally the 240 network, Class E, for internal routing, right? So that's going to be great fun when at some point we decide, oh, we're actually going to be using this network. And then Amazon said, like, well, you're going to break all of EC2 if you start announcing this somewhere else. So it'll be fun. I actually tend to think that what the future really wants is probably more IPv6, not IPv4. But as I said, maybe we'll get there by 2034. So how did we get there? We started out and we were told that IANA assigns IP space to the regional internet registries, right? But of course, some people early on got a gift from John Postel, the original IANA. They got their own /8 at the beginning, right? And some organizations got also additional IP space. So the distribution was not completely fair, really. If we're looking at IP space just purely by IP, then we can see like the division of space that we have here. The reserved one includes the multicast and the Class E, etc., as well as the other reserved networks. So if we take those out and just look at available IP space, then we roughly see how IPv4 is allocated to the rears like so, which is not quite even. Just for kicks, comparison in IPv6 space is a little bit more even. IPv6 is a lot more boring in this regard. I'm just throwing it up here as an example. But yeah, so IPv4 space, we started running out, and then they were being traded, right, and reallocated. So blocks were given from one rear to the next one. They're being reassigned, reallocated, etc. So things are moving around. And people started buying IP space, right? So you can actually buy IP space, which comes in really handy if you happen to have a spare /9 lying around and want to make some money. So you can actually sell that IP space. And to my friends from Amazon here in the audience, I'm just riffing on you. It's, you know, nothing personal. There are other companies that do the same thing, right? You know, Google bought also plenty of IP space, and other companies do as well. But so you see that, like, you know, IP space is being traded, being sold, etc. And of course, really cool thing, AWS at some point decided, you know what, these are worth some money. We can actually, you know, charge people for that. And I started this whole talk basically by stumbling across the AWS IP ranges and going like, wait a second, that's a lot of IPs for just one organization to have, right? I mean, that's a fair bit of number of space that is available. And that's just AWS, that they're just saying that these are the ones that we're using here. Which, by the way, by their logic of 5 cents or half a cent per hour per IP adds up to a net value of $6.4 billion effectively, given that IP space. So it's not too shabby. Anyway, so like, again, IP space is being traded and traded and traded. And I was thinking to myself, wait a second, how do we actually know who currently owns what IP space? Now, in theory, we know that we can find out this information, right? We have the means for this. But how can we look at this comprehensively? Can we find out on a larger scale which different organizations own which particular parts of the IP space? And so I went like, I know, I'm going to use Whois. And you can tell that I already told you I don't know what I'm doing, right? Because Whois is great. Whois is neat because you can just look at this, and as a human, you're like, oh, yeah, I can make sense of this. This is great. But Whois uses different formats depending where you end up on. It's all free text. And so after a while of processing this at larger scale, you just think to yourself, wait a second, this is not going to work out so well. So maybe Whois is not the right approach to this. So you say, like, wait a second, I know, I'm going to use the real statistics that they're publishing so nicely on the different FTP sites or HTTPS sites nowadays. And this is what that looks like. And that is really helpful. So you have this file that tells you which IPs start out with, and then the count of IPs given for that particular assignment, including even some geolocation information. And that is really useful, and it's great. But it doesn't tell me who the IP block is assigned to in this case, right? So all I know is like, oh, there are these allocations, but I don't know who it is assigned to. So like, I know, I'm going to use RDEP, because RDEP is defined in the RFCs. So many RFCs. And it's using JSON, so I can actually process this a lot better, right? And this is kind of what that looks like. And that is really useful. That is good information. You've got, nicely structured data there with some of the information that we might be looking for. And so I went ahead and did the obvious thing. As Tobias said, people do dumb things sometimes when they're doing their research, and that's kind of what I did. I was like, you know what? I'm going to start at 000 and go through all the IP space and hit RDEP for that. Basically going like, okay, well, I'm not going to hit every IP address. Don't want to do the 4 billion lookups, but I can hit the first one, see what the CIDR is, then jump to the next one and move on from there. And so the problem is, if you are dealing with multiple ways of looking at information, and if you're trying to look at sources of truth, and I'm sure all of you know this, like if you've ever looked at your inventory database or something like that, assets you have, you know that there's a set of things that you have in the database. And then you have the set of things that you kind of know should be there. And then you have the set of things that you're actually seeing out there. And those three things at most intersect. They're not congruent. And that is a problem I've seen many, many times. So it basically means that, yeah, we have a three-body problem right here. So back to RDEP. Yeah, that's the thing about RDEP. RDEP is great, but you run into a couple of things. Sometimes you get a redirect to the other RDEP server. Sometimes there's data in there. Sometimes there isn't data. Okay, you can deal with that. Redirects, of course, mean that sometimes you have redirect loops between the different RDEP servers. So that's an issue. RDEP doesn't include the AS information that I might be looking for, but whois has that information. So I have to, mingle those again. Afrinic has API limits, but they won't tell you what they are. I asked them, they said, we're not going to tell you. I said, okay, so I hit them, I get a 429 back, which is good. But there is no retry after, so I have to guess. The Brazilian RDEP server has an API limit, and they tell you what it is. They tell me 1 request for 20 seconds. After that, you get a 403, and you're on their shit list for a long time. So you can't do this, as conveniently, so you have to rotate IPs to source IPs and get the information that way, which isn't in their spirit either. And then you have all sorts of other issues that come after that, right? So like RDEP is wonderful, has a lot of useful information, but at the end of the day, it's the same kind of garbage in, garbage out that whois is, only structured in JSON. Which, is progress. It's getting a little bit better. Anyway, so, and yes, this actually now says my hovercraft is full of eels, for those of you who know MentiPython. Because this is how I feel when I'm either looking at this data or I'm in a meeting like this, which I normally tend to avoid. But so now I have this data and I'm starting to analyze it and look at it. And so it's like, okay, so let's see, whose CIDR is it anyway? So I collected all this information and I looked at like how many CIDRs are allocated for the given countries. And I came up with 238 countries and roughly 300,000 different allocations. Well, now, countries is, of course, relative, right? The UN counts something like 196 or something like that. We have over 300 ccTLDs, but all right, 238 countries, ISO 3166, two-letter codes anyway. So just by counting how many CIDRs are allocated, these are the top 10. So I found that Russia leads this, has about 17,000 CIDRs. Germany is second, Brazil is third, and so on and so on. But that is just how many CIDRs are allocated. And that could be a /32, that could be a /23, this could be a /8. So it's not really meaningful information, right? It just tells you how many there are. So I said, okay, let's go for IPs, counting who has most of these IPs actually. And so you find that the US and China are the first two with quite a bit of them, and then the rest of the top 10 show up like this approximately. But notice that the US over here with 1.6 billion IPs covers about 43% of all available IP space. The top 10 account for 75% of all IP space, and the top 2 for over 50% of the IP space. So that's, again, not evenly distributed across the different markets. I broke this down by regional registry, but first IPv6, a lot less interesting because we have so many of those addresses, right? The only interesting thing here is I found that there are some countries that don't have any IPv6 allocation. So the Central African Republic and Eritrea over here, or North Korea. Then we have Kosovo, Western Sahara, Jan Mayen up there, Falkland Islands or the Malvinas for los Argentinos, and the French and Arctic territories. Okay, those are not so surprising, but there are some countries that don't have any IPv6 space, apparently. Anyway, so for Afrinic, it looks like this. And now think back to the original map that I showed you where I'm saying this is a lie. Afrinic apparently hands out IPs, or at least has IP allocations for observed 127 countries. The first 3 are South Africa, Egypt, and Morocco. And then the remaining top 10 still all reside within Africa. And I'm going through this, fairly quickly. Those slides will be available. I'll put this up on the blog later on. You can dive into this on your own time. But again, you see centralization there, where a certain number of allocations are concentrated in certain markets. For Afrinic, this does not even completely overlap with the expected population charts or even economy sizes, which we will see in some other markets where this aligns a little bit more. Like APNIC, not surprisingly, covers a lot of Asia. China, not surprisingly, will be one of the top players, the first one, and then Japan. And here are the other ones as the top 10. There again, the top 3 account for 75% of all the IP space that APNIC has. ARIN, obviously concentrated in the US. Interesting thing there, whoop, let me go back. The US covers 95.4% of all of ARIN space, covers 36% of all IP space. LACNIC is a little bit more concentrated in its assigned market, so to speak. But there again, top 3 account for the majority. RIPE takes the first place with 164 countries, which is quite a lot, more than just Europe, as you might expect. But at least the top 10 stay within there, approximately. All right, I then looked at what types of IP space are they actually, right? We have different allocation types. And of course, each rear uses a different kind of string for this because the RFC says type is a string. Okay, cool. Now anybody can just pick their string. So Afrinic uses 7 different types, ARIN 4 types, APNIC 5 types. LACNIC, I couldn't find documentation, but I found 5 observed. RIPE has 11, but I found only 7 in the wild. So again, you have this really diverse set of data. Breaking it down looks like so. It's like, okay. And this over here is from APNIC. That is like, to give the distinction between what these different things might mean. But different things mean different things to different rears. So it's difficult to view this and say, like, this is this and this is that, because it might be depending on type. So for Afrinic, we see these over here. And what I really care about is not so much the allocations to local registries, but more the allocations to the end user, right? Like this is kind of what I care about. And so for Afrinic, those are assigned PA and assigned PI. So we can only focus on those for this particular aspect. APNIC has these distributions and uses assigned non-portable for end users officially. And if you're wondering why there's such a large number of unknowns, it's because, well, JPNIC RDOP sets the type to null, literally null, not the string null, but null. So that's not helpful. ARIN uses assignment for end users, although of course sometimes, going back, there's lag here. There. There we go. Sometimes the direct allocation is also an end user, because now we have to decide what actually is an ISP, what is a local internet registry. Is Amazon one of those, perhaps? Right? Because you could argue Amazon uses EC2 or AWS. There are other people there, so it reallocates things. Is a bank that uses IP space for its ATM network something that reallocates things? From my perspective, they are really just still that same organization, so I care about them as well. LACNIC uses assigned and reassigned over the year and is in the enviable position of having unallocated blocks in this case, show up like so. And RIPE NCC uses these types. But we also have legacy. Legacy, of course, again, is another type that may or may not be end users. I also looked at the slash sizes. So what is the most common allocation that we find? /24, not surprisingly, takes the lead over there. People tell me that pie charts are stupid, so I should use a Pareto chart. So here we go, same distribution. /24 is the big one. Something that's interesting is there's a large number of /32 assignments that we have, but of course we also have a bunch of /8 still. LACNIC is the only one that's an outlier, with a /22 being the most common assignment, which I thought was interesting. And by comparison, IPv6 looks like so. And hey, /24 is also the same most popular allocation for IPv6. Of course, that's like 2 dazillion IPs versus 256, but they share that in common. Anyway, so then I went to net names. I was like, okay, now let's try to find out who they actually are, these different networks, these different allocations. And net names look like so. And then I went like, okay, now I can count them by IP just instead of just frequency. And I have to somehow map these strings to the actual organizations, which isn't easy to do necessarily because that data is or is not in RDAP. That's like Schrödinger's data that we have there. We don't know. But you can correlate to some degree. You can also identify AS numbers correlated to the different networks that you have. And again, you'll notice that we have a many-to-many mapping there, right? We have multiple AS, multiple net names, multiple identities. And of course, different organizations show up multiple times because they still are the same entity, but they have different identifiers. And if you want to correlate that, you have to actually know that that Level 3 and CenturyLink are the same company nowadays, right? Companies purchase each other and take over IP space, so it's not easy to look at this. I found about 63 distinct AS. If you just go by AS count, it looks like so. Again, these are assigned to these different companies. Something to note, there actually is a Stark Industry Solutions, like Stark Industries, like Ironman, his company. There's apparently a British VPS provider that uses that name. All right, top AS by IP count. Again, looks like so. You break that down, and then you merge all of these things. You take the net names, you take the top IP count, you take the AS data set, and eventually you just have to do it manually for the most part. And so what I then came up with is basically the top organizations as combined by IP count look like so. DoD takes the cake, not surprisingly. Then we have Amazon, China Telecom, AT&T, Verizon, etc. As chunks of all IP space, it's DoD with 8.9, Amazon with 4.21, and so on. What's interesting here to me is that there's 2 companies that are different from the others. All the other ones, except for the DoD, right? All the other ones are telecoms. All the other ones are ISPs, telecom providers. Amazon and Microsoft are the only ones that are not. And they control a sizable chunk of IP space. Anyway, so rushing through this, whose CIDR is it? It's really hard to tell. Distinguishing between the end user and what becomes an ISP or an LIR is really difficult to make that call. There are a lot of inconsistencies in the rear definitions across the rears. So that again makes it difficult to get a global view of this data. There's inconsistent data in RDAP, looking up information. Sometimes you get back the first name of the person who is the contact. Sometimes you get the company name. And so it's difficult to then correlate that. The rears seem to be a lot less regional than you might initially expect based on the trading of the IP blocks. About 30% of all IPs appear to be managed by just 13 organizations, which for a global internet is, a different thing. It's, less distributed than we might like. The DoD still controls over 8% of all IPs, which is great fun because you may remember that a few years ago, all of a sudden they started to announce this IP space that they hadn't previously announced, like the 11/8, and half the internet lost its shit because they're like, crap, you're breaking me because I'm hogging your IP space internally. As I mentioned earlier, not a good idea to do that. Of course, those are still being announced nowadays. So Amazon and Microsoft take the two as non-ISPs, the two top spots there. And IPv6 is a lot more boring. And I think I like boring. We should do a lot more of that. Anyway, so that's my talk. Dziękuję. I will make slides available. Slides are already available. I will also put this on a blog post. I know I rushed through this, but all this data will be made available so you can dig into that. And before you go to lunch, we can answer questions if there's time. Thank you.
Thank you. Here we go.
Thanks. Jim Reid, just a random punter off the street. Interesting work, and I appreciate the problems you have because of these inconsistencies between how data is stored at all the various RIRs and all the repositories. But I was wondering when you were looking at your talk, if you had considered using RipeStat as, as the initial starting point for your data mining exercises.
Yes, I did consider that. I looked at that. What I wanted to do is get an IP of what is allocated, not just what is being announced. And that was the main reason why I excluded that data set, not to get like another part of the elephant that I'm touching blindly there, right? So there's a lot of IP space that is assigned that is not being announced. I wanted to look at who actually owns that, and that is where the DoD comes in and some of the other space.
Okay.
But it's definitely worth looking at too.
Okay, thanks. One other point I would also like to stress at this stage is that although you're assigning addresses to countries based on what the allocations are listed in the various RIR databases, it doesn't necessarily follow those IP addresses are used in that location.
No, absolutely.
You have to think very carefully about that, say, for example, for multinational companies that are operating globally.
Yeah.
So just saying a huge chunk of address space goes to country X doesn't mean to place that all that space is being used there or even is actually active there. Thank you.
No, I appreciate that. That's a good point. That's true.
Oh, one other thing I meant to mention, sorry. Please try not to talk about ownership of IP addresses. That can be a very difficult conversation in other settings.
Okay, thank you.
Cynthia Refström. Really interesting talk, first of all. I'm also very annoyed at the inconsistencies in RDAP. And I would encourage you, if you want to help try to fix this, to join the database working group, at least for RIPE or RIPE-NC. Thank you.
Thank you.
Hello, Eric Balano from Interland. You mentioned a list of two-letter ISO codes that does not have IPv6, and you mentioned Kosovo between them, but Kosovo does not have an ISO code. So how's that?
So those IPv6 allocations were based on the RIA stats only because I did not want to iterate through all of IPv6 and test it individually, right? So what the RIAs published, they did not include those country codes. And that's possible either for allocation reason that they're grouping those into other locations. They're saying, look, Kosovo does not get its own allocation because it's included in that region. And I don't want to even get into the geopolitics of that. But I think that is something that might come into play there.
Okay, thanks.
Thank you. Do we have anything from the remote participants? No? Okay. And I can assure you the pain of trying to parse RDAP will pass after just a couple of years.
Yeah, I know, working on it.
You're going to be okay. Everyone who is interested in assignment types and things like that, if I'm correctly informed, there will be a presentation in the address policy working group on that. And with that, thank you very much.
Thank you.
And before everyone is rushing off, I would like to remind you, we still have open Lightning Talk slots for Friday. So if you want to submit something, submissions are open. We are very happy to receive them. You can still nominate yourself for the program committee until 3:30. And please remember to rate the talks and enjoy your lunch.
No, I don't need to do anything at all. Hello, good afternoon, everyone. I hope you had a nice lunch and grabbed some coffee. So, Jan and me will be sharing this session. As usual, whenever you are actually going to ask the question, please mention your name and affiliation, and please follow the code of conduct rules. Still, we have 1.5 hour time to, if someone actually wants to nominate yourself for the PC committee. So please nominate yourself or someone else. And I will actually start with our first speaker, that is Beyond Numbers, Navigating the End User, part of AS Ecosystem, by Radu Angel from TU Delft. Radu, the mic is yours.
Hello everyone, I'm Radu and I will talk to you about numbers, mostly AS numbers, numbers of AS numbers, and other type of numbers. This is the right conference, so I probably don't need to explain what AS numbers are. I will go into it directly. We have a lot of them. We have 4 billion, only 116,000 are assigned by RIRs. We can see them in the global routing table from the APNIC stats. We can see 75,000 V4 only, but we don't see 40,000 of them. Where are they? We know around 7,000 are IPv6 only, but we don't know anything about the rest. The 20% from the RIPE region that are not routed at all, those only refer to the RIPE region. So they are not 20% of the 41,000 or from that. So it's just from what's assigned to the RIPE region. Then we have some valid reasons why an ASN could be uniquely assigned to somebody, but still not being visible in the global routing table. It could be internet exchange points, it could be root collectors, they wouldn't be visible. It could be private networks requiring unique numbering, or it could be abandoned. We don't know. So we're missing a lot of ASNs from the global routing table. Then we have the assignment numbers. Internet Assigned Numbers Authority publishes these statistics of average monthly assignments per RIR. These numbers are from May 11. They change a bit, but not dramatically. The RIPE region wins at this with almost double the number of assignments in ARIN. APNIC is also on the second place, so APNIC also has a lot of assignments. That's why I will focus only on RIPE and APNIC for now. We also have this nice document, RFC 1913, that's 28 years old, and it tries to describe the guidelines for receiving an assignment, an AS number. It is mentioned in documents for all the 5 RIRs, but with different degrees of importance. For example, in APNIC, requests are evaluated based on it. In the RIPE region, it's just a small reference, CRFC 1913. It's not clear if a request can be rejected based on that or not. Also, RIPE has some harder requirements I will discuss later. So now focusing on this wonderful RFC. It has 3 main points that allow you to get an AS number. First one and the most important is that you need to exchange routing information externally. That is BGP because you want to be on the internet. So this is very easy to check. Having multiple prefixes is also mentioned, but it's not very important. So it's not, if you don't have multiple prefixes, go away. It's not like that. Another important thing is to have a unique routing policy. This is the most important in my opinion. Here, this is very debatable what a unique routing policy is. For example, in the RIPE region, a multi-homing is a requirement. Not very much enforced, but it is a requirement. This multi-homing is a unique routing policy because you can't say no to a network that is multi-homed. But there are other unique routing requirements that might pass this check. So I don't have a strong opinion if multi-homing should or should not be required, but I think the unique routing policy is very important. Now let's assume you checked all the boxes, so you actually need an AS number. Where do you get it from? You usually get it from the regional internet registry where your network operates in. But your network could be very large and you can choose, or you can find an RIR that is open to out of region assignments, that is easy to deal with and maybe cheap. So there are a lot of out of region assignments. This brings us to RIPE NCC, which is amazingly our region. This issue was discussed last year. A maintenance fee was proposed, but people didn't like it for some reason. So it was rejected at the general meeting. It is now proposed again in a different form. We don't know what will happen. So what's the problem with these things? There are a lot of requests coming, an increasing number from end users. End users have no contract, no relationship to RIPE. They have to pass through an LIR. These end users can be natural persons or they can be companies. But from a presentation from last year, we know that over 50% of these requests come from natural persons. So this kind of makes people unhappy because there are a lot of requests. Also, the number of unsuccessful requests is growing. These unsuccessful requests are requests where people don't provide adequate documents. They silently drop when they are requested for more documents from the NCC. And the NCC can't close the request until some time passes, so they have to wait if the end user will actually provide documents or not. This consumes a lot of time because you have to receive the documents, you have to check them. Some of these checks have actual costs. And guess what? These costs are supported by the RIPE members, which are the LIRs that have the contractual relationship, not by the end users. Now again to the global routing table. Sorry, because it's only the v4 one. Now we have different numbers. We have RIPE again on the top with a lot of ASNs. And in the brackets, it's the number of ASNs that announce only one prefix. Somehow this is double the number in ARIN. So I don't know what ARIN is doing, that networks over there have multiple prefixes, but they are doing something. Now, what are ASNs? This is wrong. They are no longer 16-bit numbers in the RIPE region. Since last year, I think they are only 32-bit, so they make no difference between them. But they are definitely not personal identification numbers. Now, the thing. What are the personal ASNs? This is a more recent term. It refers to networks assigned to natural persons, hobby networks. And there are very different opinions on them. Some people are upset because they are not doing any actual research. Research is conducted in academic settings, have a goal. Having BGP at home is not really research. Also, some people consider this as a way to get more young people interested in networking. These are the main different views. Maybe there is something in between too, but last year there was also a presentation that said there were some ASN requests from a 1-year-old person and also an 80-year-old person. So we're very inclusive. We accept requests from everybody. We can't just drop them. We have to check. Now, the world population is 8 billion people, but there are only 4 billion ASNs. Again, I'm excluding the reserved ones. We have all 4 billion. We can assign them at any time. But this means only half of the potential network engineers can get one. So maybe this could be again a scarce resource. Now, in general, the answer to this question is no, you don't need an ASN. If you like computer networks, you don't need an ASN. Doctors have licenses that follow them if they change their jobs. So you can't have a medical practice with a janitor, you need a doctor with a license. But you can have an ISP with your own ASN and it won't change if your network engineer leaves. So network engineers, not all of them need AS numbers. If you want to learn BGP, you also don't need an AS number. You can take courses, you can read books, you can play with private AS numbers. There are some private networks that try to replicate the internet over tunnels. If it is a requirement to have a full routing table, I'm sure it can be found from somebody. Somebody can send them this full routing table. If you're actually doing research, you can submit a request with what you're actually trying to research, and you will probably get an academic temporary assignment for research. But that has an end, so you have to actually research some. But registered, you suddenly get access to a lot of databases that are otherwise unavailable to you. This you can't replicate with private ASNs, but I don't think it's a huge problem. But I think it's important to keep these databases clean and useful for the community, because the community is not only the hobby networks, not only the research networks. There are also some actual networks trying to do internet things. I will now have some examples how this can break things. There is this wonderful site PeeringDB where ASN contacts register and they self-declare their network type. They provide information about data centers they are present in, internet exchanges, a lot of things. But most of it is user-generated content. And in general, there are issues with user-generated content. These hobby networks, personal ASNs, how do you want to call them? Mostly pick the education research category in this. There was a feature request to add the network type personal, but for some reason this was rejected. So now you kind of don't know. If you do research, you don't know if this educational research network is a university, is it a national research network, is it somebody's living room network. Also, you have the recommended prefix number, which is used in some cases by tools to automate network deployment, where you set the prefix limits on the session based on that. Now let's assume that I'm a serious person and I run an internet exchange. I'm also certified for privacy like other internet exchanges. Now I also accept these educational networks because I'm open to letting people learn. But suddenly I get a lot of prefixes from, I get a high prefix limit from one of the networks. Okay, this is just one measure that I take to protect my network from a leak. But let's assume that my RPKI fails, my other filters fail. So I'm left with the prefix limit from peering DB, which is very high. There are actually education networks that have more prefixes in peering DB than Hurricane Electric. And I have a second example. We have this wonderful RFC about geofeeds. This is pretty recent. In section 3.3, they explain how to verify the accuracy of these information. Somebody needs to check it if there are errors. Manually check it. RIPEDB supports it. You can add it as remarks. You can add it as geofeed. Again, I'm also a serious person. I'm always a serious person. And I work for a bank. And I start to see penguins accessing my services. But I don't have penguin customers. I have no customers in that region. So it must be a problem. I will contact my security people that take care of updating these feeds, and they will notice these feeds are wrong because somebody put something very creative over there. So this RFC is almost 4 years old, but you can't really trust it because people are playing with it. Yeah. I call this internet graffiti because they are putting things that are really not operational over there. For example, you can see ACAR test signatures. This is not really operational info, but yeah. The alternative to this is becoming more restrictive in what you accept in the DB, but I'm not sure this is what we want. So I don't think we want to become like LACNIC or ARIN to only have certain fields. Now there is another trend with these ASNs. People have rights because GDPR, because they are natural persons, so maybe RIPE shouldn't see their birthday or other information. I have another idea. There are phone numbers. Now you can have, you can operate your own mobile network with software-defined radio. I think it would be wonderful to have public phone numbers assigned to it, and I'm curious how it would work going to the national agency that's in charge of these numbers and give them a censored ID and tell them, please give me a range of phone numbers. I'm curious how that would work out. Now, there is this website run by Ben over there. He manually maintains this list of personal ASNs that get some bonus things if they are registered there. Well, what happens is that most of these ASNs are in the RIPE region for some reason. And their numbers are increasing pretty fast. Now they represent almost 2% of the global routing table. I don't know if 2% is a lot or not. It depends. So this is public information. These are the top 5 sponsoring organizations for these. I will go a bit faster because my time is almost over. Yeah. So there is a business model for this. These small companies can take money for ASN requests, but RIPE doesn't take any money for the ASN request. RIPE just handles the paperwork. They don't have to worry about database accuracy. But guess what? If you have an AS number, you also need additional things. You need IP addresses. IPv4 is expensive. What do? You deaggregate some IPv6 from the LAR helping you out. You have also a wonderful service that exports your routes to RIS for a very small amount of money. I don't really understand how this helps except by polluting RIS data and faking AS paths. I don't know why this is a must-have for networks, but these services need to be cheap and affordable so people don't complain a lot. How does this affect us? Us can mean a lot of things. It affects LIRs by increasing the membership fees. It affects the RIPE with database accuracy, and they can create operational issues for everybody. And for me personally, it affects the data quality for actual research because I find a lot of weird shit over there. Sorry for the... Yeah. So how can we fix this? We can enforce the existing policies. We can ask the ASN contacts to clean up some of their non-operational information they attach to their AS numbers, and maybe find some other ways for for young network engineers to be interested in networking. Okay, attaching, yeah. So thank you. I'm over time.
Thank you very much. You first.
Okay. Hi, Ben, BGP Tools. This is going to be a comment. I'm really sorry. I'm not sure I've ever disagreed with a talk so much as I've seen in person, but I don't really enjoy that you seem to have a view that universities are the only ones that conduct research. If you look around this room, that is very clearly not the case. And also that personal networks also do operate serious businesses. There are things called sole traders. So not all of these things are what you think they are. And I don't really understand the call to action for this talk. What is it that you want to change?
Well, I would like to have some more thorough checks on the unique routing policy because these networks are just building overlay networks. If you like to have an overlay network, use Tor or something.
But what? Never mind.
I don't understand how it helps having a lot of tunnels the same.
The thing I'll mention here, this will be my last point, is what is the purpose of the internet? Because I'm not sure the internet has a defined purpose. The purpose of the internet is what it does.
Yes, but currently it's mostly business and 2% research, and the 2% is increasing. So it will maybe become 20%, 50%. I don't know. When will it stop?
Okay, we will go to Leo and then to Tobias. Then we have online question.
Hi, I'm Leo Vigoda, and I'm wearing my PeeringDB product manager hat to answer your question about why PeeringDB rejected the request for a personal network type label. And that was because PeeringDB discussed the whole network types label last year. This is the product committee. And they decided that that's not actually a useful thing in making a decision about whether you're going to peer with someone. you know whether you're going to peer with someone based on how much traffic you exchange with their network, and whether they're a content network or a personal network or whatever isn't really a deciding factor. And cluttering up PeeringDB with lots of additional information isn't useful. Of course, if you disagree with that, the PeeringDB product committee can rediscuss it. You can create an issue in GitHub and explain why they were wrong, and they can discuss it again. But I just wanted to answer your question and explain the situation.
Yeah, I actually agree with that because I don't think personal ASNs exist. They are just numbers that represent networks.
Thank you.
So I agree with that.
Okay, Tobias, we are cutting the queue.
So Tobias Fiebig, Max Planck Institute for Informatics, but speaking for myself as an LIR. First disclaimer, I am currently holding 3 ASNs personally registered to me, but I understand I'm not in that data. Anyway, first to the point about the phone numbers. That is a splendid idea, and I can only encourage that, and I recommend you talk to Harald Welter, who is pretty much in that. And concerning to the tunnel networks, I think who is without a tunneled backbone, meaning MPLS or anything else that packs packets into packets and into packets, may throw it the first stone.
Online?
None of those issues are limited to personal ASS. Many such ASS are mindful of providing correct metadata, and many non-personal ASS have invalid metadata, either accidentally or maliciously. This is an intrinsic issue with self-reporting. One can't expect the data to 100% accurate and up-to-date. Do you have any quantitative data that such ASS are a significant part of that problem? It seems ridiculous to blame them for a possible fee increase without that.
I didn't really understand the question.
Do you have any quantitative data that such personal ASS are a significant part of that problem?
Well, there are the numbers that the requests are increasing, so they are part of the problem. Yeah. These numbers are increasing, so.
Marco.
Yeah, Marco Schmidt, YBNCC. Yeah, thanks for the presentation. And I just want to clarify, it said registration services not happy. We are very happy people, but it's true that the workload is impacting. And actually, I plan to elaborate more on that one tomorrow in the Atlas Policy Working Group first session. So if after the social today you have energy to be there, I can give a bit more information to what you mentioned. So, thank you.
Okay, Will.
Okay, Will Saitis. So I've got 2 comments. First of all, I was totally with Ben and all the comments he made, so +1 on that. Thank you, Ben. And I think you have not been using the database, the GUIs things for so long, because you would know that it's a mess for a long time. I don't think that those personal ASNs will increase the mess that we've got there. And the last comment on that will be that I think that now that we don't have any IPv4 space available in any pool anywhere, we will not have so many requests anyway, because there is no interest to have like an ASN without IPv4.
But there is a market where they deaggregate PAV6 and yeah. Yeah.
Okay, since the queue is closed, thank you very much.
Our next presentation is L4S, enabling scalable deployments of real-time services by Werner from Nokia. Werner.
Hello, excited to be here. It's my first RIPE meeting. It's also the first time I'm being subtitled, which is actually a good thing because I tend to talk fast. So, I'll try to talk a little slower so that AI can keep up with me. So, all right, good start. I'm here to talk about L4S, which is a new technology enabling, I changed the title a bit, simplification and scalability in how to support low latency services. It's being standardized at IETF. Why is Bell Labs talking about L4S? Well, we did a lot of the pioneering research behind L4S and are actually driving the standardization at IETF and other fora. And we're in a bit of a mission to get the word out because L4S has a lot of potential, but there's very little awareness in the industry about L4S at this point. And we think it can have a significant impact on the future of the internet and how actually low latency can be supported in a scalable way across the internet. I'm looking for the ticker. There we go. Okay. So L4S, what does it stand for? 4 L's and an S is actually low latency, low loss, and scalable throughput. If you think about latency, latency is not a single number. Latency is actually distribution, a statistical distribution, which has a minimum value, which is determined by the propagation delay. That's being solved currently by bringing the compute closer to the end user. There is an interface delay determined by the macro and physical layer implementations of technologies like Ethernet, like PON, like 5G. And this is continuously being decreased by releasing new technology standards. And then lastly, there is the queuing delay, also sometimes called the tail latency. And this is actually what L4S is tackling. So it's about enabling a low latency, but also enabling a consistently low latency, so very low jitter. And this is actually the biggest source of latency variations within the network. But high level, the goal of L4S is to reduce what we call working latency. And working latency is a latency that you experience when the network is not idle. So when you are, for example, doing video conferencing while your neighbor is downloading the latest PlayStation game, or while your son is doing that in the same household, creating congestion on the network. An easy test you can do for yourself at home is to do a speed test in parallel with a ping. This is not perfect test. Ping is not prioritized in the same way, but the results will not change significantly. What you see then, if you look at the ping latency over time during the speed test, first you will get a nice low value, 20 milliseconds is a reasonable idle network latency. Once you start congesting the network, this is actually measured on a commercial 4G network, you see latencies of easily exceeding 1 second popping up. And so L4S is about reducing that latency to the idle network latency, no matter what the load is on the network. So latency, okay, that's nice, it's a single number, but let's translate it to kind of a figure of merit that you can relate to. This is nicely done by Apple recently. Apple is quite a front runner here as well in terms of adoption. They actually support L4S now on all iOS and macOS devices, can be enabled by a software switch. And you see here an illustration in terms of video rendering for FaceTime applications, so video conferencing. And you see on the left the video stall percentage with legacy technology with L4S technology. So you see that actually L4S can completely eliminate any video stalls in video conferencing applications. Another figure of merit is the received frames per second that now stick to the maximum value of 30 frames per second when activating L4S support. Some other companies active on this side in terms of the application and operating systems are Netflix, Google, NVIDIA with the GeForce Now Cloud Gaming, for example, just to name a few of the bigger names. So, as you mentioned, as you've seen, the names I've mentioned are application or OS vendors. And the reason is that L4S is a two-part solution. There's one part within the application, which is actually using a new rate adaptation algorithm, a new congestion control algorithm that actually allows a fine-grained rate control down from values as low as 100 kilobits per second up to plus infinity, even for very, very low round-trip times. The second part is within the network. There you have to implement an immediate marking-based rate control, meaning it doesn't leverage any packet drops, but it uses ECN marking to signal congestion. And that signaling can be done instantly. Not like with classic active queue management, there's no smoothing in the network. The smoothing actually happens in the application. So there's basically no need to build up a queue in the network before marking a packet. Then secondly, it includes also mechanisms for coexistence and compatibility with non-L4S traffic. So you don't starve any non-L4S traffic on the network. And you do that using the marking capability to control the data rate of L4S. An example of that is the dual queue active queue management mechanism based on PySquare, which is also described in the RFC 9332. Actually, the AQM is a coupled queue dual queue mechanism. So if you think about low latency, well, the first solution you do think of is, well, let's implement an active queue management mechanism. There's a few issues with that. So if you represent the network here by a water tap, the source controlling the data rate and the bottleneck by a funnel, you get to this picture. You can use different congestion controls like Cubic or BBR, and they react to signals, the packet loss or delay measurements, BBR exactly. If you don't have an active queue management, well, your reaction will only come when the buffer is overflowing. You have a loss signal, especially for Cubic. When you implement an active queue management, what do? You introduce a controlled loss when you set a lower delay target to drain your queue faster than it would and not allow it to overflow. However, even with an active queue management and with classic congestion control mechanism, you still need a significant queue for different reasons. One reason is you need it to cover for data rate variations, the sawtooth thing you can see here. The second reason is also even for delay-based congestion controls, you still need to have a queue to actually have valid measurements of the delay. They don't work, these measurements, if you have no queue in the network. And then thirdly, you also have a big benefit of having a bigger queue to improve rate RTT fairness. When you have a single bottleneck shared by different flows with different round trip times, you tend to get very rate unfair capacity distributions. The bigger the queue, actually the more fair your capacity sharing is going to become. And then last but not least, you also have a fundamental trade-off. If you lower the delay target even more, you enter a regime where you actually are imposing so much loss to the application flows that you have a big impact on the overall loss rate. So this is why actually classic AQMs struggle today with imposing or enabling a low latency. Of course, a known solution or a solution you might think of for the loss is to use classic ECN. As you probably know, that didn't really work out. The reason being the implementation of classic ECN is still a single queue mechanism where ECN traffic was mixed with classical loss-based traffic. So the reaction to a loss or a mark was made identical, and also the rate of marking and the rate of dropping packets were made identical, losing any latency benefits. A better evolution in terms of leveraging ECN was actually data center TCP. And data center TCP was a very powerful, is a very powerful mechanism, works within data centers, using a new congestion control, and combining that with what we call an immediate active queue management. So an active queue management with a very, very low marking threshold. And that actually enables a very, very fast and frequent rate of congestion signaling, allowing you to control the data rate of your flows very accurately, and actually enables a combination of very smooth, high throughput flows that do have a continuously low latency. However, the problem is if you take data center and you put it out in the internet, it doesn't work for several reasons. One is it will starve out any non-data center TCP traffic, not being compatible with loss-based congestion control. And also data center TCP worked in a data center and used a queue that was actually larger than the base round trip time. The base round trip times in data centers are very, very small. Base round trip times on the internet are actually much bigger. And in the internet, we'd like to use a threshold that is lower than that internet-based round trip time. So there were some reasons to adapt data center congestion control, this data center TCP congestion control as well. So that's what actually L4S brought to the fore. One is coexistence and compatibility mechanisms between non-L4S and L4S traffic, such as the dual PySquare coupled AQM. And the other was a lot of changes to the congestion control, which is called PROG, according to the IETF meeting where it was agreed to, and the location of it. That introduced changes such as source spacing of the traffic flow rather than ACK-based spacing, also puts limits on burst size that data center TCP doesn't have, simply because when they use a queue that is larger than the base round trip time, any impact of those is not visible in the marking. But once you deploy on the internet, you want to have that threshold lower than the base RTT, then you need to actually tackle those to make it work. And thirdly, this is not an exhaustive list. Thirdly, Prague also introduced RTT independence, meaning that your flow throughput when sharing a common bottleneck is actually made more equal, so more fair, and also increases the inertia of low latency flows using L4S. And increasing the inertia, I know it sounds bad in terms of throughput, but actually if you want to have low latency, it's actually beneficial to have a slightly larger inertia, especially in dynamic link conditions, such as wireless networks, or with a lot of varying number of flows. So the Prague congestion control, this is a picture of how it works. It actually couples the data rate to the marking probability in a one-to-one relationship. No dependence on the round trip time if it's lower than 25 milliseconds. And moves along this formula where you see, this is a log-log plot, by the way. If you have, for example, 1% of packets being marked on your flow, it means your flow will have a data rate of 100 megabits per second. 10% of marks, data rate 10 megabits per second. It's a one-to-one relationship. If you look at these lines here, what that actually means is, if you move along the diagonal line, well, you have a constant rate of feedback of 2 ECN marks every 25 milliseconds. So it's constant, it's up to date, it's no outdated information. At the very low rates, there was also changes being made to reduce the packet size at that point to keep that pace up of 2 packets every 25 milliseconds. So the end result is that you have a data rate that can be very, very finely grained control, down from 100 kilobits all the way up to plus infinity. For us, it's an IP-based mechanism, so it actually leverages the ECN bits within the IP header. This is an IPv4 header. I actually perhaps should better use an IPv6 header for this crowd. So it's within the TOS byte next to the diffserv code point, 2 ECN bits. 2 values of the 4 have been used now for L4S. The first one is the ECT1, the 01 code point. What that allows, if you set that as an application, you're telling the network, hey, I'm an L4S packet. If you have the capability to do so, please treat me as an L4S packet. Then you have the second code point, the congestion experience code point. It flips the more significant bit there. That allows the network to mark the packet, the L4S packet, as having experienced congestion, which will make the application throttle its data rate accordingly. Because it's an IP-based mechanism, it's also a technology agnostic mechanism, meaning it's not coupled to a 5G technology, 3GPP technology, not ITU specific, it's not IEEE specific. It actually can work over any technology. So we actually have a uniform mechanism for applications and their rate adaptivity across all communication technologies. What does it require to support L4S in a network node? You need a couple of elements. The first element is to be able to classify or distinguish L4S traffic from non-L4S traffic. You can do that by directly looking into the IP ECN bits or using a proxy layer 2 identifier to which the traffic has been remapped by another node in the network, for example, a VLAN. Whatever you use, you need to be able to distinguish L4S from non-L4S. Why? Because you then need to put the packets of L4S in a different queue. By putting them in a different queue, you have isolation, and you avoid that the latency buildup of the non-L4S applications actually has an impact on the latency buildup, the queuing delay of the L4S applications. Then thirdly, when going to the scheduler, you actually prioritize to allow the few L4S packets to skip ahead of the non-L4S packets. So altogether, this is just simple prioritization of L4S over non-L4S traffic that is being controlled in terms of impact on non-L4S by ECN marking. So on the L4S queue, you have ECN marking be applied that controls the rate and feeds that back through acknowledgements to the application. So It uses scalable congestion control. It also allows scalability in how to offer low latency services. I have to admit, this is actually a slide I copied from Deutsche Telekom. I made my own version of it. That's a nice illustration of the difference between how to manage low latency with L4S or with, for example, guaranteed bitrate services on radio networks. If you have a good channel, you use a fair proportion of the cell resources, and everything's okay. Now, if you move to the cell edge or you go indoors, your spectral efficiency goes down. And then, if you have a guaranteed bit rate, you actually are exploding your resource usage within the cell, limiting the amount of low latency users within that cell and also impacting the other users. L4S takes a different approach. It also sustains the low latency, but it manages the throughput, enabling much more statistical multiplexing gain in your network design. Similarly, when you have a single bottleneck shared by multiple flows, they will fairly share the bottleneck. If 2 flows, they will get each half. 4 flows, it will converge to double amount of marks and half of the throughput you had previously. So it's flow fair capacity sharing within a single bottleneck. Supporting L4S on a network then, well, the first thing you need to make sure of is that ECN bits are not being bleached, right? That's a big no-no, although if there is bleaching happening on the network, L4S will detect it and will default back to traditional congestion control. If you want to really benefit from low latency, that's something you need to remove from the network, ECN bleaching. And then the biggest gains is by supporting L4S in the bottleneck nodes. Where are the biggest bottleneck nodes? In-home network, Wi-Fi, or the access network, typically. That's where you get the biggest gains of L4S support. At the edge, like in the BNG or UPF, it's also interesting to introduce per user rate limits to have a nice introduction mechanism and limit the amount of L4S traffic in your network. In the other parts, L4S support is a bit optional, and I have a better plot to illustrate it. You have to see your transport network, how it's actually behaving. And you look at the distribution. If you have an insignificant amount of jitter, well, you don't need to worry. L4S will go through, will not receive any additional jitter. You don't need to do anything. If your jitter is significant, but transient, not very consistent, well, you can go about just prioritizing L4S. That will solve all of the jitter issues. Only when it's significant and consistent, such as the in-home network and the access network, typically, you have to prioritize and support ECN marking. Okay, what about if you have now a layer 2 network that is congested, in case that would be the case? You can still support L4S by doing a remapping between the L4S IP bits and the layer 2 headers. Example here for MPLS, you would, for example, map the ECT1 combination to a particular MPLS traffic class. That would suffice for prioritization. If you also need to support marking, because it's very congested, well, you have to have a second layer 2 proxy, which is a proxy of the congestion experience marker in the ECN. Okay, let me end with a couple of experimental results. So this is actually an example showing how L4S behaves on a Wi-Fi access point, which was the first networking device to actually support it. In orange, you see the latency on the top plot of non-L4S flow, which fills the buffer and then continues doing that. L4S keeps the latency consistently low. In terms of data rate, you see a small impact there. In this case, it's related to the interaction between the Wi-Fi MAC scheduler, which was a blocking scheduler, and the L4S marking. But there's a bit of a fundamental trade-off as well. If you think about having no queue in the network, that means if you have a dynamic capacity, when it increases, you cannot fill that up immediately because you have no packets being queued that you can immediately send out. So in very dynamic conditions, you do lose a bit of link utilization, unavoidably, the fundamental trade-off. But you can fill it up with best effort traffic without any issue. If you look at the CDF, so this is really the probability distribution, 99 percentile from 200 hundreds of milliseconds goes down, in this case, to 12.5, which is actually limited by the Wi-Fi MAC layer, not by the queuing delay. Another demonstration we've recently done is on end-to-end fixed network. So a BNG, an OLT, and ONT, that's a PON network, Wi-Fi access point, all connected and operating in L4S. I'm showing here a cumulative distribution function without L4S. You see the nice overflow of buffers. We're fully congesting a network in all of these measurements. When you activate L4S, well, the L4S latency goes down to 10.4 milliseconds. That's a P99.9 percentile value. Allow me to zoom in on the left there. This is actually still lower limited by the Wi-Fi MAC layer, which we're also trying to solve. You can now improve the Wi-Fi MAC and get a benefit as well there. If you take the LAN connection, you have an end-to-end latency, one way, of less than 1 millisecond in a fully congested situation. So let me end here with saying that, okay, with L4S, you now have the capability for an application to choose between using a classic way, maximizing throughput, buffering in the network, very nice in dynamic conditions, or doing it in an L4S way, where you actually prefer to have a lower latency than a higher throughput, if you need to choose between the two. And it allows for the two worlds to perfectly coexist. An application can even mix the different traffic types within the application according to its needs, and they will fairly share common bottlenecks in terms of throughput. And with that, I'd like to end this talk. Thank you.
Thank you very much. Thank you very much. Who will be first? Yes, please.
Kemal Shant, Cisco Thousand Ties. Thanks for your talk. As part of the talk, you mentioned that in order to enable L4S, you would need to have proxy effectively on your network, right? So the question becomes whether it's actually worthwhile of going and adding additional infrastructure just to enable something that's not implemented yet fully versus just enabling DBR that already exists and is doing pretty much what you just described. Thank you very much.
Yeah, so allow me to correct you. So there's no need for an A2 proxy. Only if you really have a congested transport network, then it would be beneficial. I'd consider it to be rare. It's not doing the same thing as BBR. BBR cannot solve any self-inflicting latency. It cannot behave in wireless connections. We have experiments on Wi-Fi and wireless radio connections because it's model-based. The model is actually a really bad fit for wireless connections. It cannot keep latency low. It even goes to 100 milliseconds and above if you are in congested situations. The only way to solve it is to revisit both the congestion control as well as the AQM, the marking behavior in the network, which is what L4S is doing.
Hello, Alexander Azimov, Yango. Thank you for, first of all, thank you for your report. I find it very interesting as a technology. I have a few questions. The first question is that you said that with a growing number of flows, there will be growing number of marking. Does it mean that the device that's measures this number of flows? So does it mean that we need a device that measures number of flows coming through it?
No, it goes autonomously. It's because you have more flows trying to get a piece of the cake that you converge to a higher amount of marks. And basically, if you get to the curve, the higher amount of marks simply means that you have a lower throughput of the flow. So they will share the throughput evenly. So you need to get to a higher amount of marks to have a lower throughput. It's basically kind of the equilibrium situation I'm showing, not the dynamics that lead to that.
I see. Okay. And another question is that, as far as I remember, in previous standardization of ECN, both marking 0, 1 and 1, 0 were just marking ECN capable traffic. And there might be in the wild network devices that will be flipping the bit because they are not supporting L4S. They are just legacy devices, and for some reason, ECN is enabled on the queue that processes the traffic. How it will affect this technology?
Yeah, so this was one of the reasons why it took so much time for the RFC to actually become an RFC, because that issue. But it was deemed that there's very, very, very little deployments of actual ECN that would actually be affected by this. So in the end, it was decided to reuse one of those two code ports for L4S. If there would be such issues, this is still an experimental draft at this point that would pop up in the near future.
Okay, thank you.
Ben. Hi, Ben, BGP Tools. As an end user, how do I deploy? How would I get involved with L4S? How do I use it? So, are there any? Apologies if you explained this. I didn't fully understand the talk, I guess. But if is there a TCP congestion control algorithm that takes into account today L4S bits, or is this more of a user thing? Is this something that you would implement for, say, a quick stack or something like that?
There are multiple options. So either it is fully within the application, on top of a UDP socket, for example, you can implement your own L4S implementation, or you do put it in the OS protocol stack, like Apple has done now for iOS and macOS. They have done L4S inside QUIC and inside TCP. For Linux, you have TCP proc, which also supports L4S. So it's basically, you can choose. There's multiple options there.
Cool, thank you.
Okay, if there are no more questions, yes, okay, please.
Hi, Matthias Scheer, AVM. So we are in a position where we are actually implementing such a thing, being a CP vendor. And my question would be, when do you see adoption of this technology by hardware network process vendors like Big B and the Big Q?
That's a very good question. It's an ecosystem play because you need both application support as well as network support. We see application support is getting there now. We have Apple, NVIDIA, all implementing L4S support. Second will be when the operators start implementing it. We are aware of some operators that actually have thoughts about commercializing L4S and even monetizing L4S service. It's hard to look into the future, but applications are there. Now it's turn of the network operators to actually introduce support in a gradual way.
All right. Maybe one more. So if you go back to your proof of concept, you did your own Wi-Fi access point, Nokia Wi-Fi access point. Which hardware? Can you share which hardware you used?
I can share that, yeah.
Can you share now?
It's the Nokia Wi-Fi beacons.
But there was no hardware offloading, I suppose, because the hardware offloading on those chips would probably cancel. We see now if
I cannot go into the implementation details.
All right, I figured. Thanks.
Welcome.
Okay, we need to wrap it up. Thank you very much.
Welcome.
So before we go into the lightning talks, let me check. Okay, there is. The numbers are visible. So for the lightning talks, there will be 10 minutes. We will count 10 minutes, and please stick to the numbers, whoever it is. Who is the first one?
The first presenter is Ethian. The first presenter is Ethian breaching detection with Piedrasanta trace route by Luca Sani from Catchpoint.
Oh, Luca. Please, the stage is yours.
Thank you. Thank you.
So you have 10 minutes. If you want to use them all, there are no questions. If you use less, then there are questions.
Okay, thank you. Hello, everyone. I'm Luca. I work for Catchpoint, mostly on BGP and network measurement stuff. So this talk is about is a follow-up of a tool that we presented at last RIPE, which is Pietrasanta Traceroute. Pietrasanta Traceroute is an open source tool we are maintaining at Catchpoint, which is based on Dimitri Butskoy Linux Traceroute, on top of which we added several enhancements, hopefully, mainly to gain speed, but also to introduce new features, like, for example, the possibility to run quick traceroute within a TCP session, and so forth. So, by the way, Pietrasanta is the name of the city where the Italian Catchpoint office is located. So in this talk, I'll focus on a feature which is called ECN bleaching detection. I think from previous talk is pretty clear what is ECN, so I will be very quick about that. When the ECN mechanism is in place, a packet that experiences congestion, instead of being dropped, is marked and still delivered to the destination. The destination then signals back to the source that a congestion happened, so that the source can adjust the rate accordingly. Typically, but not necessarily, the feedback is implemented at transport level. For example, in TCP, it was introduced a dedicated flag called ECN echo, by which the destination can communicate to the source that a packet was received with a congestion experience mark. As we know from the previous talk, ECN got renewed attention due to L4S technology. In particular, as we know, the version of ECN that is required is not the classic one, but a more accurate one. The accuracy is implemented again, can be implemented again at transport level, and it means that the destination will be able to communicate to the source, not just that a packet experiences a congestion, but more precisely the amount of packets that were received with any value of ECN at IP level, so 10, 01, or 11. In TCP, there is a draft which is called Accurate ECN, so not yet a standard, which a new flag on top of ECN echo is added to the TCP header, which is called Accurate ECN flag. And this flag, along with dedicated TCP options, can be used to report the ECN counters to the source for the feedback. In QUIC, these mechanisms should be supported by default because QUIC ACK frames contains ECN counts, which are dedicated to report the values of each ECN value to the source. So as we know, one of the main problems in using ECN is that the value of ECN of the packets between source and destination may be altered for different reasons, ranging from bugs to traffic engineering decisions. So if the value of ECN is getting altered, the mechanism cannot be used properly, and also, for example, L4S it cannot be used and deployed effectively. So with Pietrasanta traceroute, we introduced the possibility to check the value of ECN at IP level, hop by hop from the source to the destination. In particular, we introduced the possibility to check the value of ECN in the moment that the probe expired on the hop. So we can compare the value of ECN that we sent with the value of ECN that was experienced at the moment the probe expired. So we can check the bleaching or any kind of alteration, for example, even the congestion. We also introduced the possibility to detect if the destination transport layer supports the more accurate version of ECN over the classic one. This is important because not all TCP stacks support the new more accurate TCP feedback, and also because we observed experimentally that not all QUIC implementations actually reports the QUIC counters correctly. So in order to report the ECN hop by hop, as I anticipated, we look into the IP header of the probe that was encapsulated into the ICMP TTL exceeded. So on the left, you see the probe that was sent. This is a probe of a TCP traceroute. Into the IP header, you can see that we set ECN equal to 1. And the TTL of the probe is 2. So after 2 hops is expected to expire. The ICMP TTL exceeded is reported on the right. And if we look into the IP header of the probe when expired on the hop, we see that the ECN value is still 1. So this means that from the source up to the hop where the probe expired, the ECN value was not altered. These are two examples of traceroute running from a source to a destination. On the left, both are TCP traceroutes. So on the left, you have an example of traceroute where ECN bleaching is not happening. So you can see that each hop from the source to the destination contains the value of ECN that we decided to use in input. And moreover, you can see on the last hop a combination of TCP flags that allows us to conclude that the destination supports the more accurate feedback of ECN, so the accurate ECN standard draft. On the right, you see another TCP traceroute where ECN is getting to start bleached from hop 13. So as you can see, there is 1 up to hop 13. After that, they are all zeros. And the destination reports a simple CNAC. So this means that, for example, in this scenario, L4S could not be used effectively because there is bleaching from the source to the destination. So leveraging this feature that we introduced in Pietrasanta Traceroute, we decided to run a measurement campaign from our vantage points deployed all over the world to understand how frequent and how much bleaching is there on the internet. So besides the research curiosity, this can be useful to understand, for example, how much the network is prepared to accommodate L4S. As we know, ECN is an essential requirement for L4S, so is a necessary but not sufficient condition. This is not a rigorous research work. For example, the results that I'm going to present are for sure biased by the vantage points that we selected in our network. We tried to be as fair and distributed as possible in choosing the vantage points. For example, paying attention to not select vantage points with the same upstream, this kind of stuff, but still the measurement platform will be biased. I think that I want to say that I ask your forgiveness, but the results for the moment are only related to IPv4 trace routes. IPv6 campaign is running, so stay tuned for more results. So this is the overall view about the bleaching. Over the total of trace routes that we run, around 12% of them experience a bleaching at some point during the path. As you can see, the bleaching happens more or less all over the world. I think that I didn't say is that all the trace routes that we run are run from source and destination in the same continent. We decided to do that because usually if you use L4S for streaming or gaming, the content is likely to be provided locally. The percentage that you see is the percentage of trace routes starting from that continent that experience the bleaching, and the absolute number is the absolute number of them. Since we are at RIPE meeting, we focused a little bit more on Europe. So in this graph on the left, you can see the percentage of trace routes that bleached starting from each country. So if you take a country, the percentage means that that percentage of trace routes starting from that country going to another country in Europe experience bleaching. An interesting thing is that among all the bleaching that we observed in Europe, the vast majority of them were due to a single autonomous system that introduced a lot of alteration in ECN value. On the right, you can see the distribution of the number of bleaching. Sorry, okay, finish. Out of time. Just want to say that if you find this interesting, the tool is open source, so it could be deployed on other platforms and maybe RIPE Atlas, I don't know. So feel free to check out the code and reach to me in order to set up maybe another campaign or collaboration. Thank you.
Thank you. Luca, the numbers were here.
Yeah, sorry.
Well, there are no questions. Sorry. No. Use 10 minutes. You can talk to him directly. We need to keep to the schedule because we have Andre now.
The end of
have a look at the numbers here. You have 10 minutes.
It's running already.
No, we'll fix it. Don't worry.
It's so strict here. Hello, everyone. My name is Andre Philip. I come from a country which is a southern neighbor of this beautiful country, from Czech Republic. And I think I have I would say, an interesting input to the problematic of IPv4, IPv6 transition from my very sage government. My government, or the government of the Czech Republic, dealt or started to deal with IPv6 long time ago. It was roughly 15 years ago. And that time they passed a first resolution, which explicitly mentioned IPv6, and it said that all the equipment has to be compatible with IPv6, and that all governmental websites has to be reachable via IPv6. Honestly, at that time the amount of website wasn't vast, so it was so filled. But anyway, because it was slowly forgotten, some 5 years later they passed a very similar resolution which expands this obligation not just to IPv6 support but also DNSSEC. So they said that all governmental domains has to be signed by DNSSEC, and also they said if you have some public tender for hardware or service, then it has to mention IPv6. So basically, with that we should be ready, right? There was the only problem that time they didn't include any monitoring, no enforcement, nothing like that. So in reality, quite often the IPv6 part was ignored, and many tenders just forgot to include this clause. So that was not really very satisfactory status. The current government has a really strong focus on digitalization, and they really work hard on renew all governmental services on the internet. So they passed another resolution that should probably improve the situation, especially in the area of DNS. And they said that they would like to unify all the services under .gov.cz domain. There were several reasons for that. There were some DDoS attacks that specifically targeted some of the DNS of some of the governmental services. So they took a lesson from that the infrastructure, which is multiplied many times, is not sufficient. And also there were some phishing attacks that the problem of citizens of the Czech Republic was that they couldn't really recognize what is the governmental sign and what is not. So they wanted to kind of clean this mess, and all the emails and all the website, they wanted to put them into .gov.cz. And also again, IPv6 and DNSSEC was reiterated. So again, interesting move. But the last resolutions happened roughly 4 months ago, and that's probably the strongest and the most interesting. First of all, it's called the restart of the implementation of DNSSEC and IPv6, because they figured out, and it was mainly based on the RIPE and CC Internet Country Report for Central Europe, that the implementation and the deployment of IPv6 is not optimal in Czech Republic, and they wanted to change it. So they reminded all the previous resolutions. They say they are valid, but they are not really fulfilled. So they said, we really want this to be fulfilled. But also they put a monitoring clause there. So the quality or the status of the deployment will be monitored once annually starting next year. So that's a novelty there. So that will be monitored and must be published, that report. So the people will see how this resolution is fulfilled. And the most important part of it, they also set a date when the governmental services will be ceased, will not be provided on IPv4. So that's something I would say revolutionary. My very sage government set a date. It's June 6, 2032. It was chosen because it's exactly 20 years after the first IPv6 days. So 20 years after the start of IPv6, they believe that 20 years is enough to adopt a new technology. And of course, we create a website and t-shirts and stuff like that. So you can check end of IPv4.cz. There is a countdown, and also, of course, you can download the resolution. But basically, that's the main news. We have a final date of IPv4 in my country, so I'm really looking forward to that, and we will see what's happened. That's all. Thank you very much.
You see? Thank you, Andre. Now we have time for questions.
And there are none.
No? Okay.
One brave one, yeah.
Hello, Michel, Lukix, Luxembourg. Question, did any commercial entities follow suit here? Because this is only government, so that's only part of it. obviously you would need all the infrastructure to support IPv6, like all ISPs and so on. And then also you could see enterprises following suit and also saying that we'll also stop that, or right now, because we're not discussing stopping today, it's far in the future. Now it's more the push that everything that is not yet IPv6 should get IPv6 now.
Well, there are two things, right? Like e-commerce services or the providers of websites or services like that, they are really not touched by this because they can continue operate as they do normally. This was mainly a message for ISPs because not all ISPs in the country do provide IPv6 support. And I must say a lot of things are changing these days, especially the mobile phone operators starting to offer IPv6 and so on. So we can see some change, but still it's well plan ahead. So I don't expect any rush. But yeah, that's the main message for the ISPs: do implement IPv6 as quickly as you can. Yeah.
Okay. Anyone else? I saw Maria running to the mic, but then went away. Is there anything?
No questions.
Oh, well, apparently everything is clear.
Thank you very much.
Thank you. Now we have the before end date. Thank you. Who's next?
Next is Libor Pelton from Sysnic, again for single provider multi-signer overview of scenarios.
Caution, this will be about DNS, so please don't hesitate to leave the room if you suddenly feel uncomfortable. I'm Libor Pelton from CZNIC, as well as our boss, Ondřej Filip, and I'm the developer of the open source implementation of authoritative name server called NodeDNS. Yeah, so nowadays, mostly the zones are signed by dedicated servers. They work the way that the unsigned version of the zone comes with an incremental zone transfer to the signer. The signer signs the zone, and the signed version is again sent via incremental zone transfers to public-facing secondaries. And you might want to use multiple those signers, not just one. And there are two possibilities. Either you run the multiple signers inside your infrastructure, or use separate providers for the DNSSEC. If you want to transition between those providers, you need to shortly become multi-provider, multi-signer, because it cannot be done atomically. But this is the scope of the music project, which is large, ambitious. I wish them all well, but they are still in development and have their own problems. So this talk will be about multi-signer within your company. When configuring multi-signer, mostly you will face various gotchas and things that can make you headache. So this talk will give you some hints and warnings what to do and what to not do when configuring multi-signer environment. Some of those are common for all the setups that are possible, and some of those warnings are specific to the specific type of setup. One of the consideration is that when you configure multiple signers, then the public-facing secondaries actually need to be configured to be able to obtain the incremental zone transfers from all the signers. Because if one of your signers goes offline or stops processing the updates, the secondaries will smoothly transition to the working one. But in case of incremental zone transfers, you need to really take care, because the versions of the signed zone will be different on each signer. The resource record signatures will differ in the version of the zone that's produced by one signer and another, and they can have the same source serial. So if the secondary downloads incremental zone transfers from one signer and then for other, and then mix them up, it will lead to a big mess. So there are multiple ways how to mitigate this and how to avoid this situation. Some of them can be configured on the side of the signers, some of them on the side of the secondaries, and the best approach is to combine them all. I would like to also present you some of the setups that are possible within multi-signer in your operation. It mostly depends on how you want to manage your keys. There are more possibilities. First of them is that the signing keys are shared among the signers. This means that all the signers have also the same private keys. And you can manage them on one of the signers and share to the others, or manage them elsewhere and then import all the keys to all the signers. But in any case, you need to have the tools that are able to export, transport, and import the private keys into all the signers. And you need to repeat this process every time there is a key rollover. And you need to also consider that this export and import takes some time. So this delay has to be accounted for in your key timings. Another possibility is that all the signers share the key signing key, and each signer has its own zone signing key. This mode of operation really resembles the offline KSK mode, where you have only like one party that signs the zone with the zone signing key and a distinct party that only signs the DNS key set with key signing key. This works very similar, or at least or almost the same way. So the same tools can be utilized for this mode of operation. So if your software is able to operate with offline KSK, it's possible to configure this setup. And the third possibility is that the keys are different. Each signer uses their own keys. But in order to make the NSA working, you need to share the public keys between the signers, because the DNS key error set must be the same on each signer and must contain all the keys that are used. So in this mode of operation, the signers need to share the public keys between them, which can be synchronized various ways. But in any case, it has to be done first when you configure the whole setup, and then upon every key rollover that happens at any of the signers. Various ways can be used to transfer the public keys between the signers, but for DNS, the native way is to use dynamic DNS. And it can be configured the way that when a signer updates a key, it sends the dynamic DNS to all the other signers to inform them about the change, or it sends the dynamic DNS update to the common primary into the unsigned zone, so that in the result, the unsigned version of the zone actually also contains the DNS key error set. Either way has some downside and some gotchas that you need to take care about. So it seems that the multi-signer is painful to operate, but I hope it's not, and it's possible to operate smoothly. But you need to align your tools, not to do things manually, because you can break things manually. You should automate your processes, keep monitoring them, that everything is okay. Your tools have to be able to react on events. It means events during key rollovers. And the rollover timings need to reflect the delay imposed by the synchronization of either the private keys or just the public keys. We have written some guidelines into Node.dns documentation, which should help you configure this setup in Node.dns, but I hope those guidelines are also applicable to whatever software or whatever ways you use to do this. So we have 2.5 minutes for questions.
Thank you very much. We have 2.5 minutes for questions.
Hello,
Yes.
Matthijs Mecking, IEC. Thanks for bringing this to attention to a larger audience. I think my main takeaway, I was working on multi-signer in the bind code, is we have to change the assumptions on DNSSEC signing, because basically we've been thinking about a single signer, and that means we own the key material. And with multi-signer, suddenly we have data key material that's from other providers. And at least in our code, previously we made a lot of assumption. Well, this is our stuff, so we can do smart things. And suddenly there's a key, someone else that broke all those assumptions. So it would be good. I should be reading those guidelines, I think, but it would be good to see if we can find the difference in those assumptions between single and multi-signer. It's not a question, but it's a comment. But thanks for the presentation.
Yeah, I will be happy to cooperate further.
Thank you. Any other questions, comments, anything online? Nope. Well, do you have anyone else?
Some announcements.
This is the end. Okay, announcement, please.
The nomination for the PC has actually been closed, and the voting starts from 1600 hours today. We also have Birds of Feather or BOF from 6 o'clock in this same room. And we also have a social networking event. The first bus for the event will actually leave at 8:30 from the entrance of Metropolo. Thank you, everyone. Enjoy the copy.
And please rate the talks. We at the program committee would love to see good or bad ratings and the explanation why something was well accepted or not. Thank you very much. There is a coffee outside.
afternoon. We're going to start in like 1 minute if you want to grab a seat.
Somewhere. There's another session, I thought.
That worked wonders. This is like a class of school children, and everybody's now sitting patiently waiting for the teacher to start. I'm going to do this in future. Good afternoon. Good afternoon, and welcome to the RIPE 88 MAT working group session. We have slides somewhere. Do I need to do a thing? Got the signal for 1 more minute. Okay, that's us. Okay, welcome, and welcome to Krakow. I'm Stephen. I work for Fastly. I am joined by my co-chair Massimo, who works for NTT, one of the large tier 1 providers, and our other co-chair, who isn't here, is Nina, who works for Kentic, one of the leading network observability platforms. And we have a really interesting agenda for you today with 5 different talks. We're going to be touching on aspects of inter-domain routing, who RIPE Atlas usage platforms, and Starlink low Earth orbit constellations. If you enjoy following the chat or engaging in backchatter, please join the Meet Echo. We will also be monitoring the Q&A on Meet Echo for questions. We will relay those to the audience. Please also remember to rate the presentations as we go. We do actually find that feedback useful if you like or dislike some of the content that we're bringing in. So without further ado, we are going to get started. Our first presenter is Savas, and Savas is a PhD student at Lancaster University who is specializing in internet measurement, inter-domain routing modeling, and traffic misdirection attacks. Savas.
Thank you for the introduction. First of all, thank you for accepting me in this meeting. It's my first time here. Everything is so well organized and the vibe is so friendly. It seems like you're not network operators. So, my name is Savas Kastanakis and I'm a PhD student in the School of Computing and Communications in Lancaster University under the supervision of Professor Neeraj Suri and Dr. Vasilios Giotsas. This is a joint work with Ioanna Livadariou from Simulamed, in which we replicate a 20-year-old paper published in IMC on inferring inter-domain routing policies. Now, among the other things that we're going to do in this presentation, we'll aim to answer 4 specific questions. Why would a network operator want to model the inter-domain routing system in the first place? Whether the cornerstone model actually captures today's inter-domain routing policies? What is the phenomenon of selective announcements and why should we even care about them? And finally, what can be done to enhance our inference capabilities, either as researchers or as network operators. Before jumping into the main point of this presentation, I'm going to explain a few basic things on how the inter-domain routing system operates. So the internet is a network of networks, and these networks are called autonomous systems, and autonomous systems form business relationships between them because they want to exchange traffic between their networks. Even though these business relationships can be very complex, they're coarsely categorized to 2 types, in the provider-to-customer relationship and in the peer-to-peer relationship. In a provider-to-customer relationship, a customer AS pays a better connected provider to transit their traffic to the rest of the internet, while in a peer-to-peer relationship, 2 autonomous systems exchange traffic for free. Apart from the connectivity aspect that business relationships give us to understand the inter-domain routing system, we also need to explain those traffic flow rules, the routing policies. autonomous systems configure their routing policies primarily because they want to achieve their business goals. So, for example, in this toy topology over here, Meta might want to propagate an announcement for a prefix to their provider Cogent, but not to do the same thing to their provider Lumen, because for some reason they want to load balance their traffic or their costs. Finally, autonomous systems are called autonomous because they independently define their routing policies without the need to globally coordinate with the remaining 75,000 or so autonomous systems on the internet. And one last thing is that these routing policies are sensitive information, so usually autonomous systems keep them secret. This slide over here, if I had to summarize it in a sentence, I would like to say that connectivity on the interdomain routing system, or in other words, business relationships, does not imply reachability because, as you can see, Meta is connected with Lumen, but for some reason they do not propagate all of their prefix announcements. Now, let's assume that I'm a network operator and I want to model the interdomain routing system. Why would I need to do that in the first place? There are many reasons. One would be to see the side effects of a traffic engineering strategy that I might follow, or I'm doing some routing policy changes and I want to see how that affects my network. I want to see what would happen in terms of resilience if a large DDoS attack happened in my network, or I would like to find the best geographic location to install the next data center or the next point of presence. So there are many reasons why a network operator would like to model the interdomain routing system. And modeling the interdomain routing system is a subject that has been studied thoroughly the last 25 years. It has been formed as a physics problem, as a statistics problem, as a graph theory, a machine learning, a systems optimization issue. Nonetheless, the cornerstone model was proposed in 2001 by Gao and Rexford, in which Gao and Rexford described a set of rules that need to be followed and met so that the global routing system converges to a safe state. And that work was primarily based on business relationships among ASs. 2 years later, Wang and Gao actually observed the internet routing policies at the time, and they saw whether the ASs of that time obey the Gao-Rexford rules. Now, researchers and network operators over the last 20 years primarily focused on reproducing and replicating the Gao-Rexford model. And to the best of our knowledge, we are the first to fully reproduce this complementary piece of research work to the cornerstone model in an effort to try and understand and answer whether today's routing policies follow this model. This is a replication study, so we follow the exact same methodology which they followed in the IMC 2003 paper. I'm not going to stay a lot here. I'll dive into details later in the presentation. But what we try to do is a two-phase study. Infer the import routing policies of autonomous systems on the one hand, and infer the export routing policies of autonomous systems on the other hand. Now, for the import policies part, we need to define some terms. Now, in the previous example, Meta is a multi-home customer to Lumen and Cogent, and Meta announces a prefix they own to both of their providers. Lumen and Cogent, since they have Meta as a customer, they're going to receive a customer route for that customer Meta prefix. Cogent decides to propagate that announcement to their peer Lumen, so Lumen also receives a peer route for the same Meta prefix. So they now have two routes to the same prefix to decide. And finally, Akamai receives a route from the provider Lumen, so they receive a provider route. The most important thing that happens in the import policies phase is the assignment of a local preference value to those routes. And an autonomous system assigns a local preference value to indicate how favorable that route is. For example, Lumen needs to have a system to decide which route to follow to reach the destination. Gao and Rexford back in 2001 described an ordering between those local preference assignments, and they said that usually customer routes are going to be assigned the highest local preference values because customer traffic generates revenue for your network. Provider traffic incurs a cost, so provider routes are going to be assigned the lowest local preference values, and since peer routes are neutral, they're going to exist somewhere in the middle of this hierarchy. One of the aims, one of the goals of this work is to answer whether this assumption holds with fresh data, 2023 data, because as we said, this is a 2003 work which we replicate. To do so, we need to have the local preference assignments of an autonomous system on the one hand, and the type of business relationships with its neighbors on the other hand. So to get our hands on local preference assignments, we're going to use Looking Glass server data as well as IRR data. And for the business relationships, we're going to use the state-of-the-art AS relationships inferred by CADA. Now, let's directly jump to the results. We observed that the local preference allocation pattern is consistent with a Gao-Rexford model in 83% of the cases on average. While in the original Wang and Gao study conducted 20 years ago, the average conformance was above 99%. More specifically, even though customer and provider routes are consistent with that hierarchy, peer routes are highly consistent with the Gao-Rexford model. This is probably due to better performance of the peer routes, or most probably because the flattening of the internet hierarchy that happened during those 20 years made the emergence of the IXPs and CDNs, let's say, overtake the ISP's power back in 2003. Now, these results, these numbers you see over here, are extracted using Looking Glass servers, which are interfaces, either SSH or Telnet interfaces to routers. So you can see the actual control plane configuration. While when you use data and local preference values from the IRR database, which is primarily maintained for documentation purposes, you see a far more consistent view with the business relationships and the Gao-Rexford model. Again, if I had to only say a sentence for this slide, is that local preference allocations today are not as heavily dependent to business relationships as they used to be back in 2003. Hence, we need to reconsider that cornerstone Gao-Rexford model. Now, someone would argue that I'm using inferred AS relationships, so this is a possible bottleneck in my analysis and that I'm introducing some error. We also studied the error introduced by AS relationships by leveraging BGP communities, and we observed that the error is negligible. So the only thing left that we have in order to explain this inconsistency with the Gao-Rexford model is probably the incapability of the Gao-Rexford model to capture the actual routing policies. Now jumping to the second part of this presentation, the inference of the export policies, things become a little bit more interesting here. We're going to follow the guideline of the original work, and we're going to assume that the provider network will announce, no matter what, all of its prefixes to its neighbors, because that's what a customer pays the provider to do so. However, a customer or a peer autonomous system may selectively announce its prefixes to its providers or peers because they want to load balancer traffic or handle their costs in a better way. And since there is not a specific value like local preference which can help us observe the export policies of an autonomous system, we're going to follow this guideline of the original paper and observe the export routing policies of autonomous systems through the routing tables of their neighbors. Now, I'll give you a slight example of what a selective announcement can look like. In this example, Meta is multi-homed to both Lumen and Cogent. And Meta has two prefixes, P1 and P2. Now, Meta announces to both neighbors prefix P2. So both Lumen and Cogent can access this customer prefix through a customer route because it generates revenue for their company. However, Meta, for some reason, wants to only receive traffic for prefix P1 through the ingress link with Cogent. So they only propagate that announcement to Cogent, and then Cogent propagates it to their peer Lumen. If everything was working based on the Gower-Exford model, Lumen would follow a customer route to reach a customer prefix. And that is what happens in prefix P2. However, in prefix P1, Lumen is going to follow a more expensive route, which is the peer route, to access that meta prefix. So if we need to give a definition, a selective announced prefix is a customer prefix received through a peer or provider route. Also, a selective announced prefix can be a peer prefix received through a provider route, but we'll only focus on customer prefixes in this presentation. Now, to study the prevalence and the persistence of selective announcements, we need to have the routing tables of the neighbors of an autonomous system, as well as the inferred AES relationships with its neighbors. Now, what this table shows over here, to the left column, you can find all the vantage points which we used so that we can measure the prevalence of selective announcements in 2023. You can see that the top 5 networks are high centrality networks, and we observe a large portion of selective announcements through the total number of prefixes that they observe. And this slide wants to inform us that the phenomenon of selective announcements is still prevalent even 20 years after the first time it was introduced. Due to time constraint, I won't stay a lot in this CDF, but what I want to say here is that if you are a selective announcer and you announce selectively at least one IP prefix, then probably you advertise selectively 100% of your prefixes. Because as you can see here, approximately 75% of the selective announcers announce exactly 100% of their prefixes selectively. Leaving prevalence and going to persistence, we study how persistent are those selective announcements. And you can tell whether a selective announcement is persistent if it does not switch from selective to non-selective in a specific time window. We use different time windows, the time window of a day or a month. And you can see on the left figure that selective announcements are consistent during a month. The same figure you would see it in the time window of a day. But on the right-hand side, you see that selective announcements become unstable during a year. And that is a good indication that if you care about compiling selective announcements, probably the best time window would be the time window of a month. We take one step further and we study the persistence of selective announcements over the last 20 years for 5 networks that exist in all of those 20 years. And even though you cannot see a clear pattern, you can observe a pronounced median jump in 2007, and that median stayed consistently above 25% for the remaining 20 years, with the highest value of selective announcements being observed by Lumen in 2001 with a ratio of approximately 81%. So selective announcements are sensitive to topological and probably policy changes, so we need to regularly compute them. Now, if I had to summarize in just one slide this presentation, I would like you to know that understanding, predicting, and modeling the interdomain routing system is a crucial function not only for researchers like me, but also for network operators like you. Also, reachability on the interdomain routing system is not only determined by the connectivity we have with other autonomous systems and the business relationships we have with those autonomous systems, but also by the routing policies that they and us configure. And even though we have the tools to observe those actual control plane configurations, and those tools are looking glass servers, for some reason we don't use them. We need to reconsider the Gower-Exford model and extend it with inferential techniques on complex routing policies if we want to overcome this limitation. And trust me, you'll find much more detail in the paper, which you can find in this slide. You can find the code of this paper in our GitHub repository. And feel free to ask me any questions either now or through my email. Finally, before thanking you, I would like you to know that I'm open to research and industrial positions, so feel free to reach out to me. And thank you for your time to watch my presentation.
Thank you. Thank you very much, Savas, for the presentation. And if there are questions, please go to the mic. I see that there is already a queue for me.
My name is not Stephen Strauss. I'm channeling Randy Bush on the MiraEcho Q&A. Do you have comments on the 2013 paper, A Survey of Interdomain Routing Policies by Gill, Shapira, and Goldberg, which measured that the Gower-Rexford model held only for about 65% of the relationships?
If we're speaking about the same paper, that was a survey conducted on network operators. Can you repeat the title, please? Because I'm not sure if we're...
The title of the paper is A Survey of Interdomain Routing Policies.
That's awesome. So that's a survey conducted to network operators. So if I was conducting a survey, yes, of course, it's a very important piece of work, but we do not go and actually ask people on their routing policies. We observe them through looking glass servers. So even though actually serving network operators is very important, we also have tools to automate this process rather than asking people in meetings and conferences. Yes, please.
Yeah. Antonio Prado, BGP guy.
I understand.
Did you consider to use RFC 9234 about only to customers and BGP roles, etc.? I would like to firstly thank you for your analysis because this is a very hard field to move.
Yes, unfortunately, I do not recall that RFC, but if you give me some more detail, I might share either my insights because I have some backup slides, or I'll just tell you my personal opinion.
Yeah.
I don't remember that RFC though. No.
Thank you.
Thank you. Okay, we have another question. Yes, please go ahead.
Hello, Sava.
Hello, Pablo.
So during these years, do people change how they define their policies, or it has also changed our view of the internet? So back then we had that view of the internet, we built a model on that view, but maybe today we have more vantage points to see other parts of the internet that we didn't see.
Can you please share your affiliation, please?
Yeah, I'm from Aristotle University of Thessaloniki.
Great. Thank you for your question. So both parts are correct. There are so many confounding factors that can play a role in these changes. But if I only had to summarize in just one thing, what is the main reason, is the transition from a hierarchical model, which used to stand back in 2003, in which we had tier 1, tier 2, tier 3 ISPs, so on and so forth. The power was in the large ISPs back then, but based on the emergence of CDNs and IXPs, that hierarchy changed. And we call it a flattening of the internet topology. A lot of ASs decided to follow more aggressive peering policies, either because peering links are less expensive or they have better performance. But the main reason we see those changes, I believe, is the flattening internet hierarchy.
Okay, thank you.
Thank you for your question.
Okay, perfect. So, Savas, thank you very much for your presentation.
Thank you for having me.
Thank you. And I think it's time to go with the next presenter, which is Simon Fernandez. Oh, he's remote, right. So Simon is a postdoc researcher at the UGA in Grenoble. His research is focused on the role of DNS on privacy and security in the internet. And today he will talk about, the presentation title is Who is Right? An Analysis of WHOIS and LDAP Consistency. So the stage is yours.
Thanks a lot. Can you all hear me? If it's okay, if you can hear me all, then let's start. So, hello, I'm Simon Fernandez, and I'm a postdoc researcher in UGA. And I'll be presenting the work we did with Olivier Houro, Andrzej Duda, and Maciej Koczynski at the University of Grenoble, called Who is Right, an analysis of who is an RDAP consistency. The plan of this presentation will be pretty simple. We'll start talking about like registration information, why we need it, what it is, and how to get it. And then I'll describe the kind of analysis that we run on this data. So let's dive right into it and talk about registration information. So as a researcher or as technical experts in domain names, we sometimes need to get additional information about the domain. For example, when we are studying a domain or blacklisting a domain, we may want to know who sold the domain, who bought it, if they bought all the domains in bulk at the same time, what kind of email we can use to report abuses, etc., etc. So all of this information is called registration information, and we can get it through two main protocols, the WHOIS protocol and the RDAP protocol. Let's talk about those protocols, how they work, and what we can do with them. So the simple WHOIS protocol, so it's an old protocol, almost as old as the internet. It's insecure because it's unsigned, unencrypted data, but it's widely spread. Most top-level domains, most TLDs have a WHOIS server. And because it is old and for backward compatibility, it has a very human-readable format. So data can be put in any format inside of a WHOIS record. So the main, for example, this is the part of the WHOIS entry for the google.com domain. We can see the domain name, we can see the registrar, we can see the creation date, etc., etc. And all this information is like boils down to information about this google.com domain. However, WHOIS is not always as easy to parse, and human readable does not mean, for example, written in English, because human readable can mean, for example, for the epson.co.com.bo, this is the WHOIS entry for this domain, and as you can see, part of it is written in Spanish. So if you cannot read Spanish, then good luck trying to find the information that you need inside of this data. And as I told before, it's a human-readable way, meaning that there is no standard saying how the data should be formed. Another challenge we have when parsing WHOIS are dates, the bane of every computer scientist, because sometimes you see this kind of entry inside of WHOIS records, and then it's a total pain trying to figure out what date we are talking about. Because of all of those problems and many other problems, in 2015, a new protocol was designed called RDAP, the Registration Data Access Protocol. It uses HTTP for transport, TLS for security. The data is in the JSON format. It has relatively well-defined data types. However, it's not used by all TLDs. All generic TLDs that have an agreement with ICANN need to provide an RDAP server. However, the majority of CC-TLDs, so country code top-level domains, do not have an RDAP server. So it's like kind of random if a TLD has an RDAP server or not. This is an example of part of the RDAP entry of google.com. So this is like a curated part of this entry because it's a huge JSON entry. But as you can see, there is like kind of the same information as the WHOIS entries. We can see that there is a registration entry, an expiration entry, and the dates are on with a more clearly specified formats, so easier to parse for computers, but way harder to read for humans. Now, let's talk about how to get WHOIS and RDAP entries. Let's take the example of the example.com domain through RDAP. So when trying to get the example.com entry, we start by getting the TLD of the domain, so here .com. We match it inside of an IANA bootstrap file that tells us that that gives us the HTTP server that manages this TLD, and so that we should query to get the data. So we then query this, for example, registry.com entry with HTTP TLS, and we get a JSON entry with some data. Inside of this JSON entry, we may have a referral server inside of it, meaning that additional data about this domain can be found at a different server. We can then follow this referral and get to a new server that will provide us with a new LDAP entry. So some keys, some data may be common between the two entries, but some fields may be unique to one of the two entries. So that's for LDAP. Now let's move on to WHOIS. For WHOIS, we start the same way. We start by extracting the TLD of the domain, so here .com. We match it in the list provided by IANA, and we get the domain name of the server that manages the WHOIS server. We can then contact it through port 43 with the WHOIS protocol. However, many TLDs are not present in the IANA TLD list, and many WHOIS servers are not present in this list. Meaning that as time went on, the community built a custom list with additional WHOIS servers that could be queried, and they just put it on GitHub. And nowadays, most WHOIS tools actually use this list to get the servers to query to get the WHOIS data. So either way, we get the name of the domain, we query it to port 43 with the WHOIS protocol, and we get a free-form text in a human-readable format. If we can actually parse it, we can extract some data, and maybe if we find a referral entry, or however you spell referral in Spanish or English or anything else, you can actually follow the server and get to port to query the second server on port 43 with the WHOIS protocol and get a new set of data with potentially a new data. So I'm saying that I should slow a little bit to avoid clipping. So sorry for the fast pace. I'll try to slow down a little bit. Sorry for the unstable internet. So based on this setup, we see that we can have multiple different servers and multiple different records. But we have no guarantee that all of them actually provide the same data. We see that we have, in this case, we have two different JSON entries from LDAP, two different freeform text entries from WHOIS. But we have no way of knowing that, for example, if I gather the registration date from the LDAP entry of the registry, will we have the same data from the WHOIS entry from the registrar? So, this is the research question that we try to answer. Let's take a look at the data that we collected to answer this. So we started from a list of domains from several sources, and we extracted 55 million domains that had both WHOIS and an LDAP entry available. We collected their records. This amounted to 164 million records, and we parsed their content, sometimes with great difficulties for WHOIS entries, and we checked if the values are actually consistent. We parsed the following fields. We parsed name servers, creation and expiration dates, IANA ID, and emails. Because those fields are actually used by many other research works and presented most records. I see a lot of feedback about crappy mic. Should I try to change things up, or should I carry on? Is it still understandable for you? I can maybe reduce the sensibility of the mic up. Is it better this way? Maybe it will reduce clipping for you. Please tell me if it's still too high in clipping. Okay. Well, if it's better,
Simon, I think that is a lot better. Thank you.
Okay, cool. Well, I'll carry on with this one. Sorry for the clipping earlier. I hope it was still understandable. So
we studied these fields because it's used by other works and it's used by security experts to categorize domains, for example. So, in this presentation, I'll present specifically the name server case, but here are the generic results that we have. So, for each of those fields, we have an amount of missing weight, meaning for some domains, we were not able to find those fields. We were not able to parse name servers for all domains. Sometimes it's because the data is not present inside of the register of the entry. Sometimes it's because, well, we were not able to parse it because it was in a weird format that we were not able to detect. However, in the last column, we can see the domain inconsistency, which represents the amount of domains that have at least 2 records that do not agree on this value. In this presentation, I'll focus on the name server case. So, why name servers? Name servers represent the authoritative name servers for this domain. Because it's a list of name servers, there are different kinds of mismatches. Sets of name servers can be included into one another, they can be intersecting or completely disjoint. And this is the repartition that we observed. Note that it does not sum up to 100% because as we can have multiple entries per domain, we can have multiple types of mismatches per domains. We observe that in 60% of the cases, we are in the worst case called disjoint case, where 2 lists of name servers have no name servers in common, meaning there is no single name server in common between the 2 entries. This is the most problematic setup because in the inclusion or intersection setup, because we may have 1 name server in common, it means that the data present inside of those name servers may be the same. We could trust that the data is the same between the different name servers. But in the disjoint case, we have no guarantee that the data between the different name servers are actually the same. So we focused on this specific setup that is the worst case from our point of view. Remember the kind of setup we have. We can have, when we have 2 entries mismatching, we can have a mismatch between 2 entries from the same protocol. For example, the registry level LDAP entry not agreeing with the registrar level LDAP entry, or we can have mismatches between 2 entries of the same of different protocols. For example, a WHOIS entry not agreeing with an LDAP entry. We observed that in 75% of the cases, the mismatch was between a WHOIS entry and an LDAP entry. And the remaining 25% are mismatches between 2 entries of the same protocol because of the referral system that allows different servers in the same protocol. We checked who has the right value because in the case of name servers, we are lucky. We have a ground truth. For example, for a creation date, we have no way of knowing like which is the real date. But for name servers, we have the DNS that provides us with an NS entry. So that's what we did. We collected 300,000 NS records and checked when WHOIS and LDAP disagree, who has the right value. We observed that in 78.5% of cases, LDAP had the right value, at least the value that is present inside of the DNS. In 21% of the cases, WHOIS had the right list of name servers, and in 0.5% of cases, none of them had the actual right value written in the DNS. So this points out that on average, LDAP seems a little bit more trustworthy for the name servers, but still 21% of the cases are still towards WHOIS. So given a domain, we have no way of knowing who has the right value if we are not ready to check with the DNS. So let's conclude this presentation. We need registrar information for many topics as researchers, as security experts, to classify domains, to detect abuses, to report abuses, for example. And we can get this data from different sources. We can have different protocols, so WHOIS and LDAP, and inside of one single protocol, we have different servers with the referral system. And we collected 164 million records from 55 million domains, and we detected that around 5% of domains have an inconsistency somewhere. They have at least 2 entries that do not agree in at least one field. For name servers, we have a clear third-party ground truth source, that is the DNS. But for most other fields, for example, for the abuse mail contact, for the creation date, for the expiration date, we have no third party that could tell us which server, which protocol has the right value. As a consequence, this data should be used with care because given a domain, we have no way of knowing if the data we collected only through WHOIS is actually the right data. So yeah, that will be all for this presentation. All the data sets that we used for this article, the past WHOIS and LDAP entries and the collected DNS records are available online. All the code analyzing this data is also present online. And now, well, if you have any question, I'll be happy to answer them. Thanks.
Okay. Thank you, Simon. Thank you for the presentation. Questions at the microphone lines, if anybody has them, or in the Q&A on Meet Echo is currently empty. Sorry, we tried to interrupt you, but your audio was clipping at the start, so it was a little tricky.
Oh, sorry, I saw some reports in the chat, but I had no clear information on what to do, so so sorry it took me so long to check the mic. Really sorry.
It's all good. We got here. One question: you've identified a lot of mismatches. Did you approach operators to correct these mismatches?
So yeah, in some cases we approached them in specific cases. For example, when we detected an IANA ID mismatch, which was the easier to detect and to be 100% sure that there was a right value, a wrong value, we contacted some of them, and the ones we contacted actually never answered. But a few months after we contacted them, they fixed their setup. In their specific case, we observed that the IANA ID was completely invalid and like random and had no real signification, and also many other fields, like they had placeholders for names, for phone, for emails, and so everything changed after we contacted them, but we had no additional interaction with them to know if it was like a configuration problem, if it was a EPP status propagation problem. So yeah, it's hard to contact those and those actors and to get them to move stuff, and even more to get precise information on what happened.
Okay, we have one other question in the queue.
Okay, so Massimo Candela, Global IP Network AT&T, but the question is remote, and the question is from Moritz Müller. Do you look at the name server at the parent or at the child? This also mismatch occasionally.
Yeah, that was a question we had when scanning, because as you pointed out, there was a paper a few years ago about mismatches in the NS entries between the parent and the children, and sometimes the NS servers are not even present in the children, so we chose to select the name servers at the parent level, because it was the most reliable and it made the most sense in our analysis. We know that it's a bias because like sometimes they mismatch, but we considered that it was the most the easiest ones to collect and to analyze compared to having like a child level nodes that are really inconsistent and sometimes hard to get at.
All right, and on that, let's thank Simon once again. Thank you, Simon.
Thanks a lot.
Our next speaker is Pavlos Serembetis, who will be talking about analysis of usage patterns in RIPE Atlas measurements. Pavlos is a senior researcher at Data Lab at the Informatics Department of the Aristotle University of Thessaloniki. His main research interests are internet routing, measurements, and data science. He's involved in the AI for NetMon project, which he's going to talk about just now, which received the support of the RIPE Community Projects Fund.
Thank you. So hello, I'm Pavlos, and I'm going to talk to you today about a tool we did, the RIPE Atlas Measurements Patterns Analysis tool. And in fact, this tool is a part of a project we had, the AI for NetMon project, which is a RIPE NCC Community Fund project in 2022. Now it's closer to its end. And the main goal of this project was to identify and quantify biases in internet measurement platforms and in internet measurements. So we have produced a lot of material. You can find some RIPE Labs articles, some you can check our paper, you can go to our website. But just to give you briefly an idea what we mean bias, how bias is defined, it's when our measurements or our vantage points are not representative of the internet. So let's say, for example, that 30% of networks in the world are in Europe, 30% are in US, 20% in Asia, etc. If we have some in our measurements, some vantage points, and let's say 3 from Europe, 3 from US, 2 from Asia, etc., then we can say that in terms of location, we are representative, so we have no bias. If we have 10 vantage points from Europe, then we are biased. And here a clarification, being biased does not mean you are wrong, because you may have selected vantage points in Europe because you want to measure something from Europe. But bias gives a quantification of this pattern if something is not representative. So we have developed several tools about quantifying bias. And the last tool that is still in progress and we are developing, it's the RIPE Atlas Measurement Patterns Analysis tool, for which I'm gonna talk to you today. And for brevity, I'm just saying it, referring to it as a tool. So its goal is to analyze patterns in a set of RIPE Atlas measurements. And when we say patterns, they can be generic patterns or bias patterns that point to some non-representative activity or pattern. Of course, there is a UI from RIPE Atlas that you can see a lot of information about measurements. Our main difference between the RIPE Atlas UI is that our UI is not that beautiful, okay? But the other difference is that RIPE Atlas UI analyzes the results of a measurement, for example, the RTTs, etc., and it is for one measurement. In our tool, we don't analyze the results. We analyze only the set of probes, and we can analyze for many measurements together. So in a nutshell, what our tool does, it's a web app where you can go and put a number of RIPE Atlas measurement IDs, as those in the slide. So you put these IDs, and then our tool in our backend, it does some calls to the RIPE Atlas API, to the AI for Netmon API, collects some data, performs an analysis, and presents some results on the UI. And the results are in two sections, is general statistics and bias analysis statistics. So let's have a look. This is how it looks like. It's still a prototype in progress under development. And the results it can give for the measurements, it shows in all the measurements you have put there. So in this example, we have put like 7 or 8 measurement IDs. It shows which probes have been used in these measurements and how many times per probe. And the same thing for the ASNs that host these probes, which ASNs have been used, how many times they have been used. So you can see what ASNs have been mostly used in these measurements and do some analysis. Then in the next section, it's about the bias analysis of measurements that gives some more specific patterns on what's going there in the measurements. So in the plot on the right, you can see different bars. Each bar corresponds to a bias dimension. It can be location, network size, etc. The blue bars are the average value of the measurements. So it's the patterns of the measurements we analyzed. And the larger the bar, the more the bias, which means that it has a specific pattern there. I remind again, bias is not necessarily wrong. And for a comparison, we have also the orange bars that show what's a random selection of RIPE Atlas probes. So you can see which patterns are more intense or not. The other two plots are similar. They show the same thing, but in a different format. You can select between all these plots in the tool. And also here we have a plot wherein the dots correspond to different measurements of the ones you have put in the tool. X-axis is the number of probes they use. Y-axis is the average bias. The more probes in general, the less the bias. But using this visualization, you can find some outliers or some strange activity that you would like to get into more details about this measurement. And the final plot, it's a heat map that shows why there is bias. So it shows more details on the exact patterns of what happens. So on the x-axis, we have all the measurements we have put there. On the y-axis, we have the causes that have been identified as the top causes or the top patterns. And with red and pink color, we have the causes that are caused because the probes in our measurements are over-representing these characteristics. So for example, for location in Europe, it's around in the middle of this plot, it's all pink, which means that in these measurements we analyzed, there have been a lot of probes from Europe. So there is a pattern there. And the blue is when your probes are underrepresented of this characteristic. So the bottom row shows networks with customer count between 1 and 3, which is small networks. And we can see that these networks in these measurements were underrepresented. So these measurements were mostly from large networks. So summarizing, this is a tool that is part of the AI for Netmon project. This is a work in progress. It can help you analyze RIPE Atlas measurements. And we believe that this can be helpful both for network operators and some researchers. And why? It's mainly because of 3 reasons. At first, you can easily get a deeper view of your own measurements. So for example, if you put your own measurements, you get an automated reporting in our webpage. You can get some bias insights or some recommendations of what you may want to fix, if there is such a case. Also, if you analyze measurements of other guys, you can identify some patterns in the measurements of other guys. So for example, you can learn from others about what they do, what patterns they select for a specific purpose, what should you select next. And of course, mostly for researchers, you can do analysis of usage patterns in RIPE Atlas at scale, so you can play with the RIPE Atlas data. And the last point I would like to highlight is that we would like your feedback and ideas for extra functionality on this tool. And here is a very, very short questionnaire we have done with only 3 questions. All of them are optional, so whatever you want, you can reply. And we would like some feedback on the reporting. If this reporting that we give, is it actually useful for you? And what information would you like to see there? And what extra information, how to provide results? Also feedback on the user interface, if you understand the plots, the visualizations, if you would like something else. And last, for best practices analysis, because as I told you, we can use this tool to identify patterns and best practices if we give a specific set of measurements. We would like some feedback on what sets of measurements should we analyze. For example, if I want to learn how people measure CDNs, should I select all measurements from country X to target ASNs that are CDNs? Would that be a good use case? So any ideas are welcome. Please help us in our work. And with that, I would like to thank you.
Thank you very much, Pavlos. Okay, we already see one question. Go ahead, Robert.
Hello, I'm Robert from RIPE NCC, somewhat involved with RIPE Atlas. I like what I see. Thank you very much for this work. I consider this to be complementary to what we have kind of built into the system, but this is useful from a completely different perspective. So thank you for doing that. My question is about sustainability, which I didn't see on the slide. So is this a project? Is this an experiment? Is this something that you want to stand behind for a long time? What's your take on that?
So this work has started as a part of the RIPE NCC project fund that we got funded. And now we have built within this project, we had the opportunity to build different tools. So we have an API, we have a database that is automated, updated. And this tool is a web app. So it's up there and we are going to maintain it for a few years more. I mean, it does not extra effort. We still have some resources to put some extra effort to improve it. That's why we ask your feedback. Okay. But we are open to collaboration if someone else wants to help us on making it more sustainable, that would
Oh,
be
I
great.
would be happy if, if even we did help you, but thank you.
Thank you.
Just to clarify, so you are saying that essentially the tool that you created can be exported like open or used by another organ in case you don't want to maintain it anymore. That's
Yeah,
what
it's open source. Everything is open
Okay.
source.
Thank you very much. Any other question? Oh, sorry.
Hi,
Yes,
no
please
worries.
go ahead.
Hi, Lai from Measurement Lab. Thank you for the presentation. I would be really interested in having the same study or analysis done on the Measurement Lab data or other open data sets. That would be very interesting to me. I also had a question. Have you considered extending the project or tool to identify when these biases lead to false positives or false negatives?
What do you mean by false positives and negatives in terms of bias?
I guess in terms of whatever the researcher is looking to answer, are there, it would be interesting to know how often these biases, I guess, impact the decisions that are made based on research.
Okay, so here again, the clarification that bias is in fact a characteristic of your measurements. You may be biased, you may do a very biased measurement only from Europe, but you may do it for a specific purpose. Does not mean that you are wrong, so it's not something bad. But for some cases, you may be biased and you didn't know that you're biased and you would like to fix it. So in that cases, it can be helpful to help you fix it.
Thank you very much. Any other question? Okay, then. Thank you, Pablo. Then we go to the next presenter. The next presenter is Eric Lampfer. Eric is a PhD student in the Distributed System Group of Niels Aschenbroek in Osnabrück University with main focus on network security and internet measurements. And he will present wet links and Starlink on the road, exploring the stationary and mobile performance of Starlink. The stage is yours.
Yes, thanks a lot for that nice introduction. It's also my first RIDE meeting, and I really enjoy being here. It's a great community, and I'm really happy that I can present our work today. So in the recent months, we researched a lot and measured a lot on Starlink, and we came up with two data sets. So the WetLinks data set, which is containing stationary data, and our Starlink on the road data set, which contains mobile data. I will first start to introduce you to our WetLinks data set, which we measured together with our colleagues from University of Twente. So the key features of that data set are that we measured for 6 months in stationary measurements in Osnabrück and Enschede, 2 cities in Europe, Germany and Netherlands. We measured in autumn and winter. We measured some key network performance indicators, which I will introduce on the next slide. And one special thing we have here is that we measured accurate weather data directly on site where the Starlink dishes are placed. In total, we collected approximately 140K measurement points, 80,000 from Osnabrück and 60,000 from Twente, and we published that as open data. I will give you the links later to our datasets. So here on the left and right, you see our measurement setup. On the left is the Osnabrück dish, which is a Generation 2 dish. On the right is the dish from Twente, which is the Gen 1 dish. In the picture of Osnabrück, you can see in the upper right the weather station, which was directly placed to the dish. And here on the right, you see the diagram, how our measurement process works. So at first, we measure throughput, UDP based using IPER3. We decided to use UDP to avoid some issues of TCP that we would measure, like congestion control and stuff like that. Next, we measure RTT and packet loss using the ping tool. And after every 6th measurement, we also make an MTR measurement to get the current route. Yeah, and the weather data, as I said, was collected with a semi-professional weather station called Frogit DP2000. Was measured minutely depending on the metric. So this is the architecture we used in total. You can see on the right the measurement client, which was a server running iPerf, It has two network interfaces, one connected to the university network where our measurement server and the data collection server were running. We tried to split that up so that the measurements are not interfered by our control channels. Then we have a Starlink router, which we put in bypass mode, so that we have the IP address of the NAT directly assigned to our measurement server. Then going to the user terminal, we scrape the data from the terminal, so the terminal is delivering some abstraction data, and also time data, GPS location, and stuff like that. And the firmware version, we also collected that and curated it in the data set. Next, you have the bandwidth connection to the LEO satellite, to the ground station, and then the traffic is leaving the network. We assume that the ground station used is Erzen, which is somehow close to Hanover in Germany for both stations, and the POP is according to the trace routes in Frankfurt. Then we have the measurement server, which is providing the iPerf instances, and the data collection server that collects the APIs. Additionally to our own weather measurement, we collected the measurement data from the German weather service and the Dutch weather service from the closest stations to our vantage points. Giving you a little overview on the throughputs we measured. So in Osnabrück, we had the median throughput in download of 215 Mbits. In Enschede, 240. It seems like that the generation 1 dish is a little bit faster than the generation 2 dish. And in terms of upload, we had about 15 megabits in median in Osnabrück and 16.2 in Enschede. So looking at a little analysis of the data, so we took all samples and put that to the according to the hour of day to have a diurnal cycle, and we see similar to other backbone networks that we have some peaks when the people stop working and start streaming here at roughly 6-7 o'clock, and we have some better throughputs between 4 and 5 a.m. Next, we looked into the impact of rain since we had our accurate weather data, and we grouped the rain levels into buckets and analyzed the samples. And we saw that in some scenarios, the download throughput can almost halve when it's rainy outside. So, that hit our assumptions that rain has an impact on Ka and Ku band radio transmission. And when you have rain, you usually have clouds. Sadly, we don't have a super expensive cloud radar at our university, so we tried to analyze it somehow with the data we had. Therefore, we looked how long is the rain period on average. It was 4 samples, so roughly 12 minutes. And we looked into the 12 minutes before and after the rain period and grouped that. Additionally, we built a group with no rain, since we had UV and solar radiation data. We set the threshold of 300 watts when the sun was shining, that we had the no rain group. And we could see that we have a roughly 10 megabits drop before and after the rain, so indicating that clouds might have an impact here. So that's it on our wetlands data set. More details, of course, in the paper. Next was our Starlink on the road measurement. We teamed up with our local energy grid provider, the SWO Netz GmbH in Osnabrück. And they provided a van that was used by a technician who's doing some service in the network. He's doing some LoRaWAN work. And here we measured in winter from January to March in Osnabrück, Germany again. And we measured the same network performance metrics. Additionally, here we measured the power consumption, and this data is also available as open data, but without the GPS traces due to privacy reasons. Measurement process is the same. The only thing that changed is that we have power consumption recorded by a smart plug, and we were not able to put the weather station on the van. The data wouldn't be that good when the car is driving, so we just used data from the German weather service from their open API. This is our architecture on the car. So the car has 2 batteries. We connected a 2 kilowatt-hours power station to the second battery on the timed relay, so that when the car switches off, we could charge our battery a little bit more. We had the Zigbee plug that was used to switch the terminal on and off. And we had a Raspberry Pi on board that observed the ignition state, did the control of everything, and yeah, also collected the data and conducted the measurements. Since we had no cable attached to the car, we didn't have a second link, so everything was running on the via the Starlink link. Despite that, the setup is almost similar. And yeah, this is the data we collected. As you see, the technician is mostly operating in the inner city of Osnabrück. This is the sample count we have, and some more samples on the countryside. I put that in the map where you can see the throughput, and as you can see, we have some points where this throughput drops to roughly 100 Mbits and less. And yeah, we took a look into that, why we had this. And we found that at that point, we had some more obstructions than in other of these hexagons, like a forest or a bridge. The local mountain with 180 meters is around there. And yeah, down there is also a forest. And to compare that, here is the highway, so the Autobahn, where you usually don't have any obstruction, and there we were almost able to achieve 300 megabits. As you might see, it's quite higher than we had in the Wetlinks data set, because the flat high performance dish is really doing high performance actually. We looked into the impact of speed, therefore we did a similar grouping like with our rain values. We grouped samples to speed buckets. Since the operation was mostly in the inner city where you have a speed limit of 50 km, we don't have that much samples at higher speeds. However, we see that we have a significant difference between standing and moving vehicle. We assume that the decrease of the throughput rate is because of obstructions. So we don't see any more decrease with accelerating speed. So it's more likely that when you're driving through this city and you have more obstructions and stuff like that, but this is limiting your throughput rate. And as we see, I put the Wetlinks box plot next to it to have a comparison. The high performance dish is doing much more throughput in not moving scenarios. Concluding this, we built up 2 curated data sets containing stationary and mobile Starlink data. We observed some issues in the time of day where the throughput decreases at some times. We were able to show that rain has an impact on the download throughput. Upload throughput is not that affected. It's way more stable. We observed, or we got some hints that there might be some cloud interference. We will dig deeper into that in future work. And yeah, we saw that stationary performance is better than mobile performance. So in stationary, you have 10% more download throughput. The dish version has an impact. So even with Gen 2 and Gen 1, Gen 2 is showing better latency actually in the band pipe, and Gen 1 is showing better throughput rates. And yeah, lastly, we had some power consumption issues in our mobile setup, since the high performance dish is using on average 113 watts, peaking up to 190 when the heating is coming into the game, as we measured in the winter. And our car was only delivering 90 watts, so we have to improve that setup a little bit maybe. Yeah, that's it. Thanks very much for your attention. I would be happy to answer your questions. This is my website where you can find the preprint of the papers. We will present the papers on Friday at the TMA conference in Dresden. You got a first look now into that, and yeah, feel free to ask questions. Thank you.
Thank you, Eric.
yes, you heard that right, that Eric is scooping his own work by presenting it here before it's presented to TMA. Microphone lines are currently empty. I want to follow on from your final point on your conclusion slides. Can you do anything about the power consumption of these dishes?
Yeah, so we converted the power from DC to AC and back to DC then again. And we think that we have there some efficiency loss. So maybe we can directly attach the Starlink dish to the car consumption, let's say, as to the car network. We're right now working on that to save a little bit more energy. Moreover, we think about, since now winter is over, that we can put a solar panel on the roof of a car, that we so can do some energy harvesting while the car is standing and no measurements are running.
Cool, makes sense. Daniel, name and affiliation, please.
Yes, Daniel, fellow Starlink user. I have a 12-volt direct power supply for the Starlink dish, which also doesn't use the router. So that's much, much better. See me afterwards.
Yeah, sure. Thank you.
Okay.
Hi, Ben, BGP Tools. To follow on from the DC comment, there are some nice New Zealanders, Kiwis, who have designed DC-only boards to power the...
Yeah, I think I saw their blog post.
It's like the dishy stuff. It requires a special kind of PoE because it's a lot of power over PoE.
Yeah, thank you for that remark.
Okay, and the queues are empty, so let's all thank Eric again. Thank you very much.
Thank you.
Final presentation in the block is Robert Kishtalecki from the NCC to give us another RIPE NCC Tools update. Robert, you have a clear 15 minutes.
Wow, that's a first. Thank you. Okay, hello everyone. I'm Robert from the NCC. I work as a principal engineer, mostly with measurements and tools. So I'm going to give you the customary RIPE NCC Tools update this time. First of all, RIPE Atlas. The top section is what I said, like word to word the last time. So it's kind of a back reference, if you will. So I'd like to report on where we are with those things. First of all, reviewing the big data backend. As you probably have heard, we have a large cluster of Hadoop machines storing and serving back the data that we collect in RIPE Atlas. And that was one of the things where we needed to work on because it's aging. The current status is that we have moved all of the historical data up until 2 weeks ago or so out of this system, and now it's stored on Amazon in S3. And if you are asking for historical data before 2022, I think, right now you are served from that cluster already, and you probably don't even notice, so that's a good thing. As I said, all the data is extracted already, so it's just a configuration switch. Maybe next week we are going to serve everything that is historical from this cluster. What is happening right now is what we call the hot data. So basically the last 2 weeks, last 2 to 4 weeks, which is still in our age-based cluster. So we are going to move that onto a different cluster, which is now a cloud-based one on rented machines. And the point for this exercise is mostly to reduce the cost associated with serving the data back to you, but also some efficiencies along the way. We expect to finish this work by the end of summer. Next one, infrastructure. So this is everything else but the big data backend behind the probes, basically. Again, the top part is what I said the last time. The current status is that we switched over from an on-prem Elasticsearch cluster to a cloud-based OpenSearch one for what we call the measurement metadata. So if you're asking for what kind of measurements do you have in the system, what was running against this target at this point in time, and so on, those questions are answered from this one. And this is also for the cost reduction part. We have containerized some parts of the system, and we are starting up, I think as of today, we have the first controller in the cloud serving about 100 probes. So we're looking at how it behaves, whether that's different, better, worse than what we had before. And the ultimate aim here as well is we want to have a more flexible infrastructure, reducing the cost for this operation. And this is expected to finish around end of Q3. The user interface is going through a couple of changes, as you probably have observed. Last week, Monday, I think, we released another big batch that included a revamped measurement pages. Now you have a My Dashboard, which is customizable. You can drag things left and right in your order of preference. We have a completely new set of promotional pages, which has been reworked to give kind of an introduction to people who have not been with Atlas or not familiar with Atlas, so that it gives them a starting point. Tomorrow and on Thursday, between the first break and the lunch break, I think, and during the session, Stefan and probably me too, we are going to be there at the coffee stand. So if you'd like to have an introduction to the UI, or you have general questions and observations, please come and talk to us. I think Michaela is going to be there, so there's going to be some of us who will be able to answer these questions. All right, just highlighting the new measurement UI. My favorite, so left is the old one, right is the new one. My personal favorite, honestly, is the one in the front. We had for a long time a feature where you could add and remove probes from existing measurements. And sometimes people actually use this to kind of refresh or update the probes. So now we actually made it possible for you can just click on the user interface and say, all the dead probes, make them go away and give me fresh ones, for example. It's basically almost 2 clicks, maybe 3 clicks away for you to kind of revamp and refresh your measurements if you want to. But there are other features as well in the new UI. As I said, please come and talk to us, or you just explore on your own. We have already also been working on repackaging the firmware. Again, what I reported the last time, the current status is that we're almost there to release a Red Hat-based package, and the next one is going to be Debian and OpenWRT. The point of this exercise is that we want to make the development easier on one side. So for example, if there is a code change in the probe firmware, then that change is made in the repository, and then at the other end of the pipeline, we really want to pop out RPMs, Debians, OpenWRTs, and everything that the users can use. So that's why we're doing this. I put out some proposals earlier this year and also in last year, so I would want to reflect on those, like where we are with them. We ourselves highlighted it internally before, but we then had the public discussion about it, that there are some users who like to run a lot of software probes, and the suspicion is that they do this because they want to collect credits. This is not that useful for the system, and it's not that useful for the users either. Therefore, there was a discussion about what to do about it, and the end of that discussion is basically we are going to apply those restrictions that we proposed. So there is going to be some kind of curtailing of how many software probes you can run purely for running, purely for collecting credits, so to speak. If you want to run more than what the system allows you, you can always reach out to us and explain why you want to do that. And if there is a good explanation, then we'll, of course, tweak the system. Measurement aggregators, this was another topic. There are some users who serve their clients by channeling the request to Atlas. But in this case, we don't necessarily know how many clients there are. So the system is unaware of the real usage, so to speak. So the proposal was to actually recognize this. This is fine. This is happening. But then please, if you're an aggregator, then let us know an indication of who the client is. We don't want to have email addresses or anything like that, but we would like to know if client A is different than client B. That's all we want to know. And there are some other properties here. So we would like these people and users to step up as sponsors because they are, generally speaking, using more resources from the system. And of course, if the business requirements dictate so, then we might have to enforce other rules as well. Data retention, this was a very high-level proposal that we put out, basically along the lines of we are going to reduce costs. We will be very careful about these, but then in return, the service level for older data is probably going to be lower than the service level for newer data. As I said before, the technical solution is actually such that the difference is very, very little. So this might just end up being a cost-saving exercise and not a reduction in functionality. Maybe it's worth noting that Felipe put out an article about what this really means, some technical details as well. So please go and read that article. It's actually highly entertaining as well. And these are earlier proposals, which we realized that we put them out and we actually started working along the lines of what the discussions dictated, but we never properly came back to the community to say, okay, so here's what we're going to do. So I'm trying to backfill this, so to speak. There's a very detailed technical problem of how we collect so-called late packets in trace routes. Please go ahead and read the proposal if you want to know the details, but basically we're going to simplify what's happening there. We also proposed that the system will start measuring high-profile CDNs, so to speak, so the ones that serve most of the data that an average user is consuming. This had both pros and cons in the discussions, but there was no clear consensus that this is actually the value that we want to extract. So we're not going to implement it as we proposed it back in the day, but we're trying to do a small exercise to see if this is actually going to give the value that we thought it's going to do. And based on that, maybe do a follow-up. Generic HTTP measurements. This has been discussed before. We tried again, and the discussions were inconclusive, so to speak. So there are some people who would want this, some others who would hate this. So for the moment, we're not going to do it unless the community wishes otherwise. Add support for start TLS measurements. There was a clear message that yes, please go ahead, but please be careful about how far you go with this. So for example, on SMTP, it's nice that you get the certificate from the server, but please do not send email, which we will not. And then finally, remove support for non-public measurements. There was a discussion about whether this is useful as a feature in the system. That is, to some people, actually anyone, can have a public measurement that is marked as non-public. So the results are not available to others. So that's kind of a lower value, but then they get some other value out of that. So the discussion is basically, we're going to leave it as it is. The only change there is highly likely connected back to the data retention proposal, where we said, fine, but in this case, we are not going to retain that so-called private data for long because it doesn't provide value to anyone else. Therefore, it's only costing the community. So that's going to be kept for a shorter time. Okay, moving on. RIS. The RIS team is busy with mostly these things. So as you can imagine, sometimes the hardware behind RIS has to be refreshed. Sometimes the software needs to be refreshed. So the current exercise is about renewing the operating system behind the route collectors. We are also looking at how the various RIS peers are behaving. And as you can imagine, they are not behaving exactly the same way. Some of them are more noisy, some of them are less noisy, but they all affect the processes that are creating the dumps that you probably all consume. So we want to have a better understanding of which ones are contributing to the noise and contributing to the amount of work that we have to do in order to put out the data at the end of the day for you. We're also looking at how to improve the whole machinery, how to deal with, in particular, with the stuck routes. Some of you have seen that every now and then RIS says this route still exists, although in real life it doesn't. And that's probably because there is one of the stuck peers as we know it. There might be bugs lurking. So the message to you is that if you see such a thing and you can give us the signal to notice this, we can look into it and say, well, is this real, or is there something that we need to fix? So that at the end of the day, the quality of the outcoming data is better. And then finally, the team running RIS and the development of RIS is going to focus. Well, for now, it's the same team that's focusing on the RIPE Atlas backends, so it's the big data. And the next task is basically to look at the data sets behind RIPE-Stat and RIS to optimize that, similarly to what they do with Atlas, but not exactly the same because the systems are slightly different. And then finally, RIPE-Stat, mostly it's business as usual. There is one feature that is useful to highlight. The team has been adding new data calls to basically give you metadata about how old and how new the data is behind RIPE-Stat for various data calls. So it's been enabled for some of the data calls, and we are integrating this into the service so that when you ask for data, ask the UI to explain something to you, it's properly annotated about what's current and what's old and so on and so forth. And in the bigger scheme of things, we are looking at how to do the product strategy in the longer run, so whether changes are needed, and if so, what are we going to do about that? And that is planned basically for the summer after the RIPE meeting. And that's all I had to say. If there are questions, I'm very happy to answer them.
Thank you very much, Robert. Thank you very much. We have a question from the internet.
Randy Bush, IIJ. As both a researcher and an operator, I would be quite interested in the measurements and modeling you used to assess cost reductions in moving from self-hosted to AWS.
That's fair.
More of a comment than a question.
That's fair. I can totally imagine that at the next RIPE meeting, we'll come back to you and kind of explain the experience, so to speak, what worked and what didn't, and what path we took to actually make this real. I cannot promise that, but it could be a good topic if the Matt Working Group takes it on.
Hi, Paweł Foremski, Polish Academy of Sciences. I have a question also about cost savings. Could you add some numbers, either absolute or relative, how much it costs
of course,
to run the backend and what we are looking for?
Yeah, absolutely. I would recommend you read the article I highlighted also in the presentation, because Felipe actually went on in the details and also mentioned in particular numbers there. Uh-oh.
Hans-Peter Holing, Managing Director, RIPE NCC. If you want to know more about the cost savings in the infrastructure here, please come to the Services Working Group tomorrow, where Felipe will present on that. So he has a lot of interesting numbers and pictures on what we're doing on the backend side on the infrastructure.
Thank you.
Moritz Mueller, SIDN Labs. He has recently used the RIPE Atlas measurements in the Google BigQuery interface for the first time. He says they were unsurprisingly expensive, but also quite useful. Any idea how often this data is being used?
I'm sorry, which measurements were there?
The RIPE Atlas measurements inside Google's BigQuery.
Oh, yes. So we have some users on that. Admittedly, we were trying to be careful about really going out and say, oh, this is available, use it. So it's basically in a beta stage. We are trying to look at the value versus the cost it provides. So the value it provides versus the cost that we observe to make a determination of what the future for that can be.
Thank you very much, Robert. I think we have another question. Go, Daniel.
Not so much a question. I'm Daniel. I work for the RIPE NCC. I've been involved with Atlas somehow and the other measurement projects. I think it's good for this group actually to take note of the bigger discussion that's going on in the RIPE community and especially also in the RIPE NCC membership about these measurement activities that we're doing. There are more and more people who question whether the RIPE NCC should be doing this stuff at all. So if you want to keep your toys, if you want to keep those useful things running, then you should take note of this discussion and do your best to actually influence it in your sense. And it might be not you yourself, but maybe somebody else in your organization, whatever. So don't be blind. There is a discussion about this stuff going on outside this room. Number two, it would be extremely helpful if we found more people who are actually using things like Atlas to produce commercial products or commercially products to actually sponsor us. Because this other discussion I just mentioned becomes untenable if the argument can be that there's people making money off this stuff that actually the RIPE NCC membership funds. So I understand, of course, that academics are not. I'm not asking academics. I'm asking people who are commercial or doing commercial or commercial-ish stuff. And it's also about the academics, of course, who knew about this, about things like that, to actually talk to those people. It's been a good ride for the past 20 years, I think, but I think there's change coming. So don't be fooled, face reality. Thank you.
Okay, so we have Randy. Thank you. Has a question. Hey, Randy, go ahead.
Hi. Just to be clear on my previous question, Robert, I'm not interested in micromanaging RIPE or Atlas. If I did, I'd move to Amsterdam. My question really is, many of us face the issues of should we be hosting our own stuff or moving to the cloud? And my intuition is moving to the cloud, the base costs are the same, except I'm going to pay 1,000 Amazon salaries. So, you know, I suspect you actually did a reasonable analysis. So I'm really interested in the analysis and modeling and not questioning your decisions or discussing the right budget.
Thank you for that, Randy. We indeed looked at the numbers and, you know, what can we do with what we have on-prem, and given the current direction of, you know, trying to save costs wherever is possible, we looked at the alternatives, and the decision we made is basically we're going to go ahead this way because we believe that it will reduce the costs without doing much harm to the service that we do.
As I said, I assume that. But it's the model and how you modeled it and measured it, which is interesting to me. And it's intellectually interesting. As I said, I'm not interested in micromanaging your budget. I have my own to worry about.
Thank you very much. Thank you, Robert. I think there will be more questions, but we are already over time, so we are going to go straight to the closing remarks. Thank you very much. Okay. Yeah, this was the math working group. Hey, it works now. Perfect. Closing remarks. So the first thing I would like to say is that, as usual, we have a mailing list. I have sometimes tried to remind to researchers in particular that we have a mailing list, and apparently they are not too, let's say, fashionable nowadays. But we have a mailing list, the math working group you can find here. And there will be the publication for the next call for presentations. And also, if you have any feedback about us, about the content, you can send us this email to the Math Working Group Chair mailing list, which is instead the one that you see listed at the top. Then there is a quick announcement from the RIPE NCC that they asked me to do. So there is now in, I think, 20 minutes, the academic and NREN reception. Which is in the Nankin B room, which is essentially a room that is in that direction, but due to walls, you have to just go like this in the corridor. And so please join this this meeting. And we basically are at the end. I would like to thank you for being here. I would like to thank you, my co-chairs, Nina, which she could not attend, and Stephen, that is there and helped me a lot. And thank you, of course, for being here. And also thank you to the stenographer. Sorry if we made you really suffer today. And see you in Prague. Thank you very much for being here.
Hi. We're about to start, so if you go start to find a seat somewhere, find somewhere cozy and comfy, put your legs up, I don't know, whatever feels comfortable, and we'll get started in a couple minutes. Yes. Good. Let's start. Good. Right? Oh, yeah, very much. And the mic. Yeah, I'll do. I'll give that to you when I introduce.
Yeah, sure. I know. No, these days they might actually be coming from Germany and not from Switzerland. Yeah, probably. I saw no, that it wasn't really about Swissness. Well, if 10% are significant. Well, actually, I'm diabetic, so I'm fasting. No big deal. When I started a while, we had some of those, but only several. And I'm quite sure that it says.
All right. It is 6 o'clock. Please all find a seat. If you decide you don't want to be here, then this is roughly the right time to leave the room. Okay. Well, here we go. Thank you. First of all, thank you all for taking time out of your evening tonight to come here. We're going to be talking about a somewhat different topic. It's a topic that normally doesn't end up in a BOF, but which is building a stable future for the RIPE NCC and by extension, RIPE itself. And the fundamental question behind that is, we're now over 30 years old. Is the way we've structured ourselves in the organic way it's grown, are we still fit for purpose? And this is not meant as any attack on where we are right now, but I do think it is time, as I explained in my RIPE Labs article last month, that we need to have a closer look at what is the current landscape we're operating in, and are we set up in an optimal way to handle the challenges that we have here right now. Now, before we actually get started, some ground rules. Uncommonly for a BOF, I'm very strongly supported by the program committee here. So we have two members of the program committee that have volunteered to chair this session. That is Jan Zorch and Franziska Lichtblau. Franziska, would you like a quick introduction? Also, before you start, we have additional help. Brian is going to be watching the Q&A on the online session, and Fergal is going to be watching the chat. Franziska, who are you?
Hi, I'm Franziska. This is Jan. This is Brian. We come from the program committee to support here.
because this is going to be a rather large BOF. Please have a look for our cues. We will open the microphones. Everyone will be timed by us. We will give you cues when to start, who is next. And we would like to remind you that, as per usual, microphone etiquette applies. So please state your name and affiliation. We have a code of conduct that you can look up and know how to behave behind the microphone. And I think the rest of the rules are up here.
So to further frame this, I think there has been some confusion with some people. This is not the NCC general meeting, that's tomorrow. And this is also not about the charging scheme 2025. So I would very much appreciate it if you have comments about the charging scheme 2025. We will save them up for services working group tomorrow or the general meeting. This BOF is only an hour and we're going to be tight on time as it is. So time is limited, so please bear that in mind. Try to keep your contributions to a maximum of 2 minutes. And at the discretion of the chairs, if your contribution is off topic, you will be asked to stop. So where are we now? The story until now. Here we go. The RIPE Labs article, and I took an excerpt out of it, which is what we need to consider now is the bigger picture about how to move the RIPE NCC forward. The past several years have shown us that we have far outgrown the current structure for our organization and governance. New pressures in the RIR system and new stakeholders we are accountable to have changed the landscape we operate in. On top of this, the current funding model of the RIPE NCC is not sustainable. We now have to sit down and do the hard work of completely reinventing how we manage our membership and our funding while taking into account how we can mitigate current risks and future-proof the RIPE NCC. Also important for this discussion, the timeline for implementation for this. So we have a scope and we have a timeline for this. So really what we're talking about is any potential changes in structure will be from 2027 onwards. This will give us, as a community, about 1.5 years of time to carefully consider where we are, what we want to do, get a consensus on that, and then 1 year to actually implement that. So that's where we are. The agenda for today is four topics. If we don't get to all of the topics today, then we'll figure out a way to cover that through some other means. They follow one from another. And what I like to do is, if we hit 7 and we're not done yet, then I do want to have a quick talk about next steps. What do we feel we should do after this? Not on the agenda is specific work for the community, because the community doesn't need a BOF. The community has a community plenary and chairs, like one sitting right there. And examples of those topics would be like, how does the community create output, and what is the exact relationship between the community and RIPE NCC? Those are topics that would warrant a discussion in the RIPE community itself, which have not necessarily in this construct. So the RIPE Compact, what in Earth's name is a compact? So while writing these slides, I was trying to come up with what is sort of the name for the entirety of what we're doing here. Is the RIPE community. It is the RIPE NCC, the RIPE NCC membership. I mean, we certainly have seen that those are necessarily not aligned completely. Community leadership, the RIPE NCC executive board. So this is a collaboration between those entities, sort of flying in sort of a loose formation in a collaborative compact. What is a collaborative compact? They are sort of a combination between formal and informal agreements that focus on 4 areas of agreement: how you work together, how you think together, how you work with conflicts, and how you manage your own behavior. In that structure, I like to set the discussion. It's not just about RIPE NCC, it is about the whole picture. Where are we? Where do we want to be? Further introducing this, for lack of other documentation, there's the, that was too fast. The RIPE NCC strategic goals for 2022 to 2026. Support an open, inclusive, you can read this for yourself. What I've tried to extract from this is the objective for the compact as a whole. So not just RIPE NCC, but the whole collaboration. And what I ended up with was we need to enable our community to operate one secure, stable, resilient, global internet. And those are all, I capitalize them because they're all individual qualities. And some of them are intertwined, some of them are completely independent, and some of them are highly debatable. Secure has wildly different meanings for different groups of people, for example. But what do we need for that? In order to get there, we need a trusted, efficient, accurate, and resilient registry. We need an open, inclusive, and engaged RIPE community. And we need insightful, reliable, and timely data about the internet and its operations, for which, in the end, we need a stable organization with robust governance and diverse and competent staff. Now, this is the first point where I'm just going to open it up and see what people have to say about this, which I'm probably going to, depending on how much people are going to run up to a microphone, I'm probably going to let go for 15, 20 minutes. Do we agree with this? Or is this wildly off the mark? And if so, what should it be? Over to our chairs.
Please. Thank you, Remco. Jim Reid, just a random punter off the street representing nobody but myself. I broadly agree with what you put in the previous slides, but one thing I would say about that was in terms of gathering data, I think probably one thing that's important that's been missed from that is impartial or independent, because a lot of data sources are somehow tainted because of the fact they've got a commercial bias or they're trying to pursue a specific agenda. So I would suggest adding impartial as part of one of those data requirements.
That's very, very good. Thank you.
Peter.
Peter Hessler from Zayo. For the most part, we agree with this. And like Jim said, there's probably a few minor things that we can add and tweak, but essentially, I believe you're correct.
Sander? Hi, Sander Stefan as me. Yeah, I agree. I think these there's always wordsmithing to be done, but even after you're finished. But in roughly, yes, I think you got it right.
Tina.
Hi, Tina Morris, AWS, but as with everybody today, I think we're speaking with all of our experience in the RIPE community. First, I want to say this organization has changed dramatically from its inception, as you've noted, but also point out that you are now managing assets worth billions and billions of dollars. And that brings an entirely different demographic to paying attention. And that means this organization has to scale appropriately. Also, you can't treat RIPE services as a la carte. There are critical network infrastructures like RPKI that cannot be optional. And you have to support those things. Atlas, things like that are used by so many services, and you can't just pick and choose as a customer which one you're going to use. That billing model doesn't work. Also, your strategic goals, for the record, are more like operational guidelines. They're not goals. Goals are specific, achievable, time-bound, measurable, and communicated to the community. There's no way for us to see them or see what's being done specifically to organize this. And I'll save my rest for the next section.
That's much appreciated.
Thank you.
And,
Sergey, then Daniel, then Tobias.
Sergey Masaydov, Network Group RIPE NCC member. Looking at the goals here on the screen, I would like to have more better understanding of where are we in this list, considering this is work items. So do we have a trusted registry now? Do we have an efficient registry? Do we have a accurate registry now? Unless I will hear the answer, I cannot predict or propose the stable future for the RIPE NCC. Does the board consider that we have enough trusted and efficient registry now?
I mean, I'm not here standing on behalf of the board, so you'd have to ask the board that. But I think that, and there's a lot of devil in the detail here. All of these qualities are, in a sense, subjective. So it's really about what do you consider trusted? What do you consider efficient?
Not just me, actually, everybody here in this room.
No, but everyone has their own subjective views on that. So if you disagree with this statement, I mean, this is an ambition. This is what we want to have, right? If you don't think we have it right now, then there is work to be done. This is not about now. This is what we want to aspire, what we want to get to. So if you want clarification on that, then I think having more clarification on this, and I'll accept input from everyone here. That's why I'm standing here.
With this, I can only say that I like the goal.
Okay, that's something.
Daniel.
Hi, Daniel Kahnberg. I have some history with RIPE and the RIPE NCC. I'm currently an employee of the RIPE NCC, actually the longest serving one. To continue a little bit about what Jim Reed said, I think if you look at the bottom line there, I'm missing elements of neutrality, as Jim said, and trust in the organization. I think the immense success we have had in the past building all this up is because we trusted each other, and we consciously worked on establishing and maintaining trust and faith in the community, with the community, and the NCC always strives to do that. And I think if you describe the organization, there needs to be an element of that in there. I don't want to be wordsmithing right now, but I think that's very, very essential, including, and that also speaks to the neutrality.
So a quick comment to that. I take your comments to heart. This is about the whole structure. This is not specifically about the NCC as an administrator. We'll get to that next.
Both. And I think, and I think, so I disagree a little bit. I think yes, it's about the whole thing, but especially the organization that does the operational bit needs to be trustworthy and needs to be trusted and needs to be constantly reassure itself that it has the trust of the community. And that's why I missed that word.
Okay.
Thank you.
Thank you.
Tobias?
So Tobias Wiebig, Max Planck Institute for Informatics, speaking for myself. I would like to pick on the point of goals. Goals generally have the tendency of going somewhere and developing somewhere. I think we need also a very strong emphasis on maintaining, on catering, and on keeping this environment alive and there. The question is, do we really need a goal to get somewhere, or do we just have to make sure that what we have is not destroyed?
Absolutely. And I think that if the outcome of this whole thing is that we're perfect as we are, or there's no major steps needed, then that's a perfect outcome as well, right?
Sander. Hi, Sander Stefan again. I was thinking like it's easy to go like, yes, I agree with what's here, but then I was thinking like, what's not there? What am I missing something? And I actually realized that there is more that is being done. Like the RIPE NCC represents this community in communications with governments, in other fora, and shouldn't that also be part of the requirements?
Well, this is so again. This is and I understand that this is a bit of an odd one because I'm trying to establish our collaborative goals here.
Yeah,
and the NCC as sort of the administrative or executive arm of that, of course, will have to do things representing this wider group.
Yeah, but looking at the sentence, says enable the community operate one secure, etc. internet. Is having good representation in these forums a requirement for that? And I think it is.
Oh, that's good feedback.
Yeah.
Neil O'Reilly. I'm vice chair of RIPE, and I'm also a long-time participant in RIPE. And one of the things that I think needs to be made explicit here is what values we want to base the realization of these specific objectives on. And that may be in one of your later slides. I have to say that although I've had the chance to review them, I don't recall whether that's made explicit. But we need to ground all of this in the values that are shared across the collection of existing stakeholders and which we would want to share with new stakeholders that we may have to engage.
Thank you.
Yep, Wolfgang Zenker.de, speaking for myself. As someone mentioned, the RIPE and the RIPE NCC is now managing assets worth a lot of money, and that will undoubtedly lead to people acting in bad faith, trying to influence the community. And currently, I'm not sure how we manage to stay open, inclusive, engaged, and a trustful community, while at the same time keeping bad faith actors out of. So just a point to think about.
That is an excellent point.
So Tobias Siebig, MPI Informatics for myself again. Just to clarify, I don't mean that we have to preserve the organization as is. I mean that we have to preserve what we have, the open internet. And I'm also not closing my eyes towards the reality of these values being attributed to IP addresses, where we IPv6 said they're not considered property. And I think the organization may have to change to preserve that. But the goal should not be something where we go somewhere, where we develop, but where we focus on preserving our open internet. Because if we destroy it in the face of money, it's gone. We can't buy it back.
Yeah.
Okay, it's 20 past. How long do you want this part to go?
We have 3 more people at the mics. I think we should let them have a go.
Okay.
Yeah. So after that, we will close the queue.
Thank you. Gil Falsinius speaking for myself. I wanted to pick up on something that was one of the kind of missing pieces was the whole speaking on behalf of us, which is so important right now because there is that ugly thing called internet governance. We used to run the network, we used to do it the way we wanted. Those days are long gone. And now the decisions about how the network should be done are done at a completely different level. And there's huge vacuum there where people need to be there talking for the technical community. And I think we have a very strong role in that.
Thank you.
I'm Pavel. I'm a candidate for RIPE NCC board. I would like to add my small contribution to these goals. Of course, it's documented in articles of association of RIPE NCC that we are association. And purpose of association is to explain and deliver what members of this association want. It may be excessive, but my point that we need as very first goal to reflect and help and implement what members want. It should be as very first, I would say, main point, and then everything else, because all the time we need to keep in mind what challenge we have. So just mentioned governance, regulation, financial risks. And I think we need to look, when we look at goals of our association, we need to look all the time. First, its meaning and purpose and interest of members.
Thank you. I think, you're obviously more recent on the Articles of Association than I am, but I think that at least in the spirit, RIPE NCC was set up to support the community and is funded by the members, which were back then called contributors, to make the confusion less obvious. So I think that Yes, there is absolutely a point. And this is actually the exact discrepancy that has crept in, right? And I think that that's something that's one of the reasons why we're here and talking about this. Thank you.
Okay, we are cutting the queue after Paul. So please.
Hi, I'm Marlene with Amazon. I think that having objectives are obviously good, but I think that we don't want to fall under the same problem that happens with other nonprofits, which is you kind of throw out words and not really things to measure. Because, for example, diversity, insightful, trusted, like we need to have, if you're going to put words towards a goal, you need to have a kind of like a baseline definition of what that is. And I think that the community needs to kind of come together to pick those words or what you want them to represent.
Clarify what that means.
Yes.
Absolutely. Thank you.
Anything?
Sorry for interrupting you. Go ahead.
Sure. And then a follow-up to that, once you have your definitions and kind of like a clear goal for your objective, then I would want to see like how you're going to measure up against those goals to see how you're tracking success. But you can't have one without the other.
Yeah, absolutely.
Dimitri.
Thanks, Dmitro Kochmanuk. I feel like I wasn't fine. Be the last before. Well, thank you for bringing this. You said the compact, and of course, I remember the United Nations Global Digital Compact. They're about to pass the agenda. They're going to regulate our internet in their way if we don't do this ourselves. So please keep up the good work. And also, I would say it's not just about RIP NCC. It's about RIR Group, the NRO. We have a problem. We had one specific member of a FRENIC destroying the RIR, and everybody knows how it works. And let's not pretend we are all nice and rosy and the ponies are about to fly to the moon. We have a problem, and it's not our problem, it's externality. And we have lots of black swans headed away. But let me say this, we should start with restoring trust, if we have it a bit shattered, of the organization and of the board. And I'm not saying it's so bad, but I have seen this happening before. I have seen a lot of bad words being said about NCC that, board this, board that. That's actually quite normal. If they don't critique you, they just ignore you. So be happy. But we should also be like a two-way communicators, right? So maybe we should have a task force. So that's my idea, because 1 hour isn't enough. And thank you for starting this new effort. And hopefully it's not take as long as UN usually does.
Thank you.
Paul.
Thanks, Remco. Paul Wilson from APNIC. If I've got the last word, a word that I think is missing is stewardship. I think the registry and the community through the policy process has got a really important role in stewardship of the resources that are critical to internet operation. And what we've been doing collectively over the years is deregulating and taking hands-off stewardship. And I think we're in an environment where, as Tina said, and as people have said, the scale, the value, the pressures are getting higher and higher. And I don't feel that sort of creeping deregulation represents the sort of stewardship that's actually needed. And if we're not collectively able to address that and bring things a bit back towards more active stewardship, then I really think someone else is going to want to do it for us. So I think that's a word that I'd suggest to consider. Thanks.
All right, thank you.
We closed the queue, but we may
this is a
do the
very-
exception for now.
It's Neil O'Reilly, RIPE Vice Chair. A very quick reaction to Dimitro's remark. It's not that we have to do better at self-regulation or the regulators will regulate us in their own particular way. We have to recognize the scope that we have for self-regulation and do a good job of that, and recognize that legislators and regulators are going to legislate and regulate. And we have to recognize the complementarity of competences and engage with and work with people who have different needs to regulate what we have lovingly developed over the years and work with them.
Thank you.
Thank you.
Back to you, Remco.
Thank you. Yes. Well,
I will steal you one water.
So let's move on. Thank you all for your contribution so far. This has been extremely helpful. Structuring RIPE NCC. Now, so if you go back to one of the founding documents of the RIPE NCC in its current structure, RIPE 161, and it's actually available online, and it's a good read. So there were criteria for RIPE NCC as an organization, and filling in some of the points that Daniel made. Good service, neutral, impartial, non-exclusive, not for profit, with an executive committee which represents the various interests of the contributors, which is the old word for what we now call members. Resistant to hostile takeover or control by any single party. Subject to as little taxation as possible. I'm not sure if I write that down in 2024. Supports the credible function as an industry self-regulation organization. And finally, I felt that was important. There was an organization before RIPE NCC. RIPE NCC was part of RARE, which is now called Terina these days, and had 30 employees when it started. So one of the key things there was that the employee should maintain their contractual and tax rights. Issues and caveats on the current structure. So the current legal structure is based on criteria that were relevant in 1997. The overriding reasons why the structure is what it is right now is because it was cheap and it limited tax exposure. The community policies are enforcing engagement structures on RIPE NCC. They're outdated. There is a whole bunch of policy remnants about how do we do membership, what are PI holders, etc. We have some constraints in how we can organize ourselves. There's actually 2 external documents that describe what RARs in terms of internet registries at least should look like, described in RFC 7020. In case you weren't up to date with that, this is the new version of RFC 2050. I had to look that up as well. And the ICP2 document, which is currently under review again. And Athena from RIPE NCC did an article about that last month. Also, the focus has very much shifted from resource distribution to registry accuracy and compliance. No further explanation needed. We have the 20 billion in assets that we're apparently managing. And the current membership structure not really allows room for growth anymore. For the first time, the number of paying members is actually decreasing. So with that, the next question to the room would be, so what criteria should a restructured RIPE NCC meet? I'm not talking about full-blown solutions. Let's talk about the criteria, because we'll get to solutions eventually. But let's talk about that list of criteria.
I see Curtis going to the mic. Oh, Daniel was faster.
No, it's okay. Curtis can go ahead. I was just in case nobody stood up.
Okay.
I was trying to walk as slow as possible so Daniel will make it first, but
Okay.
Somebody please start.
Okay, I'll take it. Thank you for putting that back up. I think. No, hang on. Is that the one? There was the one about democratic and.
In the original RIPE 161 document.
Yeah. Yes.
Yeah.
Can
I think you were one of the co-authors of that one, weren't you?
I don't remember. I will not.
This one.
I can neither confirm nor deny. Yeah. Basically, I think we chose an association as a structure because we wanted the democratic content of an association, and I think that's a requirement. The resistance to hostile takeover and control by any single party is something that we should still have. The last but one is to support the credible function as an industry self-regulation organization is also essential. And good service and neutrality and impartiality I already talked about, and these are the mother and apple pie of the RIPE NCC. So and why for profit? Yeah. So you have a lot of stuff already there. Whether we want to be cheap in terms of paying taxes, I think that's something we should discuss, because the question is, at the time, this was put in because there was discussion in the membership why they should be paying Dutch taxes if they were not Dutch. Yeah. And we should check whether that still holds. Thank you.
Curtis. Hi, Curtis Lindquist. So I was trying to put my finger on this on your previous topic because it actually touches on this. You had the word, I think it was called robust governance, right?
Yeah.
I think it was the word you used. Now, robust is not the same as good. There are two different things, right?
Exactly.
And
fine, fair.
Yeah, and I like to highlight that because it is no. But in all seriousness, I think one of the things that comes back probably more in RIPE NCC structure, and it comes back into the overarching part, is actually governance, right? Now, the point was made earlier that the expectations on RIPE and the assets that RIPE distributes today is not the same as when 25 people got together and formed RIPE NCC, right? And I think we had to acknowledge that. And while we all would like the RIPE and RIPE NCC to have the same expectations as in 1991, that's just not the case, right? And we need to acknowledge that, and we need to understand that we are no longer the little association in the corner trying to avoid Dutch tax. And we might want to keep that in there, right? But I think that the reality is that there is much more expectations of a quite large organization who has quite large assets and who probably would be expected by most of its members to be run in a very different way. Whether that is really what we want is probably up for discussion. But I feel that a lot of the things that you mentioned in the previous thing, like the previous topic, like trust, actually comes from that governance, right? Do we actually believe that this is good governance? Do we believe that that yields robust governance and therefore trust and all the other things? And I think that comes back to some of the points here about the structure is, if you start from the topic is, how do we want this to be governed? How do we actually want to control this? Because that's such a fundamental question you're asking.
Absolutely.
Okay, Pavel. Pavel, candidate for RIPE NCC board. Honestly, when word restructurize used about RIPE NCC, it scares me. I spent last months in reading thousands of pages how articles of association work, how board works, how RIPE NCC itself works, how we govern ourselves, what is the difference between RIPE and RIPE NCC. And I believe on papers, it's absolutely great foundation. We of course have some gaps in implementation, but foundation is here. And honestly, personally, I don't see that we need any significant changes. We need to do we need to find out where we have suboptimalities to address them and move forward. By making large changes, I'm an engineer. There is a high chance to break system. Thank you.
Thank you.
So Tobias Fiebig, Max Planck Institute for Informatics, speaking for myself. I would like to reiterate the point from RIPE 85 I made about digital sovereignty. And I think that that is a very important point we have to be robust against. At the moment, nation states see this internet thing and they believe they can, make sure that their rules are enforced on their constituents. We have to preserve the bottom-up self-governance of the internet, and our structure must support that. And that is one of the very big fights, which is a bit different than the defense against being taken over by a single actor. We basically try to be not taken over by a lot of somewhat headless, sometimes confused, but definitely disagreeing nation-state actors, and all of them, for example, in the EU, but also beyond.
Absolutely.
Okay, we are nearly 40 past. How long you want to go?
Let's, I mean,
and we
a
have
couple
Randy
more.
Bush in the queue.
Yeah, we have
fine.
We have time.
We have
okay,
time. We have
all
time.
good.
Don't worry.
So Jim, then Peter, and Cynthia.
Yeah, Jim Reid speaking for myself yet again. I probably think that the current structure of the NCC being incorporated, for some loose definition of incorporation in the Netherlands as a non-profit, is probably good enough. I can't see us being able to find something different from that, but it's worthwhile having a look to see if we incorporate, say, in Luxembourg or whatever, maybe it might be better for us. I don't know, but it's certainly worth having that conversation. But I think the issue is then about the current structure is going to be then about how is that structure actually implemented, how we elect board members and what the operations of the NCC are going to be. That's maybe where the discussions would really start to concentrate on. And you touched on this before, Remco, when you mentioned that the revenue is maybe starting to decline because the membership numbers are coming down. So part of this review, in my view, is then going to be to look at the activities the NCC is doing and trying to prioritise or partition them into certain strands. What's the stuff that's really, really, really important? What the stuff is nice to have? What stuff is optional? And if we then have to get into the situation of reducing services or cutting services, we've got an understanding about where we can apply the axe and where other things could be trimmed to try and get them to fit within the budget expectations that are available. And obviously there have to be some conversations around that. But I think the idea we can just have the NCC keep growing and growing and growing is no longer the case. And that's something I think that you were hinting at earlier. Maybe I've just made it more explicit by saying that.
Well, I mean, thanks for that statement. Indeed, that the goal of the NCC is not to grow into the sky. Rather, we need to, of course, look at what kind of activities we do right now. At the same time, and I've no doubt that at the next general meeting and the next RIPE meeting, there will be an extensive and lively discussion about the activity plan and budget for 2025. At the same time, I do think that if we're thinking about sort of the wider setup and the wider structure, the things that are critical and optional might shift. So in that sense, I'm also hesitant to start cutting right now into things that might be the 2 years down the line, we might actually think, oh, actually, that was kind of important.
Yeah, I wasn't suggesting radical action like that, but Remco, but just first of all, having a first stab at trying to identify where things might fit, see if we get some kind of consensus view around those ideas. But of course, they're subject to change because the circumstances are going to change anyway.
Absolutely. Thank you.
Peter Hessler, speaking for myself. Tina made a very good point earlier that we are responsible in some part for billions and billions in assets. However, I think that whatever structure we do end up with, that we need to make sure that we're not a marketplace. We're not in the business of selling IPs.
No.
And that there may be some interest in turning RIPE into that, but we need to resist it because that's not fundamental to what we want RIPE to be.
Thank you.
Cynthia?
Cynthia
Revström, speaking for myself. I agree with Peter and many of the other people who have already spoken up. I think the fundamental structure that we currently have is quite good. The fact that the RIPE NCC is located in the Netherlands, which has the association as like a legal concept, helps a lot in making it resilient, unlike in some other rares where they have to kind of like hack it together from other legal structures. So I don't think changing the core structure I don't think we'd really gain anything from that. So I think it's more about if changing anything, it's changing much smaller details. Yeah. I guess just that. I think the fundamentals are all already there, and I can't see any reason to change them. Thank you.
Thank you.
Can you switch Randy on?
Randy Bush from IIJ Research and Arcus. As I'm not an officer of either corporation, I am speaking for myself, but we're supposed to state our affiliations. Please do so. I, as much as anybody, wish the 90s were still here, but they're not. And unfortunately, I read the newspapers. And I think we have a little fantasy here about trust. Trust is gone. It's hard enough to find facts, right? So I think we have to realize that we're going to work in a rather untrusting environment among ourselves and between the network operators and civil society. And I think that's just life in the big city. I don't like it. Take me back to the 90s, please.
Right there with you, Randy. Thank you.
Blake?
Tina was first.
Then?
Tina. Oh, sorry. Tina Morris, AWS, again, speaking for myself, though. First of all, RIPE NCC and RIPE community, I understand the difference. I understand why they were created that way, but I'm not convinced it needs to stay separate or that it's really anything but a construct at this point. Speaking about the board for a moment, we need strong leadership in board and staff. They need to understand their roles in good governance, and the board needs to be focused on strategic goals, high-level issues, and governance. They need to be noses in, fingers out, as a good board member should be. The board needs to trust the staff to implement plans and spend the approved budget on planned approved activities. And overall, both entities need to remember consensus does not mean unanimous in all matters. Sometimes we need to just move forward. We need board members with executive experience, security, financial, legal, sanctions, etc. We need to look for our colleagues in our companies and in our community, not necessarily in this room alone. Not to say we don't need engineers, but we don't need all engineers. Everybody on our board would benefit from nonprofit board governance training. And if you can't get these skill sets, the board should consider board advisors. Looking at trying to get candidates for this cycle, there was a statement on the website that said time commitment for board duties was impossible to measure. Impossible. That is really disappointing. You have board members that you could have pulled. Obviously, it's a variable amount for various roles. But you also have enormous staff. Leverage them to do their jobs, to prepare board materials. Take the load off of your volunteers that don't get paid anything. I tried to recruit several people for these slots. I had really great people. They all said flat out no. Not even, oh, I'll think about it for a couple of days. It was pretty much an F no. And it was because of RIPE's current status, the time commitment, the fiduciary responsibility, and the personal risk. And none of them wanted anything to do with it.
+1, I guess.
Blake. Thanks. Blake with Zayo, and also actually representing about 5 other LIRs, just with other stuff that I do. I've got a big stack of stuff here, but I want to try to summarize some little pieces of it and not blurb it out in one big blob. The first thing I wanted to mention was, I think it's worth maybe going back and defining what the community actually means and like what an org actually is and what a member actually is and what do we mean by that. You know, like one company can have, you know, I mean, I'm here representing like 6 LIRs, right, that I actually have a vote for, but does that, you know, does that make me larger than like a national telecom? Well, actually, maybe, you know, I think that's worth having a relook in terms of just like the fundamental architecture of how, you know, that trickles down to everything, right? It trickles down to how many votes you get and what fees you pay and all of that, right? The second thing was from a once you maybe get a crisper definition of what the community actually is, it might make sense to have like a bit more, let's say, community representation. I mean, obviously we have the board. The board is elected by the community, right? But it might make sense to have some kind of a community council or something a bit more informal, that's a bit more participatory with input for the members, or maybe just extend. I mean, obviously the board is already doing a ton of outreach and all of that, and that's really good and important. But I feel like maybe there are folks or even like chunks of the services region, right, that maybe feel a little bit less represented or something like that. I mean, you can't represent, you know, however many dozens of countries it is with 7 board members, right? That's just not going to happen. So that's, I guess, a pretty good summary of the first chunk of stuff I had. Other than that, I think that from a corporation point of view, it might make sense to look at the different options like a Societas Cooperativa Europea, a public benefit corporation, Societas Europea, B Corp. You know, there's a bunch of different financial governance structures and so forth out there that didn't exist in 1997, right? That might be more appropriate for organization like the RIPE NCC without going full blown, you know, 3 cheers for corporate, whatever. All right, thanks.
Very good, thank you.
Okay, next is over here, and we will cut the queue for now.
After Dmitry. Dmitry is the last.
Caitlin with Amazon Web Services. So I just wanted to address the line, the focus has shifted from resource distribution to registry accuracy and compliance. While I do agree that resource distribution is incredibly important, as everybody's noted, you are responsible for managing quite a bit of resources that are worth quite a bit of money. But I do think that this seems to leave out the fact that you are still also distributing IPv6 resources. So I do find it a little concerning that that was left out of the statement. I would encourage, while I do think that accuracy and all of that is very important, I don't think that we should sacrifice kind of the short to midterm or sacrifice the long-term goal for the short to midterm goal of just managing the accuracy of resources. And I also did just want to point out that, you know, you also talk about compliance, and I do think that compliance needs to sort of be taken almost with a grain of salt. You know, you want to be compliant and you want to encourage your members to be compliant with your policies. But I do think that there's room for being a little bit more understanding of the community needs and knowing when you're regulating just for the sake of regulating versus actually regulating to keep somebody in compliance.
All right,
Thank you.
I mean, just to be clear, registry accuracy has always been part of what we do. Same as resource distribution. What I wanted to point out here is mostly that while in 1998 or 2000, 2005, the key goal was basically get those IP addresses out there as fast as we could within the set policy. And right now, of course, you're completely right. We're still doing the resource distribution for V6. Which is in a different policy framework than V4 was, certainly back then, you know. So in that sense, the focus and the amount of time that is spent now on registry accuracy and compliance, I mean, I think James Kennedy, the new chief registry officer, wrote an article about that last week, which is actually also points out that registry accuracy is something that actually takes a lot of work.
Please.
Thank you. Malcolm Hutty from Links London Internet Exchange. Remco, could you put the previous slide up, please?
Sure.
When you introduced this with your objective, what looked to me like mission statement, you'd put a lot of careful thought into that in capturing what you believe we all think and support now.
Yeah.
And you got what I view as a really positive reception here. And I think that's a tribute to the amount of thought that went into that. But if we're going to do a structural review, we need to put the same amount of thought into what the current structure really is. This slide that you have in front of us now is a summary of a document that's more than a quarter of a century old.
I know. And
we need to have the same amount of thought that you put into that previous work into analyzing the features and aspects of our current structure before moving to the rather conclusory statements that you have on the following slide.
All right.
For example, one of the clear features of the current structure is the duality between the RIPE community and the RIPE NCC. The RIPE community is an open community anyone can join it. The RIPE NCC is not an open membership. It's large. It's open in the sense that a company membership can be. You've still got to pay a membership fee, and you've got to qualify, and these sorts of things. It's a different kind of thing. Is it still the case that we want the community to be an open community, or actually would the membership model be sufficient? That's the sort of thing that you're going to want to analyze. Yeah. The relationship here is actually where the community really comes first. I know that people will quibble with what I'm about to say, because it's only a simplification, but from a fundamental policy perspective, the community is in charge, and the NCC is a service provider to that community in the sense that it is there to implement policy, and it's the community that decides policy. And that even as far as the RIR functions are concerned, ICP2 instructs it that it's a bottom-up community that must drive it. Do we want to retain these features? If we do, we need to identify them and specify that they need to be part of whatever comes next. And if we want to change some of them, we need to have a serious debate about the implications of doing so, and whether or not changing that is actually justified. Yeah, and there may well be views. I mean, for example, I think I just heard a moment ago a suggestion that actually the notion of open communities kind of past it, and I think there could be, a lively debate around those things. So we need. I don't feel comfortable with working from this slide and then moving on to the next slide as the conclusions of, well, this is based on stuff that's no longer relevant. There's a lot about the way that we work now that could be considered relevant, or maybe people want to change. We need to take that with the seriousness that you gave to the mission statement. Thank you.
Thanks, Malcolm. That was you're actually very accurately describing the next 18 months of this conversation, I think.
Thank you. I'm János Zsakó from IST Nonprofit Kft. Hungary, speaking for myself. I think we have not mentioned enough the services and research which is done at the NCC. And if we look at the activity plan, I think there are a lot of things that we should be proud of. And it would be very bad to try to decrease the number of activities that we do. And I think we have already we have always been proud that the NCC, RIPE NCC, is kind of leader of the other RIRs in the sense of research and service implementation and so on. I think we should keep that in mind and try to keep this approach. And I'm very happy with what the NCC right now does. And I would like to keep at least at this level, if not develop it further. Thank you.
Eric.
Eric Barr speaking for himself. One of the things that I would like to at least give as a suggestion, specifically in the elections, and that's probably part for changes in the Articles of Association, is the number of proxy votes for people registering and doing board grabs. Currently, I don't think there is a limit for how many LARs you can vote with. And as a suggestion, this might actually be something that might be considered.
Absolutely, thank you.
And on the part of contractual relationships, I think we also should have a good discussion about the sponsoring LAR discussions, the situation with that, and specifically what's coming up with the the new regulations and acts that come out of the EU, for instance, and consider that the sponsoring LAR agreements may not be the way forward, and we may actually need to look at a associate membership or something where there are direct contracts with the NCC with sponsoring LAR or PI holders, because this may not be a sustainable model in the future.
Yep.
So on the part where you say we have a declining number of members, I think I disagree with you on that, based on this.
Absolutely. Thank you.
Thank you.
Yes, Robert Carolina. For disclosure purposes, I'm general counsel with ISC, but my comments are my own. One comment which appears to be non-controversial, but I think it's worth emphasizing, is that I'm assuming and I'm very much hoping that the organization will continue its not-for-profit focus. No one seems to be contesting that.
I would hope so, yeah.
I would just point out that if that were to ever change, it would destabilize almost everything good that RIPE can and does do. I would urge you in the strongest terms not to adopt the language of managing assets, particularly billions of dollars worth of assets, because that starts to trigger thoughts about things like portfolio management and optimizing and all sorts of other things. There's a difference between directory maintenance and asset management, I would suggest. I did want to call out, and this is the last thing I'm going to hit. Some others have touched on this. Your presentation spent a lot of time talking about the community needs or the community will or when the community does. What I haven't heard is a clear discussion or a clear focus on, can we identify what we mean by the community? And along a similar line, you talk about the need to be a credible with industry self-regulation. Well, with what industry? Is it clear that you have a definition of the industry that you think is participating? And then I think the hardest question of all then becomes, if you can define the community that you're seeking to organize and represent, and if you can define the industry for which you're seeking credibility as a self-regulator, do those two functions sit comfortably with one another? Are they properly aligned with one another? And do both of those functions align properly with the goals and needs of running a regional internet registry? Is this still a single entity whose interests are fully aligned? And I don't have an answer to that, but I think it's an important question.
And I think to a large extent, that's what we're here to find out. As for the specific community things, I would very gladly refer that to the community plenary to discuss. Who is the community is a good question, I think. In terms of, I take your comments to heart about using words like asset management and so on. Ultimately, we don't get to say what the rest of the world thinks about us. I mean, in my very personal view, I don't think Cogent did the industry a favor by securitizing a large block of IPv4 address space recently, and actually turning it into a securitized asset. So in that sense, we can have hopes and ambitions on what we feel the world should look like. But ultimately, most of the world doesn't really care.
So we're on top of the hour, so please keep it
so
brief.
let's do those two, and then I'm going to propose that we're, as much as everyone is excited to talk about funding, let's move that to the next time we meet or in whatever follow-up next step. So after these two comments, I would like to briefly talk about potential next steps after this, and then call it a day. We all have a nice dinner and then a social.
Good idea.
Luhan from Larus Limited. I think Dimitri just mentioned me. I'm the one who take everything to court. Well, I think the biggest paradox we have here is really twofold. The first of all is the increased value of IPv4. The IR was not, it has a casual start. It was not designed to confront that massive amount of asset value. It was $200 billion today. And on the other hand, we have depleted central free pool, which means we have declined membership numbers. So those two things are conflicted to each other at its core. You have an increasing value of of a directory you are managing, and then you have to reduce your membership fee and operation costs in the same time. So if we go down these routes, at some point, the iron will break. And the solution to the problem is really twofold. Either in this society, we manage massive amount of assets, we go into nation institutions like United Nations, ITU, and all those other things. We go higher up, put more banding, a more complicated governance structure, or we decentralize the whole thing like Bitcoins. It's really two ways to go. We either be more complicated or will be very simple. And the short-term solution of today's membership fee discussion, which is really hitting the RIPE mailing list, or the other governance change and banding put into the election campaign to prevent single-party takeover, while it's all good, despite what happened in the past few years in the corruptions, and at its core, we all realize the IIR today possesses vast amount of power. The registration database is supposed to be voluntarily recognized by each of the participants of the network has been de facto power to actually be able to turn off the internet. And this power, if it stays with the hand of this casually organized organization, it will have some severe impact for the future. National players might take over, and there are other interest parties. The bottom line is, the regional internet registry today, as it's organized, as a casual start, is vulnerable. It's very vulnerable, and it cannot sustain as today's organization structure for not even a very long time. We really need to think hard what to do next. Thank you.
Thank you.
Dmitro.
Oh, yeah, Dmitro Kakhmanyuk, speaking for myself. Wait, good words. And let me just comment that I was not trying to accuse anybody of anything. My point is that any organization that has 20,000 members runs a risk as a company or nonprofit. So I think really have to put a governance reform on the agenda. And also one of the things that I want to mention, since we have an Areas Council member here, we maybe don't know. In Erin, there are two kinds of members, those that do vote and those that don't. You are losing your voting right if you don't vote enough. I don't know if that would help to increase the voting number, but I think it's one of the ideas. I'm not saying that's the right way to do it. And also, I think, again, referring to the previous comment, this idea of the sponsored organizations granted a second-class non-voting membership can be interesting. So yeah, it's okay to have several tiers of members, and each of them would add to the income. And one last question, referring to the legal comment of the legal counsel, I see, if you do start to consider IP, as an intellectual property, there is a whole big can of worms, and we should probably start with starting a trust or regulatory framework, owning these things. You cannot manage things you don't own, and I don't think we own IP addresses, so we should probably go down this road. Okay, I guess we have lots of other topics, but I'm glad we are here, and thank you for holding the ball.
Thank you, Dima.
Thank you. Do we have anything online? Nope.
Good. Ben,
Okay.
wrap up
Back
the
to you.
next steps.
That was extremely useful. Thank you all so much for your contributions there. So we're not going to be talking about this, sadly. Sad trombone. I do want to talk about this briefly. We've had a lot of, I personally think we've had a lot of very excellent feedback, things I missed, different directions to take, different options to take. And we don't do this very often. I mean, the last time we did any of this sort was 1997. So how do we proceed from here? I've had some brief discussions about potentially setting up a community task force. And I think that based on the discussions here today, clarifying the objective and make it measurable and achievable, and all the good stuff, everything the management book says, as well as then sort of hammering out what the criteria are for the structure, as we have it now, as we designed it back in 1997, and what we might need. So I would propose, unless someone has better ideas, that we try to set up a task force. The task force will then actually, try to draft a sort of broader document around these topics to solicit input. And so I don't necessarily want like 200 people sitting on it. I don't think that'd be very productive. Ideas, thoughts?
Yeah, hi, I'm Shane Kerr, IBM, speaking for myself. What kind of task force are you envisioning? A RIPE task force?
Yeah, community.
I'm having just finished a task force. I'm not actually a big fan of that structure.
I take your point. If you have better ideas and suggestions, then please.
So I think you can accomplish a lot of the benefits of a task force without actually using a task force. So the disadvantage of a task force is that it's a closed group of people who basically aren't answerable to anyone. Now, if the outcome is expected to be a set of proposals or something like that, it's probably a bit safer because it will then be discussed by that community. But even in that structure, you're going to be able to set the terms of the discussion in a way that makes it very difficult for wider community to have participation. So I think maybe a better approach would be to maybe not do it as a task force, but you can do similar activities as you have in a task force, having discussions, having working documents and things like that, without having designated members, without having an official structure that way. So that would be my proposal. I know it sounds very half-baked because it's not even half-baked, but that's my ideas.
Thank you. That's valuable feedback. Yes.
So Tobias Siewich, Max Planck Institute for Informatics, again for myself. I would kind of like to echo into the same direction. So when I started dealing with some address policy matters, I was actually informed by, I think, Jan, that in the RIPE community, you first discuss things with the community and then you slowly form towards consensus and then you write documents, which is very diametrically different from what the ITF does, where everyone can write a draft and then agenda bash and then draft bash. It might indeed be good to have a somewhat more open frame with like document length frames where everyone can contribute and where then things can be sifted through, just because the network of people through which consensus would have to be formed before text is produced is so large and diverse that it might be good to first see some clusters emerging.
All right, thank you.
Okay, please keep your comments short and we are closing the queue after Peter. Jim.
Yeah, Jim Reed, speaking for myself yet again. I think we need some kind of organisational structure to look at this in detail and think important thoughts about the future. Whether we call it a task force or whether it comes something else, I frankly don't care. I'm also a little bit concerned with the comment Shane made about having this ongoing community consultation. Clearly the community has to be involved. But if this group, let's say call it a task force, is then going to have to keep coming back to the community to say, what do you think of this? What do you think of that? This exercise will be doomed because we're always very, very slow at making decisions. So if the task force can be left with getting on with doing its work, obviously whatever comes out of that has to be discussed and analysed. But having this sort of ongoing activity while the activity is in place, ongoing scrutiny and consultation, I think we're going to never get to any kind of conclusion. I would also say, Remco, on the formation of this body, I think it's difficult to get the balance right. In some senses, we're going to have to get people who are long-standing members of the community that understand this is how RIPE has been going for a long time. But we also need perspectives from the newer members of the community and also say from the outside as well, with people who are really maybe not all that engaged in the IP and the internet type activities, but can offer perspectives, say, in the legal side of things, regulatory side of things, and have more of a multidisciplinary approach to this. Because I think that's the way we'll try to find somewhere forward who can identify these are the landmines that are just over the horizon, so at least we can figure out how to navigate around them. And that can't be done, I think, purely from within the community itself. So I think we should try to take a broader composition of that. And I would actually go a little bit further than that and say that I think rather than seek for volunteers, obviously volunteers could maybe step forward for this, But I would think maybe the NCC board actually just decides who will be on this body and gets that endorsed by the community, but then leave them to go on with it. If we have an ongoing exercise trying to select these people and get into these complications with conflicts of interest, we're doomed.
Thank you.
Thank you.
Blake with SEO. I think maybe one of the things to do is concentrate on low-hanging fruit, maybe things that could be achieved without necessarily having to organize a task force or some other kind of organization like that. And as a suggestion, going back to my earlier comment about more representation of the historically underrepresented countries and communities in the services region, the RIPE NCC office in Dubai is a really good example of decentralizing things from Amsterdam and making folks there feel like they have someplace more local that they can be serviced from. It also reduces operating costs if you are servicing things from places that are less expensive to hire people than Amsterdam. That's just a first kind of suggestion, that could be done without having to do that. Look into business-friendly environments in places that are underrepresented.
Thank you.
Daniel.
Daniel Kahrenberg, guy with the history, speaking, employed by the RIPE NCC and speaking for himself. The RIPE 161 thing came about by discussing with the community first what the properties of the desired of the structure to be designed should be, and you listed them on that slide. There was a community discussion. It was led by a Staki, and I would recommend to replicate this process. Have one person who is stuck with actually getting community consensus on what the attributes of the structure to be designed should be. Because I think that's a not low-hanging fruit, but that's the first essential step that needs to be done. If I remember correctly, I was not one of the authors of 161 because the Staki was somebody else. And if I remember it correctly, Rob Loxile tried to make me the Staki, and I made one of my employees a Staki. So,
well done.
Just
you.
a suggestion.
Well done, you.
Thank you.
Thank you.
Please.
Hi, Lu Hen from Lars Limited. And I think the ultimate question here, and I agree with the previous gentleman said, the task force is really not a good way forward because we really need to be open to the views of the entire community, not who you think your friends and you think the community is. It's the entire community, the one who actually participate in the internet, and that including network operator, including government, including people like me who lease and sell by sell IP addresses. We're all part of this community. We're all part of this good internet. And everybody's view need to be taken into consideration. And most importantly, we need to understand constraints and the willingness of the wider community contribute to have the RIPE NCC. Because clearly, we as a community don't want to pay more, right? That has been demonstrated pretty clearly in the past few months. So if we don't want to pay more to support even the basic operation of the RIPE NCC, then how you expect the wider community want to actually have a sufficient and sophisticated institution set up to manage such massive asset? I just don't think that's going to happen. So my proposal of solution is really simple, that maybe the RIPE NCC should translate its function instead of have a deciding factor on the registration database, just being the manager of the software of the registration database and leave that power to everybody else, i.e. distributed ledge. Thank you.
I sort of failed to understand what this has to do with next steps, but I take your comments to heart.
Yeah, thank you.
Hi, I'm Marlene with AWS. I guess for me, attending through all of the sessions over the past day or two, I've noticed that we have a lot of really talented researchers that are part of the community, and the way that they've brought about solutions or their thoughts is just taking a practical stance of surveying and using other tools to survey. I don't see why we couldn't do that as a community and put into place some surveys that'll kind of capture the voice of everyone and all the facets, and from there result in either a task force or a working group or something else.
Thank you.
And last but not least, Peter.
Peter Hustler from Zayo, speaking for myself. A frequent criticism that this community has towards regulators and governments, etc., is when they try to work with our community or try to regulate or pass laws, they don't understand what they're doing. And when they do collaborate with us, the community, they often do it at a fairly late stage where our valuable input cannot be necessarily utilized in the best way. And I think that if we are going to look at structure, we have to be aware and admit we are not experts in corporate structure. We don't know what we're doing. And it would be very beneficial to get some experts involved early on who can help advise us on and such as Blake mentioned earlier, maybe there's other alternate corporate forms that could be appropriate. Maybe there's alternate ways of having a membership, maybe it's association, whatever, but getting experts involved who can help clarify what our possibilities are and help us design things in a good and structured way.
Absolutely. Thank you.
Anything online? Nope.
All right. Well, thank you all for sticking in here. We're 18 minutes past the hour, so thank you all for coming in, participating, and my final word is I'm not. I mean, the reason I'm looking at it, I was suggesting a task force is because if you have a full room of people and you all agree that something needs to be done, everyone's going to look at each other and say, yeah, wouldn't it be nice if something got done? And I for one, am not keen to carry this on my own shoulders. So, but we'll take this back, look at the summary of what has been discussed today, and we'll do a follow-up summary at the community plenary on Thursday. And I think at that point, I've conferred with the RIPE chairs as well and RIPE NCC leadership and see how we want to structure any next steps. So thank you all. Have a wonderful evening and see you at the party.